But
Well,
basically says, but there are two things here. I'll actually just screen share this. Wait, can I just screen share? Shit. Can I screen share just this thing? Yeah. Okay, better text readability. So, so in this context, if you can see my screen.
Oh yeah, and I'm streaming too, by the way.
Okay.
Sorry. Okay.
In this context, you're looking at this.
I am.
Just let me know when you're
Wait.
looking at it.
Are you sharing your screen or what? What do you mean
Yeah.
looking at? Oh, I didn't know
Yeah.
that.
So, yeah, are you looking?
Wait, give me a second. I want to switch over to Discord. Yeah. Don't forget to zoom in so I can actually see like.
I'm trying. This
Oh.
page doesn't break. I'm
Okay.
hoping this page doesn't break. Okay, good. So, let's say with this, right? Or actually, let's go with this one. So ESP, the value ESP is a memory address, but at the same time, when I say when I'm calling both of those memory address, I call this a memory address, but I might also be calling this a memory address, or reading from memory actually is what I would say. Reading from ESP, or reading from memory,
Mm-hmm.
the memory address that's stored in ESP. Like I might rewrite that, be a little bit more clear. But when I say something is a memory address, um, I either mean the value itself is a memory address, or you're doing this operator to read from a memory address. That's
I think
why I
about the
have that
value
there.
itself,
So
or
I'll
oh,
be more clear. That one I didn't like the way that I wrote it when I wrote it, and I don't like the way I wrote it right now. So I'll change it.
oh, okay. Let's see.
Okay, that's all I want to show you there. And
Yeah, I think that makes sense now. I immediate.
did I? Whoops. Oh, you know what I should do is probably specify what register is. Oh,
So what makes all these different types of registers special? Because you grouped them. I see they're in
um,
groups EAX, AX, AH, AL.
so they are grouped that way because they kind of have to do with each other. Like they're like related to each other. Within the
Mm-hmm.
groups, they're related to each other. So EAX is a 32-bit register. Actually, I'll screen share this as well because I found a pretty good resource on this if I can find it. So EAX, if you can see this, can you?
Wait, give
I'll
me
zoom
one
in.
second.
Mm-hmm. Yeah, just let me know. Just let me know whenever you're watching my screen.
Yeah, I was like looking at the. I was reading the text in the DM. Okay, now I'm looking.
Okay. So
Hey, store
this here is this whole this would be all 32 bits. This whole thing would be EAX, and then AX would also be 16 of those 32 bits, and then AH would go here and AL will go here. So the thing about the EAX, the EAX register, the AX register, the AH and AL registers is they all are the same. They're all part of the same thing. And that's one thing that has the potential to mess you up if you don't recognize that. If you change the value of AL, you
You're
also
changing
change the value of
Oh
EAX.
wow.
So like if you set
That's crazy.
EAX to 0 and you set AL to say 8, then that sets EAX to 8.
Mm-hmm.
and also sets AX to 8. But it doesn't set AH to 8 because AH is these 8
Part
bits.
of that
These 8
memory of
bits here.
EAX.
Those 8 bits there. This is those 8 bits there. AX is all the gray. The X thing is all the gray, and the EX is all this.
Mm-hmm.
So that's why it's grouped together like that. And then so that's why those ones are grouped together like that. These two are grouped together because this is a 32-bit and this is the 16 of the 32 bits, like the AX thing basically. But these are just other registers as well, similar to these ones.
Oh, it has
Basically,
the same like
you
pattern.
can just use them the same, like that. You can just use them exactly the same. And then these two are very important. They are not just registers that you can just set to whatever you want. Technically, you could. It doesn't stop you from doing it, but you really don't want to, because these ones are the ones that you use to handle stack. And basically, the stack is gonna be where you store your stuff in memory. If you mess up these things, like if you set this thing to 4, or if you set this thing to 4 and set this thing to 7, you might not have a way to find you're pretty much screwed with finding your way back to the stack and getting access to the stuff that your program should have access to. So these ones, I would say for these ones, the only things you should be doing with these is increasing them, decreasing them, or moving the values between them. So like you can set EBP to ESP, set ESP to EBP, increase this by 4, decrease it by 4, or whatever. Just don't set this to something like 7. If you set it to something like 7, you can cause a lot of you can pretty much ruin the rest of your code. It's ruined the ability for you to use memory.
Oh, why would you even want to use them at all then, or change anything about them at all?
Because you need to navigate memory, and because you're gonna need to change them, but you just don't want to set them to like constant stuff or set them to the result of a multiplication or something. Just move them up and down to like go around in memory.
Oh, you use them to like move stuff around, but you're not supposed to use them to like store.
Yeah,
something.
these are basically just memory addresses to an address. They're just addresses to stuff in memory, and you use these as references to read other things in memory.
Oh, that's cool. Okay.
So like here, I read from what's stored at ESP, and ESP is the memory address, and I'm reading a 4-byte integer at the memory address of ESP. So I'm using it as an address here.
Oh, so wait. So even though you wrote ESP, it's using one of those two.
Mm-hmm.
Even though you named it ESP, it's like something. It's one of those two special ones that you said you don't want to like, multiply and stuff in.
I was looking at this and I was like, what is going on in this function?
Oh.
But then I looked at this and I was like, yeah, I didn't finish this code.
Oh, okay.
I started that like years ago and I didn't finish it.
I'm going to make a post to my server because I'm always forgetting to say like, hey, I'm streaming.
Yeah, EBP.
But I remembered.
Yeah. So ESP is the stack pointer and EBP is the base stack pointer. So pretty much like you use ESP. So
oh wait, hold on. Can you wait for a second?
Like, yeah, I'll wait.
Because I'm not. Oh yeah, I'm not like looking at it, so I don't want to miss it. Okay, what are you saying?
So, ESP is the stack pointer and EBP is the base pointer. So pretty much like when you run a function, what you want to do is you want to put this at like the start of the memory of your function, and then this thing is just the top of the stack that you have allocated for or whatever. That's just the top. That this thing changes, so this thing should be changing more often than that.
Whoa. ESP goes at the top, and then what is EBP? What does that do? Or
EBP
base
store at the bottom. So where's my paint?
Yes! Love it when you open up Microsoft Paint.
Shit. This might take me a bit. Actually, why don't I just do this? Yeah, that's good enough. By the way, um, the way things go is actually right to left. It might be a little bit confusing. Um, this is like where the memory for your function would start, and this is where it would end.
Okay.
Something like that. So it's gonna go right to left. If you want to, you wouldn't store things this way. You would store things like you wouldn't store things this way. You would store things the other way.
Okay.
So that way. Um,
Mm-hmm.
so here, this one would be EBP. Ah. So that would be EBP, and then this one would be ESP.
ESP. Uh-huh.
Now, what happens is when you push something onto the stack, which means you add something new here, you get like a new box. What happens here is this moves. It points to that thing.
Whoa.
And if you pop something off the stack, like you get rid of this.
You mean like the actual pop command thing when you're like pop?
Yeah. Yeah,
Like
when you add something to it, when you add something to the list, or when you move something from the list. So here, you move something from the list. Can I just, okay, select, how do I do this? Select, delete. Yeah. And then when you pop something off the stack, when you remove it, this thing moves back. So this one here, this one should change more often than this one. Because
that makes sense because when you yeah.
So this one moves all over the place, but this one should stay in one place for the duration of the function that you're running. There are some other things that you would do to keep track of other things. So like when you call another function, this thing gets pushed onto the stack, and then
wait, which thing?
And then this thing,
which thing?
and this thing you can add to it. So like if you look at this thing here, what I do here
Wait.
is I do sub ESP20. I'm subtracting ESP from 20.
When you were saying this thing, which thing were you talking about? Because there were two things.
Wait, what did I say?
You just said this thing at the very end, like this thing, or something. I'm not sure.
Where's my Memis paint? Maybe I might have been talking about this thing here.
Okay, probably that one.
Maybe. But if you look here, in one of my example functions here, I do sub ESP20. Now ESP, right at that point in the code, is gonna be, nope, that's not right. Is gonna be pointing here, right? Because that's where it was left off on the function that called this function. It's gonna be left off there. That's gonna be ESP. What I'm doing by saying sub ESP20, I'm subtracting 20 for it, is basically I'm saying, give me 20 bytes to work with for this function. That's pretty much what I'm saying. I'm just saying, give me 20 bytes to work with.
Mm-hmm.
And that's something that you want to do on all of your functions. If you can, especially if you can predict how much memory, you always want to know how much memory you're going to need for your function. You don't want it to just be infinite. You want to know exactly how much the upper limit of how much memory you're going to need to allocate. And here it's 20 bytes to run this num to string function.
Why not make it like a lot bigger than you actually need it, so you have more room?
Because I don't need more room.
Oh, but it will still work, right? It doesn't like break it.
Yeah, it would still
it has
work.
Like extra. Mm-hmm.
Yeah, it wouldn't break it, but it would just be stupid to do that because that's like wasted memory.
Mm-hmm.
So what that does here is it basically says, so like if like ESP, let me get rid of this or move this down a bit.
So how much?
Basically, this thing is pointing.
We're still working with the registers, right? This is all
These
registers.
Are registers technically, yeah.
Oh, okay. But in this register seems different, like or whatever this ESP.
It's used for something. they all are registers, but these ones are used. But some of them are used for specific things. Like these ones are used for
Mm-hmm.
specific things. Technically, technically, you could use something else to do all the same. You could use a different register instead of ESP and EBP
Mm-hmm.
to do all the same stuff. But you want to use EBP and ESP, and also if you use the push and pop instruction, it does stuff to ESP, and you can't really change what register it does stuff to.
Yeah.
So
What's the
you want
maximum
to use
size of
ESP.
this? Because you said you can just keep allocating more memory or
However
making
much,
ESP.
however much you have access to. J Doodle has some limit. I don't know what it is, but if you
Oh,
go
so it would
past
depend on
that,
like your computer
I
chip
assume
type.
that's like if you try to read or write past that, then it stops running your code.
Mm-hmm. Gotcha.
So
It's
pretty much
different.
what that line there is doing is basically saying this is already pointing here because that's where it was left off in the previous function. Instead of pointing it there, we want to point it here to the end of our function because that's where we want all of we
All the
want all of
space.
this
No.
all of that space. Yeah, we want all of that space.
Cool. So it's one points to the beginning, one points to the end, which decides how much
Yeah,
space you
yeah,
get.
yeah. 1 point to the beginning, 1 point to the end. Yeah,
Nice.
so that's what that does. And those two are grouped together because they are used in conjunction with each other.
Thank you.
Okay.
Let's see.
All right, that's all. You can switch back over.
Let's see. For each of the following instructions, two parameters: destination source, memory constants. So you said for each of the following instructions. So the instructions are the ones like the JE, JNE, JL, JLE.
Yeah,
Those
those are
instructions.
like this mov,
Move.
add, sub, inc, dec,
Oh, all those
compare,
two.
all those are all instructions.
Okay.
Mol, div, push, pop, call, and ret when I write that eventually.
Mm-hmm.
This
Oh
is
yeah.
also unfinished.
Right.
I have some more stuff that I haven't finished writing here.
Oh, okay.
I'm writing them right now because I forgot to write them before.
Thank you.
Because I got distracted. I blame you.
If they both register, they must be the same size. One of them is a register and the other is not, then it works. Yes. However, they cannot both be memory. Nice. I see you edited that and like made it more clear, that part. I think, or maybe I think so. Move this source, covers by source of this. Destination equals register memory. Yeah, okay. Memory source equals nice add source stores a result. Adds. So when you do this like add one, does it take whatever that number is, and then it only?
It's so you know what the plus plus operator is in C#. Like if you have an int and you do plus plus on it.
Isn't that increment?
Yeah, that's what it is.
Oh.
So that the increment instruction, that's literally all it is.
Add destination.
I assume unless I'm misunderstanding, I think that's what you're talking about. The inc dest instruction.
Oh no, I'm asking about the add destination source.
Add.
Yeah.
Add. So what it does? Sorry. So add, dest comma source. That takes the value in. So basically, that's dest equals dest plus source. So destination equals destination plus source.
Oh, destination plus source. Okay, thank you. Cool. And dest equals.
That's like how you would write that in other languages. Or destination plus equals source.
Mm-hmm. So then the in, that's the increment. Increment destination.
Yeah, inc is increment.
Cool. School. Ah, okay, I'm on the part where you talk about multiplication, where you were deciding, like, oh, should I do the signed or unsigned? I remember you looking at that.
Hmm. Yeah, all those things there, they are specifically for the things on the jump. There's signed versions of the things and unsigned versions.
Mm-hmm.
Because, for example, let's say if is one is -1 less than 1. Well, if it's signed, then -1 is indeed less than 1. But if it's unsigned, then 255 is not less than 1. And they have different ways of handling those two things. They have ways you can handle those two separately. Like you have signed and unsigned versions of the comparison.
Mm-hmm.
Basically, like the above and below versions are for unsigned, and the less than or greater than are for signed.
Wait, say that part again.
The less than or greater than are for signed, and the above or below are for unsigned. With the jump.
Oh, were you?
Jump.
Yeah, and you labeled
Yeah.
them as like signed, unsigned, signed.
Mm-hmm. Yeah.
Cool.
Yeah, for unsigned or signed or unsigned integers.
Why is there like a jump if greater than signed, but not a jump if greater than unsigned version for the same
There
thing?
is. It's above, jump if above, unsigned.
Oh, it's just called jump if above. Like they changed the
Yeah.
word to above.
Yeah.
Hmm.
Some of that's like a little bit weird looking because I think you have the thing on the right open.
What thing on the right?
If you like look at the top where we have like the profile button. If you click on that, it closes the thing on the right that says corrupt converter.
Oh, so it'll be bigger?
Yeah, should be.
Yeah, nice.
Also added a massive like big space at the bottom of that message. So that way there's less other stuff showing.
Oh, cool. It was like for a second, I didn't even realize that. I was like, what? What?
Mm. I mean, I could make it like 1,000 characters if I wanted to, but
Yeah, you just
that's
limited
just
by
1,000 new
Discord's
lines. Mm.
space limit. Oh, you mean like certain? Okay.
I can make it 1,000 lines long of new lines, but I don't need to.
Yeah, it's good.
I actually have a copy paste somewhere almost that's like 1,997 new lines, I think, or it might be 96. I don't know, or
Mm-hmm.
with some number of lines when you paste it, and it's absolutely maximized for the most lines that I can put.
When I saw things in brackets before, they were like you said, they were like labels, but this isn't a label in this case, right? It's like an instruction. Looks like.
That's a memory address. That's reading from a memory address, or in this case, it's setting to a memory address. Storing a value. It's storing the value in source at that memory address.
Oh, okay. Oh, so yeah, this is still a memory. So this value in the memory address determines how big the stack thingy. No,
Yeah. So let me
thingy
see.
is. Cool.
So let me see if
ESP.
I can.
Oh, short 16-bit equivalent to move.
Let's see if I can draw this.
So each each increment is like 8 bits, that's a byte, I
Mm-hmm.
think.
8 bits is a byte. Yeah.
Does not have an 8-bit input according to the docs.
Wait, what are you talking about? Oh, wait, what are you talking about?
Your examples of push source, like moving the
It'll.
ESP thing around.
So I can
Like that's why you
do
have
an
2,
example.
16, and 4 and 32. Because I guess each number is a byte. Like subtracting 2 from ESP is for
That's
16-bit
subtract.
source.
Yeah, that'll subtract 2 byte. That'll pretty much shift it over by 2 bytes. So
Yeah, 2 bytes. 78-bit maximum rating. Okay, pops the value of the stack. Story into destination. Oh wow. Oh, and the way the stack works is like you can like move things off of it and put things onto it from the like you were showing in the drawing.
mhm.
But you can't just like grab things in the middle, can you? And
you
take them off.
you
Like you have to.
can you can.
Oh, okay. You can't.
Like yes, you well
Hmm.
the way it works is what you do is you can read from that if you want to, but you can also read next to that, like to the left or to the right, however much you want. It's like so imagine that it's like let's say like ESP is the start of your array, and or like let's say like ESP is like in the middle of your array, and you want to read that plus something or minus something to read like to the right of it or to the left of it.
Okay. So
You can
assembly is
also
like.
kind you can also kind of think of it like that. Like memory is literally just a giant array, and these values are just
Oh yeah, I was saying.
indices in that giant array.
So assembly is like just a bunch of like a whole line of boxes, and someone walks around and puts numbers in the boxes and like moves them,
Yeah.
shuffles them.
So I'll show. I want to give you an example of that example does with like push and pop,
Push pop.
and I'm showing it right
So if
now.
you can read a value, so basically you're saying like if you can, since you can move around and read values in other boxes that are in the stack, then that means you can also like pop them off too and stuff.
Mhm. Yeah.
Or maybe like insert another box in the middle if you want. Maybe.
Yeah. You can. Well, what you
Or
do is when it comes to in the middle, you don't insert another box in the middle. What you do is you can replace something in the middle, but you can only really add something new
at the
like
end.
to the end
Okay.
or to the end, really just at the end at any end point.
Yep.
So look at what I'm screen sharing.
Yeah, I'm seeing it.
So let's say we're doing pop. We're no, we're pushing SRC. So
Mm-hmm.
let's say SRC source is some it is some 4 byte some 4 byte thing. So
Okay.
let's say
Oh,
it's like
by the way,
this.
this stack that we're talking about, this is the same stack that when they talk about like the stack in C sharp, this is like the same stack though, right? Like the same kind of process.
I think so. Yeah.
Yeah.
I don't like that I can't like arbitrarily zoom here. It's always like fixed points. I don't like that. But you know what? I have a simple solution, right? Okay. So what we have going on here is let's say this whole thing here.
It looks like a little
This
lima
entire
bean.
thing. This entire thing. All these 4 bytes. They're all they're all for source, right? They're all for this value of source. It's a 4 byte number. When you push it onto the stack, what it does is it does this. So we're gonna do this. I'm gonna copy that and put that like here,
Yeah, it drops onto the end.
and actually what it's doing here is it's more like taking like this. I want to get a better copy of that. It's kind of doing this. So it's copying it there, and then what it's doing is it's taking this and moving it over here.
Mm-hmm. This isn't memory, right? This is still register. This whole thing.
This is memory. This is memory.
Oh, this is memory
doing
though.
in memory.
Okay.
Yeah. These
How memory
boxes are
works.
memory.
Okay, cool. So stacks.
Each one of these boxes is 1 byte. Just imagine each one of these boxes is 1 byte.
Mm-hmm.
One index in your array of bytes. So what I just showed you is basically what the push operation does. It copies the value of source over here and then moves this thing 4 over. For when you're doing a 32-bit number. When you're doing 16-bit, it's just 2 boxes and 2 boxes.
Mm-hmm. So when I don't know, are these like numbered? These boxes numbered? Like 0, 1, 2.
So it'd be like
So the old 0 becomes the source. Yeah. Like when it moves onto the stack, how do the numbers change? Shift. Like they move over in like what direction? The old 3, 4.
Yeah, it just copies the numbers over. It just literally just copies the numbers over. It copies it to this point to this location in memory, copies it there, and then moves this number over. Like this original value does not get changed. It just gets copied into memory here.
Yeah. Oh, I mean like when you refer to like the location of where things are. Like what box you want to grab something from. Mm-hmm. Like adding new things onto the stack. How does the numbers change? Is it like a giant array? Like it starts at 0 on the left to like say I want to go here?
Pretty much, yeah. So this would be ESP, and then this over here, this would be ESP plus 4. If you wanted.
Ah, okay. 1, 2, 3.
If you wanted this shitty arrow, this spot.
That's ESP plus 4. Okay.
Yeah, and then over here that would be ESP plus 8. This here would be ESP plus 5.
Wait, does this mean that you're actually you're counting from 1, like first box 1, 2, 3, 4, not 0? Like in some languages.
Well, I just basically just imagine that these are random values. Like let's say this would be 30, 60, 5, 20. It would copy. What I mean is that these are the values of those bytes. It's just example values for the bytes.
Oh yeah, I'm only talking about the plus 4, like to locate which box you want. Like it's not starting from 0, like ESP plus 0, ESP plus 1, ESP plus 2.
Mm-hmm. Yeah, so
like,
our functions are actually going to start over here with a EBP. Let me hold on. Let me get rid of this. Who cares? So so if our function starts here, and what you do is you usually just go based off of EBP. And what you do is, like, let's say I wanted to read this number here. What I would do is I would read a 4-byte number here at EBP. Shitty ass P. At EBP -4. So I'm going 4 to the left. I'll read a 4-byte number from here, and it reads these 4 bytes.
Left EBP -4. Okay.
It reads these 4 bytes. Cool. It reads that number. That's how you would read that number in, like, say, a move instruction or something.
Dude, when you made all the slashes, you just, like, made all the mod things again.
Oh, yeah, true.
Yep. It's beautiful.
They weren't very connected, though, so...
That's okay. They looked good enough for me. EPP -4. Cool.
And usually everything you want to do is based on EBP, unless you specifically want an ESP, which you'll probably encounter that when you like it's not. I'm not saying you must use EBP. You must use ESP in these specific ways, and you must never use the registers for anything else, and you must never set anything else to ESP and EBP other than things. What I'm saying is, if you're gonna do that, you need to know what you're doing and know why you're doing it.
Mm-hmm.
Like, you need to have a reason for doing it. Don't just do it for no reason because like, you don't want to break your code, right?
Yeah, because things can break easily in assembly.
Yeah, things can break easy, and you don't want to cause yourself problems that are going to take you hours to fix later.
Hours, Lord.
Yeah, something as simple as missing one instruction can cost you hours of time if you if it's confusing enough. That happened to me. You know, I speak from experience.
Yeah.
It's like, one of the problems that I had one time was that I pushed something onto the stack and then forgot to pop it back off the stack. Or actually, I didn't forget to pop it back off the stack, but because there was like a conditional jump somewhere, like a sort of if statement thing, it only popped it off the stack in one of those conditions, but not both of them.
Oh, okay.
So on one of those times it would do the right thing, but on the different one of those times it would do the wrong thing.
Okay.
And I ended up getting screwed by that, and it took me forever to
figure out where it was going wrong.
What I did wrong. Once I figured out what I did wrong, it was pretty quick to fix it. But
okay.
Stuff like that. That's why I say this will really help you for like problem solving, because you need to really look deep into it in order to figure out why that doesn't work.
Yeah.
But yeah, like this visual here, I think is a really good visual for understanding like how the memory works. So like this is a 4-byte number, like -2-ish billion to +2 billion, 4 bytes.
Mm-hmm. So when you call a function,
this thing is 0 to 255.
Oh, I wasn't looking for a second. Oh, when you wait a second. Oh my god, I just realized. I don't think I was. Okay. Wait, let me,
Yeah, you weren't showing it on stream.
Oh. Yeah. I didn't even know! No one even said anything. I didn't know.
I thought that you did that intentionally.
I didn't do it intentionally. Oh, that's why you, like, changed the... No, I wasn't doing it intentionally. I thought I was... I thought... I did the thing where it pops out. I didn't realize it wasn't showing. Okay. Yeah. Here, show your beautiful drawing. So I can see it later.
Here's my beautiful drawing.
It's beautiful. No, people didn't. I won't be able to see the blushies and the features, but I remember what it looked like. It was fine. Mm-hmm. But okay, got you.
Yeah, you think they do the blushies using the mod function?
I hope so. I hope so. Now, from now on, I'm gonna think about that. Like, or it's like it's cool that mod... makes the. Like, so that is basically a simple version of how Desmos are as a thing. Like, people figure out what shapes.
I wonder if you would have made the connection of connecting that to the blushies if it wasn't drawing them with red lines. Like, it was drawing them with like black lines.
Probably not. Lines. Yeah, the red lines just really made me think of it. And I was like, oh my god, mod. So, but yeah, blushies. This is cool.
So since the 0 people who are watching right now, that you missed this whole thing that I was going.
They missed the good stuff. That's okay, but the real good stuff. Right, but that's okay. That'll give me an opportunity if people come in and they want to know about it. It'll give me an opportunity to try to reiterate what you said, and then you can
Yeah.
grade. I can be. You're the teacher. I'm the TA, and then you can tell me if I like f it up. My explanation about how the
Does this
memory
make sense?
works. Yeah, and the drawings are like really really good too. Wow, I feel like I just took a. It's so good.
So this is how. This is pretty much. This is basically what you're going to be visualizing the entire time that you're writing an assembly.
In my head, I have to like imagine this
Yeah.
stacks moving and.
You might also, I mean, you could write things. You can write things down like you want, like on some like paper. You write it on paper if you want, or
Yeah,
write it on
probably
like,
helpful.
or write or type it out somewhere or something. But this is pretty much what you're gonna be looking at.
Yeah, numbers
This is what you're gonna be thinking
stored
about.
next to
All
numbers,
like
grabbing numbers.
in this order, like everything's gonna be in that order. Everything's gonna be going from right to left, and you're gonna be reading. You're gonna be thinking about something and reading from that to the right, and that's pretty much all what you're gonna be thinking about in this layout, this whole layout.
Yeah.
And what I was saying before was each one of these boxes is a value from 0 to 255. It's a single byte. Each one of these boxes. Is
Oh yeah, a
byte.
byte can hold 250. Yeah, the 256 or 256 hour clock.
So there are also integer limits that are important. So within 1 byte, you can store from 0 to 255. With it, and that's also negative 128 to 127.
Negative
in 2
128.
bytes, you can store 0 to 65 535.
Oh god. 0.
Which is negative 32 768 to positive 32 767. If you did like Minecraft stuff and you heard of 32Ks, then you'll recognize that number. Like 32K tools. That's something that you recognize the number from.
Dang, that's what they're like referring to, kind of.
Well, 32K tools is when they're talking about 32K tools, basically what it is it's like a sword, or like let's say a sword or something enchanted with the maximum possible value you can enchant something with, which is 32,767, because that's the integer limit for the number type used for enchantments.
Oh my god! Wow. Okay. So maxed out sword.
And then, do you know the 4-byte integer limit?
No, I didn't even know the. Not sure if I would have remembered the 1 byte. I mean, we talked about 255 last time.
You're gonna see that. You're gonna see that so many times. It's gonna be important.
Good.
You're also for one of the problems. Maybe 2 of the problems. I don't know exactly how many of the problems, but you're gonna need to know the integer limit.
Okay, but I didn't know 2, 3, and 4.
You might not need to memorize it. But it's gonna be important to have. Like you can just look it up, like 32-bit integer limit or something, and then you'll find it. That's gonna be important to know. I think for converting an int to a string, you're gonna need to know the integer limit. I think for that, or maybe it's converting from string to int. I don't know.
Oh,
something somewhere in there is going to require you to know the integer limit.
32-bit, you said? Oh, bit. Wait.
32-bit integer limit is going to give you 2 147 483 647.
Oh, that's 4 of those boxes. That's right.
Yeah, and then 4 294 967 295 for unsigned. I have those numbers memorized because I got them. I had to work with them often enough that I just ended up memorizing them.
Mm-hmm. Yeah.
I haven't memorized the 64-bit integer limit though, and I can guess the reason why, because I'd never see it.
Oh yeah.
I rarely ever need to think about it. Anyway, I hope you like my demonstration on whiteboard.
Your demonstration was fantastic. So fantastic. Visuals are so helpful. At least for me, they are. Like, I don't know. I'm bad at like visualizing like math stuff and like how things move around in my head.
Yeah, it's all one giant array. And the thing is, and it's important, everything that you're doing in assembly, like you can think of it as one giant array as long as you recognize that everything you're doing in assembly is using the exact same array.
Mm-hmm.
Like it's all just one giant array, and everything shares that array. They just use different parts of it. And in order for them to use different parts of it correctly, you need to make sure that you don't that you have them set up to use them correctly, which is where the ESP and EBP things come in, is so that way you can section them off kind of and work with specific parts for specific functions.
Mm-hmm.
Assembly.
Oh, hi, Goob. Oh, I didn't. I guess my TCS
Goob
is.
underscore says
Oh,
what we learning.
I wasn't late.
Your
Assembly.
TPS is always that delayed.
Yeah.
Yeah, we're learning assembly. Well, they're learning assembly. I learned the assembly that I'm teaching them.
Mm-hmm.
And before I do any more of that, I need to go take this. I'll be right back.
Okay. I'll just start reading this by myself. Okay, where did I leave off last time? Declaring variables. Initialize data or constants. That's right. Section.bss Explorer. Oh, wait, no. The text section is used for keeping the actual code. This section must begin with the declaration global start, which tells the kernel where the program execution begins. The syntax for declaring text section is section.text global start. Assembly language comment. Begins with a semicolon. It may contain any printable character, including blank. It can appear on a line by itself, like this program displays a message on the screen, or on the same line along with an instruction like add EAX EBX. Adds EBX to EAX. Oh yeah, add the destination source. Wait, let me look at my thing. Oh yeah, destination source. Assembly language statements. Assembly language programs consist of 3 types of statements: executable instructions or instructions. Oh wait, I read these before. Syntax of assembly language statements. Assembly language statements are entered 1 statement per line. Each statement follows the following format: label, mnemonic, operands, comments. The fields in the square brackets are optional. Mnemonic. A basic instruction has 2 parts. The first one is the name of the instruction, or the mnemonic, which is to be executed, and the second are the operands, or the parameters of the command. Following are some examples of typical assembly language statements. Count. Increment the memory variable count. Move total 48. Transfer the value 48 in the memory variable total. So this label is an instruction, I guess. Add AHBH. Add the content of the BH register into the AH register. And mask 128. Perform AND operation on the variable mask 1 and 128. Let's see. What is AND? Is that on the list? Add marks 10. Add 10 to the variable marks. Move AL 10. Transfer the value to the AL register. The Hello World programming assembly. The following assembly language code displays a string Hello World on the screen. Live demo. I kind of don't want to use it then. Wait, I wonder if I can copy and paste this into JDoodle. What do I have? Section.text.
I'm back.
Yo. I'm not sure if I can like copy this and have
I
this
should
work.
add to the tasks. I should add to the tasks that you need to you need to optimize the
Uh-huh.
you need to fix the problems with the assembly that JDoodle gives you by default for that.
Okay. I think I can I delete this? Oh wait, I don't know. I don't want to. I should probably like delete this thing at the bottom because this was for the old one. I don't know if this will run.
It'll run.
It will.
Yeah,
Hello
it'll
world.
run.
Wow. Okay, that's awesome. Let's see.
Mhm.
Must be declared for. Is this being covered? Let's look at this one. Linker LD. Okay.
So I want to try something. I wish I could type
Start.
I wish I could type in your window, but
Yeah, someone needs to make
there's
like a coding thing where two people. Is there something that exists where two people can
J,
code at the same time?
I think JDoodle has that,
Are you serious?
but you might need. But I wonder if you need to be signed in order to do it.
If we can do it at the same time, it's worth. I'll make an account, but that's a cool feature. We do. You've never used it before, I guess.
Fucking button. I have used it before.
Oh.
What fucking button is to do this thing? Like, I don't like this UI that they have here. I can't figure out what any of these buttons
Oh
do.
yeah, I know you hate that they
I
did
don't
that.
like that I have to, what is going on here? Wait, is this wrong? Oh, well.
Start.
I can't figure out what any of these buttons do because I need to click on them. Is this the button?
Linker entry point. Move EDX len.
Oh, no, I can just, no, wait, we can do this right now, actually. No, I don't need to be signed in.
No way.
You don't need to be signed in, I mean.
I don't. Oh, you're gonna send me a link?
So, if you look on
business
the,
lane.
on the left side there, there's like a video icon thing. Or one of the buttons on the left there. You have to zoom out, maybe.
Oh yeah.
The fourth one.
Oh yeah, there's video icon thing. Oh, it's cute. It's called Together JS.
Mm-hmm.
That's cute. Oh, can I invite you?
Yeah, send that link to me.
Oh.
Where's my mouse?
Oh my god, you know what? Now that I know this is a feature, like from now on, if people are trying to help me while I'm like coding, and I didn't know about this in Exorcism, I can actually invite them to a JDoodle with me.
Yeah. Good thing I have that thing. See, that's the misclick.
Here, type something. Does it work in real time? Like, can you see this?
I gotta open it. I gotta open it.
Oh, okay, I'm sad.
I have to open it. I'm required to open it. I must open it.
You must open it. Open it now. Right now. Right now. Open it.
I'm doing it. I'm doing the thing.
Okay. You can do it.
I'm doing the thing. I'm not signed in. Yeah, join. Select all images of boats. That's not a boat. Why did I click on that? I clicked on the fucking bus. Okay. Yes. Yeah, I'm ready. Can I log in? Okay.
Look, when you click, you create like a circle thing that shows what you're like pointing to. Isn't that cool? Wait, type something so I can see how like laggy it is. Like here, respond to my hello at the bottom. I want to see what it like looks like when you type.
That's just not okay.
What are you? Your name is Observant Owl. Oh, I can see you doing stuff. We're writing good code right now.
I think every time you do something, it actually like moves my cursor.
Wait, if I move down, you get moved. Wait, what happens if I to move your cursor? Wait, I am reading this thing about like how this works. Message lane move EX. Oh wow. Move Message ECX.
Let's see if I still remember how to code in assembly.
Let's see if you do.
Yep, I still remember how to do this.
And you wrote this really fast.
This code here is another hello world. But it's doing it using... And I can actually draw this out for you. I could draw this out for you on what exactly this code is
I would
doing.
love it. I love your drawings. I would love if you could draw it.
Am I still screen sharing? I am. Okay. Where's my MS Paint?
Sick.
Okay, so...
Sick. Oh my god, and I just discovered a new tool. Like, this is amazing. See? Every time I stream, it's like a new adventure. Discover something new. Wait, I have to close this stupid cookie thing. Go away. Stop my message right. So you wrote like another version of Hello World, right? It just like both are Hello World. That's so cool.
Yeah, both are Hello World. Yeah.
It's super cool. Move EPX1. Fire descriptor standout. System call number. System right. Oh yeah, this is like. Call kernel. I know what INT stands for.
Interrupt.
Oh yeah, you did say that. Interrupt. I see INT. I always think integer, but it's like messing with me. Nope. Interrupt. Move EAX1 system call number system exit. So are like EAX and EBX only used for like these kinds of instructions like system call numbers and file descriptors?
No, they are general purpose registers that you use for
for any number.
You use those for basic for pretty much every operation. Like you'll use those for doing like math or stuff.
Yeah,
you'll use those for operating with strings. You'll use them for everything.
Dang, okay. Hello world.
That's the whole like general purpose thing about them is that they're used for everything.
Mhm. What is this? Is this like the length of the string or something?
The len. No, wait,
I mean down here 0xa.
What is 0xa?
Oh wait, no, this is like
it's an extra byte that they're adding to the end of the string, and I'm not entirely sure why.
Oh, okay. But it is an extra byte. It's good to know what it is, though.
Well, it's definitely not the length. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. It's definitely not the length of the string. This is the length of the string.
Yeah, this one here.
Can you see what I highlight?
Discord?
Can you see what I highlight inside of the JDougal thing?
No, you have to click on like what you're touching.
Okay, so if I select everything here, you can't see that I'm highlighting.
No, I can't.
Okay, now that's inconvenient. But whatever. So, yeah, so that.
Do you see my cursor move around? Just like I see your cursor moving.
Yep, I see yours.
Whoa.
Your name on here is Friendly Fox.
Aw, you're observant owl. It fits you. You're very observant.
I'm
owl. I like Friendly Fox. That's cute. Squid. Now you're Squid. How did you're Squid now?
Me says 07.
Up me.
Who's 07? Oh, up me.
Up me. Yep.
So
you're Squid.
Let's do this this MS Paint.
Yeah, let's go. Wait, give me a second to like move over there though. Okay. Switch.
So, okay.
Oh wait, wrong thing. Damn it. There we go.
Okay, so what we've got going on here is like let's just say this is like where we're starting. Like this is just whatever memory stuff, we don't care about it. But ESP just like, let's say it starts here. Now if we look at the code that I wrote over here, push RLD exclamation point. So what you can think about that as is it's like let's say I'm taking this here. I have a lot of these, and in it I'm gonna write in that order. I'm gonna do R L D exclamation point.
Whoa.
And then I'm gonna take that.
RLD.
I'm gonna take that, and I'm going to move it over here.
Ooh.
Now the next instruction is doing. Do I have enough space for this? If I don't have enough space, I'll move it. The next instruction is doing the same thing, but instead of RLD, it's O space WO. So I already showed you what I'm doing. Like I just hope to make sense why that went there, and also this ESP would move to the left. I'll do that after.
Yeah. Well, that's why it was written out like with Earl at the first. Like you wrote it in that order. That's so.
Yeah.
That's cool.
So now when I select this,
hello world.
I move this over here. You can kind of already see where we're going with this. And then I'm going to select this last one.
This is like watching a Khan Academy video, except I don't feel bored.
And this one is going to be hell.
Hell! Hello!
So now we have hello world written out in memory. And then ESP, now, because after all that, this thing points all the way to the side over here. Points all the way over here.
Automatically? You don't have to move it?
Well, it moved by 4 every time I did a push. But I didn't move it in the drawing, but it moved by 4 on each of these pushes.
Yeah, so it moves by itself.
By the end of it, it pointed here.
Cool. That's what that.
So EAX4, EVX1 is setting out for printout. Move ECX ESP. So what I'm doing is I'm setting. So I have EAX. Whoops, that's not draw tool. So EAX. My shitty ass handwriting equals 1.
Don't worry, it's not as bad as mine. 4. Yes.
EBX equals 1. And then ECX.
You cross your X's in the opposite order I do.
Equals ESP. So what this means, I'm setting ECX to ESP, which means now ECX also points here. Because I set it to be equal to ESP. And ESP points there, so now ECX also points there.
Okay.
And then EDX equals 12. And then when I do the int ADH, int 0x80, what this does is it runs the printout. So if we do this, so starting from here, what are we doing? We're going to start from here, and we're going to print out 12 characters from here. So it'll print out H, E, L, L, O, and I just keep drawing these arrows. So it'll print out each of these. And how many, and when do we stop? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
13? Or
So
is it 12?
from here, we printed out 12 characters, and that is the entire hello world string that I pushed onto the stack.
Uh-huh.
So that's what the code that I wrote does. That makes sense?
Yeah. Oh, notice like too, one of the things that are similar between yours and the other Hello World was you both had EAX at the 4, EBX 1.
Yeah, you have to do that in order to print out.
Okay.
Those are so pretty much like int ADH is like it's like a function, and parameters. So there's 4 parameters of a function. The EAX and EBX, it's like EAX tells it what to do, and EBX is another parameter. It tells it so EAX set to 4 tells it to print out to like console or something.
Uh-huh.
EBX to 1 says where to print it out, which is in here. It's this console. And then ECX tells it where is the start of the string that it's printing out. So
ECX, that's why you copied
ECX,
ESP
ECX
to
right
ECX.
Yeah, so ECX is now right there.
So you could tell it where to start.
And EDX is the length of the string. Well, the length of the string is 12. 4 plus 4 plus 4.
Oh my god, the thing I just learned from this is like those registers, like the register names, like EAX and stuff, you use them sometimes. Like when you make a interrupt or like tell the system you want to do something, then those for a function, then those become the parameters.
Yeah.
That go in. That's whoa.
It's cool now. It's gonna be inconvenient later on.
Oh, I know it's gonna be inconvenient because like I'm not just gonna know like because 4 and it needs to be 4 and 1.
It's gonna be inconvenient later on because every time that you want to like read from input or print to output, you're pretty much gonna have to like destroy all the values that you have saved in the A, B, C, and D register, and just like push them onto the stack and then pop them off later
to use again. Oh,
you don't lose the numbers that you had before.
Yay.
So yeah, so this example makes sense. Well, this graphical as visual representation of what my code does.
Yeah, it's really good. Cool. And I actually was like sharing the right thing this time, so people actually have to see you draw. Finally.
Yeah. Yeah, and you can see where all the pushes push to here. Where I have all these like red lines.
Red lines. Oh, whoever followed, thank you. See, they followed you because your art was so good. You got me another follow.
They followed you, they didn't follow me.
No, but I mean, you were making content though, for me on my behalf. This is very, very cool. Okay, I'm gonna switch back to sharing the. Wait, let's see, web browser. Oh my god. Yeah, properties. What we're looking at. Oh, this is awesome. Hope you don't like crash our page by like making so many circles that like everything like goes crazy.
Well, let's see if I can do that.
Oh, I shouldn't have said that.
Oh, it's getting laggy. It's lagging.
Okay, maybe maybe you should just kidding. That's just DB. Hello world. Oh yeah, string length string. When the above code is compiled and executed, it produces the following result. Hello world. Nice. Compiling and linking an assembly program in NASM. Make sure you've set the path of NASM and ILD.
I don't think we need this.
ID.
I don't think we need this because we're doing JDoodle.
I know. I'm still gonna read it anyway because I read the last one. It's not really super important though. LD binaries in your path environment variable.
So, by the way, you like my visual representation of all this stuff, right?
Yeah.
So the thing about that is, like that. The reason why I think it's so good of a representation for this thing like that I came up with it. That I came up with that is because like I needed that kind of a representation, that way of thinking, in order to understand anything that was going on here. And part of me is thinking like I didn't know how memory worked. Like when I first started, I didn't know how to read, write, do anything with memory. I kind of like didn't even know it was there or how to do anything with it. But eventually, I figured it out.
Mm-hmm.
So like with that, I had to figure that out myself. And what all these instructions do, I also had to figure all these out myself. So when I kind of what I kind of worry about is that like since I'm trying to figure out like run this experiment to see if doing it like if learning like kind of in the same kind of route that I did would help you be really good at programming and this like really boost you the same way that it did with me. But also at the same time, there's like two different sides to this. So on one side, I'm giving you all of these resources and all of these instructions and what all these things mean and how to use them. Whereas for me, I have to figure them all out myself. So it's kind of like I'm like making it too easy, or I'm giving you too many things. But on the other hand, I'm giving you those things because I feel like if I don't, those are pretty likely places for you to give up if you don't know those things and
Oh
you have to
yeah,
figure
I
them out yourself.
probably. Yeah. I mean, without enough guidance, I mean, I probably would just keep working
Yeah,
on.
I went with no fucking guidance. Just figured it out. Because at the time there wasn't really anybody who would have been able to
I
help me with these
know.
things.
You
And
were less fortunate.
I was also like 13 or 14 at the time,
Oh
so
yeah. Well, that's why you should have been a streamer at the time. That's why.
I feel like I would have done something at the time to get me banned from Twitch if I was a streamer.
Perhaps that's a sort of problem. You
That's
gotta
what
be.
happens. That's what happens when you're 13 years old.
Mm-hmm. Let's see. I take the following steps for compiling and linking the above program. Okay. Type the above code using a text editor and save it as hello.asm. ASM. Make sure that you're in the same directory as where you saved hello.asm.
What?
To I'm reading the thing. I don't have to read, but
Yeah, I can believe that.
yep. To assemble the program, type NASMF. I'm just curious what like the process you would do if you were like doing it on your machine with Linux, I guess, because I don't use Linux.
Yeah, you would compile it and then you would run it.
Mm-hmm. To assemble the program, type NASMF elf. Wow. Hello.asm. If there is an error, you will be prompted about that at this stage. Otherwise, an object file of your program named hello.o will be created. It's so cryptic. To link the object file and create an executable file named hello, type ldm. Oh my god, L536 SO Jesus hello.o. Okay, this is Linux stuff. Execute the program by typing /hello. Wow. If you
Yeah,
have,
these commands probably mean something, but
they probably
I
do,
don't
but
know. I don't use Linux. I don't know what they mean.
I know whoever came up with the names for these specific commands, they suck. Because then this is like
I
so
mean, they're probably
unclear.
made more to be quick to type and
They
not
definitely
quick to
were made
understand.
just like quick to type, but not to be clear to like what they actually mean. Done everything correctly.
Clear enough to the computer.
Mm-hmm.
That's all that matters. Like it's like rejects, right? Like regular expressions. I mean, it's not really made to be easy to learn, so much as it is made to be easy for the computer to handle.
Yeah. Let's see. Done everything correctly. We'll display hello world on the screen. Okay. Ooh. Hey, this is the thing you were. Yeah, this is what you were looking at earlier. I can't wait to get to this page. I'm close. I think. Memory segments. Let's see, I'm just looking at how long this is. We've already discussed 3 sections of an assembly program. These sections represent various memory segments as well. These 3 sections. Okay. Memory segments, okay. Interestingly, if you replace the section keyword with segment, you will get the same result.
Section and segment do the same thing, I guess.
Yeah, they could have just said these are the same thing in a short. Let's see. Segment not as code segment. Global start. Must be declared for linker. Oh yeah, of course. Tell linker entry point. Move EDX lane. Message lane. Move ECX message. Message to right. Did you say wasn't it like ECX where it like starts?
Yeah, ECX is where
Reading
your
from?
string starts.
Oh, cool. Message.
So that's the left of your string.
Got you. Move EBX1. Oh, this is the same thing. This part again with the in the kernel. Move EX4. System right. Call kernel. Interrupt. Move EAX1. System call number. System exit. Call kernel. And this one's a little bit new. Does this just like end the program or something? Oh,
When you set EX to 1 and you call the interrupt, it just exits the program.
Yeah. Ah, cool. Segment.data. Data segment. Oh yeah, segments. Hello world. Our dear string. Beautiful. Length equal message. Length of our dear string. When the above code is compiled and executed, it produces the following result. Hello world. Memory segments. A segmented memory model. Wait, I just realized I think they didn't do this like exiting thing in the other one.
They did.
Oh I just
well,
wow, I just skipped it.
I think they did.
You're right, they did.
Well, I mean your code yeah, they did it at the end.
Yeah, they did. What happens if you don't do this?
Your code will continue executing the computer will continue executing the stuff that comes after, and then it's undefined behavior, and your code will crash at some point.
Got you.
Basically, if you don't end it there, your code does whatever the fuck.
Like, okay, whatever.
No idea. You pretty much have no idea what your code is doing after that. It's doing something, but you have no idea what it is.
Cool. It just goes crazy. Segmented memory model divides the system memory.
Because it's like for the computer reading it, it's just reading byte code. So, like all the computer sees is byte code, and the byte code there for those 2 lines is basically it's telling it to stop running the code. But if you don't do that, right? If you don't do that, then it'll just keep running the byte code afterwards until it either gets invalid byte code that would cause an error somehow, or it or something, or it tries to do something, and then the system says, "Hey, don't do that."
That doesn't make any sense.
Tries to read from like index -1 or something somewhere, and then the code is like, "Don't."
Don't.
The machine is like, "Don't do that," because that's really bad.
Cool.
You don't have access to -1.
So not having this is like what happens when the system doesn't take its meds.
I mean, my guess here is it might execute whatever byte code, whatever bytes are in hello world, it will execute that as machine code instead of
it will see
the
it.
hello world string. It might execute that as machine code, and that's obviously not going to work.
Gotcha.
I mean, you could probably figure out what exactly it's going to do, but it's pretty clear that it won't work.
Yeah, it just won't do what you want it to do.
It'll be bad.
Well, segment memory model divides the system memory into groups of independent segments referenced by pointers located in the segment registers. Oh, this whole EBX, EAX, this is the model, the system memory, the memory model, I guess. Each segment is used to contain... Oh yeah, and you said that EAX, EBX, those are pointers, right?
ESP
Not
and
variables.
EBP.
EBP.
ESP and EBP.
Those are the only ones that it's talking about?
Those ones are used specifically... Those ones are used specifically for memory.
Oh. Reference by
or at
pointers.
least they're supposed to be. I mean, you can technically use them for anything. You can use them even for like math and whatever or string manipulation, just like the other ones, but you're supposed to use them for memory, and it's going to be easier if you do.
Yeah. I just
And
thought.
that's also the thing. It's not like even though those are supposed to be used for memory, technically you can use anything. You can use the other registers to do the same thing. You just probably shouldn't.
Oh, those registers are special, right, for memory. Just
Yeah,
memory
and also some instructions are going to use things like ESP and EBP,
into groups of.
assuming if you're using those for memory, and if you're not,
Mm-hmm.
it's gonna cause problems.
Okay. Wherever my corners open the same registers is cool. Each segment is used to contain a specific type of data. One segment is used to contain instruction codes. Another segment stores the data elements. A third segment keeps the program stack. In the light of the above discussion, we can specify various memory segments as data segment is represented by .data section and the .bss. .data section is used to declare the memory region.
Well, it's in that order. Then I guess instead of executing like "hello world" as bytecode, it probably executes whatever you put on the stack as bytecode. Maybe, I don't know.
Oh.
If they're right after each other, then not.
Yeah, because it does it in order. Right.
But I don't know for sure that they are right after each other because that's not information available to me. But if it's in that order, then yeah.
Yeah, that would make sense.
It all depends on what comes after those lines. That's really all it is.
Yeah, whatever comes next, it'll do. Yeah. The data section is used to declare the memory region where data elements are stored for the program.
It'll do as told until it finds a reason not to.
Mm-hmm. Computer is very.
You didn't tell it to stop. Well, it won't stop.
Mm-hmm.
It's as simple as that.
The computer is very obedient. This section cannot be expanded after the data elements are declared, and it remains static throughout the program. Okay, the .bss section is also a static memory section that contains buffers for data to be declared later in the program. Oh, that's why that thing from last time, I know it's not here anymore, but that thing down here created another 8 that was down here yesterday.
Mm-hmm. Yeah.
Because it was declared, it was like done afterwards, whatever it says. Mm-hmm. Buffers for data to be declared later. Then it got declared later in the program. This buffer memory is 0 filled. Code segment. It is represented by .text section. This defines an area in memory that stores the instruction codes. This is also a fixed area. Stack. This segment contains data values passed to functions and procedures within the program, where all the things happen. Functions.
So I think technically, right? I mean, it might be easier to use it, but technically, for nothing really do you really need the data segment, I think. I've been able to do everything that I've done just all in the code segment.
Wow.
So like I don't even really, I think at most if I use the data section, I might have used it to store like a floating point number, but I think I didn't even do that. But like you can use the data segment to declare a floating point number using the regular float format. So like you could store like 1.5 or something like that. Otherwise you might convert 15 to a floating point number and then divide it by 10 or something.
Okay, I see. So convenience.
Mm-hmm. Convenience.
Institute pass.
Or 3 divided by 2 actually might be more accurate. I don't know which one it would do.
Here we go, finally, registers. Processor operations mostly involve processing data. This data can be stored in memory and accessed from thereon. However, reading data from and storing data into memory slows down the processor, as it involves complicated processes of sending the data request across the control bus and into the memory storage unit, and getting the data through the same channel. To speed up the processor operations, processor includes some internal memory storage locations called registers. The registers store data elements for processing without having to access the memory. A limited number of registers are built into the processor chip. There are 10 32-bit and 6 16-bit processor registers in IA32 architecture. 6 16-bit. Thinking 32-bit. Yeah. The registers are grouped into 3 categories: general registers, control registers, and segment registers. The general... Are these divided? Registers. Oh, okay, so let's see how they were... This page was divided. The general registers are further divided into the following groups. General. Data registers, pointer registers, and index registers. Data registers. 4 32-bit... because there's 10 of these. 4 32-bit data registers are used for arithmetic, logical, and other operations. These 32-bit registers can be used in 3 ways. As complete 32-bit data registers. This is the whole... Okay, see.
Yeah, that's the thing I was talking about.
These are just parts of it, yeah, the whole thing. EAX, EBX, ECX. Okay, it's 32-bit register. EDX. Lower halves of 32-bit registers can be used as 4 16-bit data registers. 4. But there's like 8 of these. 4. Wait. There's 4 32-bits.
That's the gray regions, the gray boxes. As like so pretty much it's AX, BX, CX, and DX.
The AX.
And then those gray boxes are split.
AX is AHNAL, but you could say AX for the whole part. Yeah. Now I see. Thank you.
It's the whole gray box.
Whole gray box. BX, CX, DX. Lower and higher halves. Have the above.
I get the feeling that this is going to screw you up at some point when you're coding in assembly.
Oh yeah, it will happen. I mean, I already told you like how hard math is as soon as you're replacing with letters. Like these are just letters. Like I was like, wait, which one is which?
You're gonna have something in in the EBX at some point, and then at some other point you're gonna store something in BH to store a single character, and then all of a sudden your number in EBX is all messed up. Like that's gonna happen.
Definitely. It's gonna be so bad. I'm gonna end up having to like make this like my phone wallpaper, my desktop wallpaper, the specific chart.
You're gonna have to print it out and put it on your wall.
Hang it above my bed so that I wake up, I see it as soon as I
put it right above your computer.
CX, DX. Lower.
You have to paint it on your front door.
Oh my god.
On your bathroom door.
How to get kicked out of the house. Lower and higher halves of the above mentioned 4 16-bit registers.
Then you don't get kicked out of it.
Can be used as 8-bit data registers. 16. 8-bit is one byte is 8 bits. Sorry, I'm reminding myself of that so I can remember these things. Wait, let me try to remember what you said too. At least for the one. Well, what was it? 1 byte. 1 byte's 4 bits. 1 byte stores 255.
1 byte is 8 bits.
God damn it! Wait, that's what I said.
You said 4.
Oh, I meant 8.
1 byte is 4 bits. You said 4 bits.
I actually meant to say 8 though. Yeah. Okay. Wow, I can't believe I said 4.
You're off by.
Shut up! Now I'm off by 4. No. 1 byte. 1 byte is 8 bits. 1 byte stores up to 255. Or if you do the sign stuff, it's like negative 128 or something. 100 to 127. Is that what you said?
Which are the same things. Yeah.
Oh, okay. Negative 120. Wait, you mean negative 120 is 127? That's where it flips or something?
It's negative 128 to positive 127.
Yeah, yeah, that's what I mean. They're the same, like,
Same
binary
thing as
thing.
zero. It's same thing as that range is the same as the range of 0 to 255 when you're dealing with the flight.
Oh, you're just saying the range, like 0 to 255, one negative 128 to 127.
Yeah, that's the range of values.
Cool.
You remember
Range.
what the 16-bit one was?
Not at all. There's too many numbers. It's like you're like, and the way you were reading off like three,
Yeah,
6, 4, 3, 2. I'm like, what the?
yeah, 65, 535. You know,
65,
play 2048 enough, then these things actually become easier to remember.
65.
You ever got the 55, 535 in 2048?
No, I have not played. See, this is the problem. I haven't played that, so now it's not easy for me. Yeah, I'm gonna Google it so I can like see, look at the number. It'll help. What do I do? 2 byte? Because it's 2 bytes, right?
Yeah, 16-bit integer limit.
16. Oh, that's what it's called. 16-bit integer. Oh, you heard it. 65,535. 65535. Okay.
That's and that's the unsigned.
Unsigned.
That divided by 2 gives you the. That divided by 2 will pretty much give you the signed limit.
Okay.
Where one rounded down is the rounded down is the positive, and then rounded up negative is the negative.
So whatever this is, wait, I want to. Okay, I'm gonna use a calculator on Google. Cause wait, I want to try. Okay, you'll see what I mean. What I'm gonna say.
Then if you also look up signed integer limit as well.
Wait, if this isn't evenly divided, what do you do here? Wait, it's
So
like you go
for what it'll be
again.
One of them will be round will
To 0,
so
right?
so like the positive will do 32767, that's round down. The negative will do 32768, that's round up.
That's right. Positive gets rounded down. Okay.
Mm.
So this is pos. If I divide it by 2, because I'm trying to find. So okay, I want negative, so I'm gonna round up then. So it's 3276. So it would be negative 32,768 to
Yep.
32,767.
If you want to know how to like do these like easier, so or a different way, if you do 2 to the 16, that's 65,535. That's for 2 to 16 representing 16-bit. That's
Yeah,
65,535. Or for
Oh
the
yeah.
65,536 minus 1 gives you the integer limit for that thing. If you do 2 to the 15, so 1 less, that'll give you.
Oh, so have it.
8 minus 1 gives you that integer limit.
I see. So instead of 2 to the. So for 2 to the 16th, you would do 2 to the 8th, right? You said?
2 to the 8th
limit.
is for 8. No, 2 to the 15th to the 16th to have it. It's 2 to the 15th because 2 to the 16 divided by 2 is 2 to the 15th. So it's going to.
Oh damn, you're right. Oh, so you just go 1. Okay, you 1 down. I see. 2 to the 15th, and then that gives you the.
And you can do this in Google. You can type this in Google. You can actually even do complex numbers.
That would give you the, and that gives you the sign, doesn't it? 2 to the 15th will give you the signed one.
Yeah, it'll give you the signed limits.
Because round it up if it's negative.
Yeah.
Starting with 0.
Yeah, it'll give you 32768 instead of 767 or whatever.
6, 8.
Minus
That's
1
cool.
gives you, if you do minus 1, that gives you the positive integer limit.
Cool. Thank you. Hey.
And you can do that same
Cool
thing
trick.
for 32-bit and 64-bit.
Nice. Yeah, you'll have to ask me on another day now. Be like, do you just remember off the top of your head what's the 16-bit integer limit? And hopefully I'll get it eventually. It's like 65535. Unsigned.
It showed up enough times that I memorized it.
Did you have this one memorized too? The 63276.
Yeah, that one I
8
memorized
and
from
this one
Minecraft, I
too.
think.
Oh yeah, 32 sword something weird, like the max
And
max
then
out
I
sword.
think 65536 might have come from when I memorized a bunch of the starting powers of 2 up to like 524288 or something. I think that's what it was. I think 524288 is a power of 2.
5, 2, 288. How many powers of 2 is that?
2, 4, 8, 16, 32, 64, 128, 256, 512,
Oh my god.
1024, 2048, 496, 8192, 16, 384, 32, 768, 65, 536, 131072, 262, 144,
Okay, that's a
and
lot of
then
them.
524288.
Oh my god, I can't believe you memorized all those. Like, you did it like as if it's like a times table. What the?
Yeah.
Instead of using a calculator. That's cool though. Right,
Yeah, it
so
comes in handy.
I bet, especially like when working with computers, like that seems pretty
especially
handy.
if you get like 32 divided by 4, then those numbers I immediately recognize how to do that. I can just or if I can see these powers of 2, and if I see these powers of 2 when I'm doing math,
Yeah, you can.
and then I'm like, yeah, no, that's easy division. It becomes
Dang.
really easy division.
That's so cool. So do you think powers of 2 are the most, if you have to memorize like any powers, is like powers of 2 the most useful by far that you could possibly pick?
I mean,
other than ignoring
for
10s,
computer,
doesn't count.
For computer science, yes.
Oh, computer science. Okay.
For regular math,
Yeah.
I would say memorize like at least like the first couple of each of like the first couple powers, like 3, 9, 27, like 2, 4, 8, 16, whatever.
Yeah.
4, 16, 64, 5, 25, 125. Like memorize the first couple powers of all those numbers, so that when you see them, you can recognize them.
Wait, which numbers again? You said like 9? I think, did you say that? 9, 3
Like,
or something?
so like 3, the powers of 3 are 3, 9, 27, 81, and so on. Like you want to memorize like the first couple of numbers, maybe like through like 1 through 9. But I'd say like first one, higher one, just memorize it up to like the number and the number squared. Like 9, you can probably just get away with 9 and 81 and don't go past that.
Mm-hmm.
8,
okay.
8, 64. 7, you have 7, 49, 6, 36. 5, you get 5, 25, 125. I think it was 6 is also 216 after, I think, but I don't know, I have to check. Yeah, it is. For 4, 64, 4, 16, 64. You have 3, 9, 27, 81. Where 2, you have 2, 4, 8, 16, and all the others. And then for 1, you have 1, 1, 1, 1, and 1.
1, 1, 1, 1, 1.
Yeah. Yeah, you know, 1 to the 5th, it's 1.
No way. I'm just kidding.
What's 1 times? Yeah, what's 1
I know. I'm
just
kidding. I'm being
it's
sarcastic.
Clearly 5, right?
Yeah, that's what I was saying. No way, it's 5.
And then for 0, it's like 0, 0, 0, 0. Depending on how you do it, you know, undefined. Exponentiate, like base 0 exponentiation is always very fucked up.
Oh.
It's just always that way, because like, you know, you might depending on how you interpret it, you can interpret it as 0, or you can interpret it as frickin' or undefined, or infinity, or whatever the hell, it depends.
No. Some of these data registers have AHAL, PHPO. Oh yeah. DHDL. E for the long one. Some of these data registers have specific use in arithmetical operations. AX is the primary accumulator. Oh yeah, this whole thing. It is used in input/output and most arithmetic instructions. For example, in multiplication operation, one operand. Oh, you wrote this for your multiplication thing, and when I was reading the thing on Discord, you said about AX. For example, multiplication operation, one operand is stored in EAX. Okay. Or AX. Or AL. Register. Oh yeah, you said according to the size of the operand. But AX. Oh, it's a little bit bigger. Oh, I see. It is used in input slash most. I see. BX is known as the base register, as it could be used in indexed addressing.
See, look at how good you're doing, and that person spat told you that you couldn't learn assembly right now.
I know. Look at me. Oh, later on when they came back to the street, I'm like, hey, I studied some assembly while you were gone. I was like, it was really productive. I learned a lot about like bitwise operations and like how the
Thanks for the resources on how to make a game. I learned how to do assembly.
yeah, it's great. But
Look at this great code in assembly that I made with that code in C sharp. Those C sharp books.
wait, where? I scrolled down too far. Oh, yeah.
Yep.
Yep.
Yeah.
As it could be used in.
Yeah.
What's...
You scrolled down way too far.
I scrolled down like to the bottom of the page. What is indexed addressing? That's just like saying like plus
That's
2,
the
right?
square brackets.
A square bracket.
Index addressing is the square brackets. Yeah.
Yeah. Is that like the thing when you were saying like -2, +2 to tell it where to go?
Yeah. That's the boxes.
Boxes. Yay. CX is known as the count register, as the ECX. Yeah, ECX is the big one. As the ECX, CX registers store the loop count in iterative operations. Ooh. DX is known as the data register. It is also used in input/output operations. DX. It is also used with AX register. Oh, AX and DX work together for division and multiplication. Along with DX for multiply and divide. It should be multiplication and division for operations involving large values. Cool.
Well, I mean, those are you call them multiply and divide in this context. I think you call them
really?
But it's just I mean, I think also part of it is that I don't want to say multiplication. I just say multiply.
You would say multiply operations.
It's just less syllables. You know, it's less syllables.
Fair.
But if you're like having advice to just do a multiply or do a divide.
Oh, I've never heard anyone say that.
Nobody would get mad at you for that. Just because it's short. It's more convenient to say it like that.
Fair enough. Multiplicate. Yeah, you're right. Less syllables.
That's probably also how you're going to be thinking of these things at some point. Is, well, I need to do a multiply here. So you're going to be thinking like that.
I'm gonna be even. I want less syllables. I'm gonna be like, I need to do.
This is a multiply operation.
Yeah, divide. I mean, or it's like it's a vinculum operation. Point registers. Yeah, this one was pretty clear. This data register section was really good.
It's a name leakage operation.
The what?
Doxing operation.
Doxing operation. The pointer registers are 32-bit. EIP, ESP. What's her name? I say E. Where's the I? ESP, EBP. Oh, these are the special ones. The pointer ones that point to the stack thing.
EIP is instruction pointer.
Why is it not in the picture? Where are you, EIP?
EIP, you are never going to need to change. And I think you shouldn't. Let me read this.
Sure.
Yeah, probably. I think EIP is like something you don't want to change.
Gotcha.
Yeah, so, yeah.
EBP registers in corresponding 16-bit write portions. I see that IP, SP, BP. There are 3 categories of pointer registers. IP, instruction pointer. Oh yeah, this is the one that doesn't change. The 16-bit IP register. Oh, it's talking about this one, the EIP.
Yeah, that's where you steal your IP from, the IP register.
Are you serious?
No.
Oh, okay. You're funny. You okay? IP register
The
stores.
IP, the IP register stores your IP. Yeah.
Of course, because IP. Of
Mm.
course. IP register stores the offset address of the next instruction to be executed. Ah, offset. IP and association. So I see why you wouldn't want to mess with this because it does it automatically. It looks like it just stores it.
Yeah.
So why would you screw up your own thing?
Mm-hmm.
IP in association with the CS register. Where is CS? CS? Is
Not
it down here?
listed.
It was down here. CS, where are you?
Not listed.
Oh,
Not
did it say
not
that?
listed. It's. I'm
Oh, it's
just
just not
looking at
here.
this. It's not listed.
Yeah, I thought it was supposed to tell me about all the registers, but it's clearly missing some. Let's see.
Well, I mean, those two registers are not really ones that you really need to know about because you're not going to be doing anything with them.
Fair enough.
You're not going to be doing anything with them
I just
unless you're
want to
doing some
see.
like really complicated stuff.
That's fair. I guess that's why they don't like tell you about.
Mm.
Them. They're just like, oh, you don't need to know about this. Well, okay, fine.
What's going on here?
I was using Command F to search, and now I'm back at the top.
Yeah, I put you all the way at the bottom. That works.
16 bits. Oh yeah, IP in association with the CS register as CSIP. Interesting. Gives the complete address of the current instruction in the code segment.
Oh, so CS is probably the code segment register.
Oh, code segment. I thought it. Okay. I see CS. I'm like computer science, IP address.
Information technology.
Stack pointer. The 16-bit stack pointer register provides the offset value within the program stack. SP in association with the SS register. Okay, another
These
one.
all have 32-bit versions apparently,
I guess so.
which are just you just put E in front of it and it's 32-bit.
Even CS, you think it is ECS?
Maybe.
Oh
I don't know.
wow, maybe.
I've never used
16
it.
bit.
I never touched EIP.
You don't touch those.
I never touched the IP or CS registers. I never needed to.
Okay. SP provides the offset value within the program stack. SP in association with the SS register refers to the current position of data or address within the program stack. Okay. So this one's for the stack, and this one's for the. I mean, I'm not going to change them, of course, but this one's for the.
Yeah, ESP and that's
current
ESP
instruction.
that I'm talking about on the second one. That's ESP.
Oh, ESP. Okay.
Mm-hmm.
And the ESP part.
And then the next
position.
one is EBP. The one that so ESP is the one that goes on the left, and EBP is the one that goes on the right.
Mm-hmm. Register. Wait, all these things are called registers. Like this is called the AH register, AL register, EAX register, right? Or is it only the big one called register?
They're all registers.
Oh yeah, 16-bit. It literally says 32-bit, 16-bit. You're right. First occurrence register. Okay. Base pointer. BP. Little BP. There's no EBP, but like little one. 16-bit BP register mainly helps in referencing the parameter variables passed to a subroutine. Okay. What is a subroutine? Even in like a real, like a higher level language, because those are brought up.
Basically
Something
a
done
function.
in some. Oh, just function. Okay.
Basically just a function. Yeah.
Nice. BP register mainly helps parameter pass to a subroutine. Okay. The address in SS register is combined with the offset in BP to get the location of the parameter. Okay. BP can also be combined with DI and SI as base register for special addressing. Index register. Oh, DI, SI. I'm guessing you never use these. I'm guessing.
EDI and ESI, I think I have.
Oh, cool.
Those ones are fine to use. They're basically just like the EDX, the EAX, EBX, ECX, EDX things.
Mm-hmm.
For whatever I care about. They're basically just more of those.
More, yay.
Which is good. because I've needed them. I've needed more than just the 4 a couple times.
So you went into these ones. 32-bit index registers ESI, EDI, and their 16-bit rightmost portions, SI and DI, are used for indexed addressing and sometimes used in addition and subtraction. Oh yeah, used for indexed addressing. Right. There are 2 sets of index pointers. Source index. It is used as source index for string operations. Oh. It is used as destination index for string operations.
Technically,
Yeah?
you don't need to do it for. You don't need to use it for any of those things. Like, I don't think I used it for either of those 2 things.
Oh, it just. I see. You can use it for anything. Extra register.
Like that's basically just a that's
Another one.
like the sort of thing that's a recommendation, right? That's basically like you should use it for this thing, but you can use it for anything.
Cool. So just bonus register. Download free registers. Here, click here. Free registers.
No.
Yes. Need more RAM. More registers.
You only get 10 of them.
No. More. Infinite registers. Control registers.
Will kill you.
No. The 32-bit
The
instruction.
registers will stab you.
What will stab me?
The registers.
No. It's sad.
The registers will bash your head in with the calculus textbook.
That's a programming language.
What?
Bash. I think. 32-bit instruction pointer.
You'll dent your skull with a calculus textbook.
But then I'll finally understand what a derivative is, I think. Isn't that the all slope?
Yeah.
Yep. 32-bit instruction pointer register and 32-bit flags register combined are considered as the control registers. Instruction point register. Flag register. Oh, and we already looked at the instruction pointer, so this is one of the instruction... whatever it said. They're both control. Many instructions involve comparisons and mathematical calculations and change the status of the flags and some other conditional... Oh, that's what happens when you're saying, like, making comparison, storing in the flag. That's cool. And change the status of the flags and some other conditional instructions. Test the value of these status flags to take the control flow to other locations. The common flag bits are overflow flag. It indicates the overflow of a high order bit, leftmost bit of data after a signed arithmetic operation. So basically, if the bit flips, that means it overflowed.
Yeah, if you went like
if
you went
leftmost
over the
bit.
integer limit, if you went over the integer limit, then yeah.
Yeah, cool. See, I did learn something with the whole discussion about how the bits work and then sign and unsign. Now it's like clear why the left side, like the left one, flips.
If you added 2 8-bit numbers together, if you needed 9 bits to represent it, then you hit the overflow flag.
Oh yeah, I see.
Like 255 plus
'Cause that's
1,
what I
you
flip.
can't do that in 8 bits, so that'd be overflow.
Yeah. Or like, I'm thinking like
See what happens when you go to when
like
you
it makes sense if
nobody's here.
Oh. Well, it was my fault originally because I wasn't streaming until recently. I was streaming in the... Oh wait, why does it still say math? What the hell? I was trying to switch to software. Because we're streaming in math, but we're doing this. Well, that's so awkward. We're streaming in math the whole time. But we're talking about assembly. That's why. Lol?
You're bad?
I'm bad. Skill issue. So what if... So if the leftmost bit is 0, and then it becomes 1, that's not necessarily overflow, right? It has to go from 1 to 0, because then it overflowed.
Yeah, it has to go from 1 to 0. Yeah.
Cool, because that's how things carry. Direction flag.
I think, well, this might be...
Me says awkward.
That might be different for multiplication.
Yeah, awkward on me. Multiplication?
It might be different from multiplication.
Okay. Because the... Oh wait, is that because for the overflow flag it's like used in the multiple? I think you said something like that. Oh good, thank you for following. Forever follow. Let me look at what you sent me. Let me like look at the cheat sheet again. Your cheat sheet. It's not my cheat sheet. It's also kind of cool how like this discussion about like how binary and all that stuff works and how the numbers, like the patterns that the numbers have. Like it's also helpful just too, like just general math. Like it's helpful for that, I think. That gave me a better understanding of numbers. Let's see. You wrote for multiplication. You wrote storage ex. Oh wait, am I crazy? I thought you talked about a flag, but there's no mention of a flag. I thought you did, but never mind.
Wait, what's going on?
I don't know. I just, in my memory, I thought you wrote, like, when you were talking about the multiplication and division.
Did I not write it down in there?
Commands. I thought you said something about flag, but there wasn't anything.
Well, I have said something about.
You did. There was something about flag somewhere. I just don't know where. You wrote about
I think
flag.
I was talking about like the whole.
Comparison, like greater than, less than.
It was like flags show up with comparison.
Yeah,
you're
you
asking
did.
about
That's right.
About like what does that do? Because like what is it comparing about them? And I said it stores the result in the flag.
That's what you said. I was like, what does it do? And you're like, well, it just stores. It just changes the flags.
It just does all of these things.
All of them.
It does
and then
all of these things. It stores all of this information.
Which is so cool. And then you just have to say which one you want. I want this one.
Yeah, but yeah, that's literally what the conditional jumps are. It's literally just check that flag, and then jump if that thing.
That's cool. Direction flag. It determines left or right direction for moving or comparing string data. When the df value is 0, the string operation takes left to right direction. When the value is set to 1, the string operation takes right to left direction. Oh, like when you're going to do something on the string. You could change the direction, I guess. Interrupt flag. It determines whether the external interrupts the keyboard. Interrupts like keyboard entry, etc. Oh, cool. Okay. Are to be ignored or processed. It disables the external interrupt when the value is 0 and enables interrupt when set to 0. Okay, that's kind of cool. Oh yeah, because 0 is always off, 1 is like on for all these things. That's why 0 is... I found out 0's false, 1's true, right? Am I right? Do I remember that right? Yeah. Because 0 is like nothing.
0 is off, 1 is on.
Trap flag. It allows setting the operation of the processor in single-step mode. Operating the processor. Oh, wow. The debug program we used sets the trap flag so we could step through the execution one instruction at a time. Oh, that's kind of cool. Sign flag. It shows the sign of the result of an arithmetic operation. The flag is set according to the sign of a data item following the arithmetic operation. Oh. The sign is indicated by the high order of leftmost bit. So that's how it determines, like, because if it should be negative or whatnot. Like, it's like if the sign flag, like what will be shown on the screen, this sign flag, it will change. That's cool.
Yeah.
Now I know. The sign is indicated, but not the sign like cosine sign, but like sign, like normal person sign. Not the crazy sign. Sign is indicated by the high order of leftmost bits. Well, yeah, you can tell me that. A positive result clears the value of sign flag to 0. A negative result sets it to 1. I thought a positive result, it doesn't really matter because it will be like the same thing, but I thought a positive result would be like 1 and then negative would be 0 because it's like negative is closer to 0, positive is like more like 1, but whatever, it's fine. But then negative has more numbers in it. Positive has 1 less, and negative has more. So maybe that's why it's like they decide it's 1 for the flag. Order of most bits.
I'm very glad that I rebound just pressing the power button on my computer
Would you?
putting it to sleep instead of shutting it down.
Why?
My foot press the power button. My leg pressed the power button on my computer.
Mm-hmm. Oh, by accident, you mean, or something?
Whoops.
Okay.
But luckily, it didn't shut down my computer because I specifically set it to not do that because I got upset because it kept doing that.
Okay.
It's a really easy button to press if I have anything near there, so...
Oh, okay. I see.
It's not like on the side or anything, it's on top.
Mm-hmm.
And it's like a little square. It's easy to press.
Hmm. It's kind of weird that they have to use a term like this, but I think high order means it flips. The leftmost bit flips.
Yeah,
Flip
high order is leftmost. Or actually, wait, what is the sign? Oh yeah.
Yeah, because it will change
whether it's
signed or unsigned.
Yeah, that's whether it turns to 1 or 0.
Yeah, people need to use better language. I don't like this term high order. I would prefer it flips. I like that better. 0 flag.
I mean, if you just say it flips, then you're wrong every time. You're wrong half the time.
Like,
if it flips to, well, actually, wait, no, sign flag. No, never mind. Sorry, my bad. I thought it was checking. I thought it was a 0 flag.
Oh no, I was reading sign flag. Yeah.
0 flag, but sign flag. Yeah.
Yeah. 0 flag. It indicates the result of an arithmetic.
Is that indicated by the value of the leftmost bit after the operation?
That's just what I mean, the value. But see, that's a better word, value. Like, this is like unnecessarily like weird. It just comes across like so weird. Indicates the result of an arithmetic comparison operation. A non-zero result clears the 0 flag to 0, and a 0 result sets it to 1. So if you compare things, and then I'm imagining it in my head, compare things, and it's non-zero flag 0 sets it to 1. So that's like, this is like true, right? Almost. It's like 0 is like they're equal. Set it to 1, which is true.
Yeah.
Is that okay? I'm making sure I'm interpreting that right. Auxiliary carry flag. AF. It contains the carry from bit 3 to bit 4. Following an arithmetic operation. Used for specialized arithmetic. Have you used this one? This one seems special.
No, I have no goddamn clue what you need that for.
Yeah. You can say
I'm assuming that there's some good reason for you to need
some math reason.
Checking
just for
carry from bit 3
yeah,
to
from
bit 4.
just from this one bit to bit 4, like what the hell? You can say that this flag is weird AF, right?
Yeah.
Yep.
Weird AF flag.
Weird AF flag. The AF is set.
The AF flag.
It is, so that's why it's called AF, because like what the hell?
Yeah, the weird AF.
Weird AF. AF is set when a 1-byte arithmetic operation causes a carry from bit 3 into bit 4. Okay. That's have some purpose. Parity flag.
That's used for something.
Something. Maybe it's something in the system.
It has something to do with base 10, I don't know.
Oh, maybe.
Or some other base. Yeah, it's confusing.
Or it could even just be like arbitrary, like it was just decided, like we have to pick one of the bits to carry, and could be.
It wouldn't be arbitrary. If it was arbitrary, they would have filled that slot with something better. That's an entire flag. That's space.
It's true.
That would have to be something important.
But it is about halfway. It's about halfway in the bit. I mean, in the byte, it's about halfway in there. So maybe they needed it like in the middle. because like
Yeah.
so it won't interrupt something else. I don't know. It's interesting. So, parity flag, PF. It indicates the total number of 1 bits and the result obtained from an arithmetic operation. Oh, okay. An even number of bits. Oh, this is the checking thing to make sure, like, there wasn't a mistake that I read about before. Parity. An even number of 1 bits clears the parity flag to 0, and an odd number of 1 bits sets the parity flag to 1. Okay. Carry flag. It contains the carry of 0 or 1 from a high order bit, leftmost, after an arithmetic operation. Oh, so just remembrance if it became 0 or 1. Or carry 1. It also stores the contents of last bit of a shift or rotate operation.
That's
Yeah.
that's a bit shift and bit rotate. So like basically,
Oh,
like you have your number in binary. A bit shift is like you move all of those values to the left one or to the right one.
Okay. What about rotate? This one seems weird.
And to the left one is basically equivalent to multiply by 2, and to the right one is equivalent to divide by 2. And rotate is basically whatever like if you're moving it to the right, whatever that bit is that was on the right moves to the loops back around to the left.
Oh,
wow! If you took a byte and moved and did the bit shift to the right by 8, you would just get 0, because everything would just move outside and you get all zeros. But with rotate, it rotates it around, loops it around.
That's cool. Okay. Kind of crazy. Last bit of a shift or operation. Huh. And the last bit is the bit on the leftmost, right? It's the last bit.
Yeah.
Interesting. Have you used the carry flag?
I think I have.
Oh wow, this one's more complicated. Okay.
I think I have before.
I thought you would have.
Let me see. Well, I can check right now. If I have something in my code that says JC, then I think I have. JC. Oh no, I don't. I think I did at some. I thought I did at some point.
Contains carry of 0 or 1.
Oh, I used J not C at some point. Oh, I used J not C. So basically, yeah, I did use it.
Oh, okay.
You
cool.
Jump if not C. Jump if the carry flag is not
Oh.
C.
What is not C?
So jump if not carry flag.
Oh, just not. Okay.
Basically, if it's 0. Jump if it's 0.
If 0, yeah, do something then.
Like JC would be jump if that's 1. J not J.
Oh, the command JC. I see.
Yeah.
JC and J. Isn't that one of the ones where you said? Oh yeah, you said there are others like JZ.
I didn't put it. Yeah, I didn't put it in the list.
Yeah, but it just says, but you'll learn what those do and how to use them if you need to. Cool. JZ, JNZ, JC. The following table indicates the position of flag bits in the 16-bit flags register. Okay. Oh yeah, because they have acronyms. Like, bit number 0.
So it looks like there are others. There are other flags.
But they don't want to like explain what they do.
They didn't explain what those other flags are in this year.
Yeah. Okay, that's fine. Oh,
that's zap.
Oh, each one. I get what they did. Each one has a different starting letter. Like this is DI. That's why some of the names are weird. Like auxiliary A, Z, P, C, S. There's no like duplicate letter. C, P.
Yeah. That's probably very intentional.
It has to be.
Things like the jump, the jump instruction. You use that.
Oh, that's how you tell it to do something like J something or T something, S something, P. Cool. Segment registers. Oh, this actually, this will be fun to read. System goals. I'm like looking what's ahead. Address concerns. Oh god, recursion in assembly. Recursion's hard enough in like high level.
I did recursion in assembly.
Oh, nice.
For the simple calculator, because I needed to do recursion to handle parentheses.
Do these link? I bet this links to like paid resources. I was curious what this. Yeah. I was curious.
Yeah.
I see. So they sell courses and stuff too.
Well, you get this for free. You don't even need any of that.
Okay. Segment registers. Segments are specific areas defined in a program for containing data, code, and stacks. There are three main segments. Data, code, stacks. Sounds familiar. Code segment. It contains all the instructions to be executed. A 16-bit code segment register or CS register. Oh, that's CS. So they did define it because remember they said it works together with the CS register or whatever.
Mm-hmm.
It was standing for code. I already forgot. Code segment. Oh yeah, you had it right. You were like, it probably is code segment. It was. Register. Stores the starting address of the code segment. Okay. Data segment. It contains data, constants, and work areas. Oh my god, there's a bug. Sorry. Data, constants, work areas. A 16-bit data segment register, or DS register, but not Nintendo DS, sadly, stores the starting address of the data segment. Let's see, it's data, constants, and work areas. Stack segment. It contains data and return addresses of procedures or subroutines. Let's see. It is implemented as a stack data structure. The stack segment register, or SS, well that's what SS is, register, stores the starting address of the stack. Starting address. Apart from the DS, CS, and SS registers, there are other extra segment registers, ES, extra segment, FS, and GS, which provide additional segments for storing data.
Corrupt Converter says I'm on here for a short bit.
Okay. Got you. Are you still in? Oh yeah, still in VC. Oh lol. The double corrupt converters. In assembly programming, a program needs to access the memory locations. All memory locations within a segment are relative to the starting address of the segment. Oh. A segment begins in an address evenly divisible by 16 or hexadecimal 10. Oh. So the rightmost hex digit in all such memory addresses is 0, which is not generally stored in the segment registers. Let's see. Thinking about the 16 and 10 thing. Okay. Segment register stores the starting addresses of a segment. To get the exact location of data or instruction within a segment, an offset value or displacement is required. Starting address. To reference any memory location in a segment, the processor combines the segment address.
Of me says X10.
Yo. The processor combines the segment address in a segment register.
Corrupt converter says obviously 0x10 means 0 times 10 means 0 kappa.
Combines the segment address in the segment register with the offset value of the location. Ooh. Look at the following simple program to understand the use of registers in assembly programming. This program displays 9 stars on the screen, along with a simple message. Displaying 9 stars. Oh, just both. Okay. Let's see. They should have like a copy button to copy the code. I'd rather run it in JDoodle. Plus, this one's like unprotected or whatever. But I like your thingy. I don't want to get rid of it. I just like. I wish multi-line comments existed. I'm sad. Maybe I'll just make another JDoodle. No, I'll just comment everything out. It's fine. So I'll do just like.
Corrupt converter says just do more.
Do more? No, I'll just keep one open. It's fine. It's not that long. Keep. What do we have? Okay. Let's say does this do the thing? It does. Excellent message length. CX.
Of me says it walks.
It does. EVX1, EAX4. EX9.
Of me says it asterisk works.
It does. ECX. What are the things in the data? Message DB. Oh, this MSG. It's referring to this message to right. Oh, so they're using message. They're defining it like in the data instead of like what you did. Corrupt when you did the like thing where you actually wrote it like a you know, like a string literal and pushed it onto the stack. I see. To, and you moved it to, oh, you just push. Huh. That's cool. Wait, the extra thing you did was this. Where was it? Oh god, wait a second. I just realized that you did a lot more stuff. I should have asked you about this. I didn't even see that you had this line written. I think this is yours. Where?
Which the XOR?
Yeah.
That's basically equivalent to just setting EBX to 0. I got crusty audio right now.
Oh, okay, it's fine. Don't worry. It's equivalent to what? Setting.
It's equivalent. Yeah, the XOR EBX. That's basically just set EBX to 0.
EBX. Okay. I forgot what EBX does here. EBX1.
That second parameter there. So the reason why I do that is just so that way when you run the code, like I set EBX, like that could just be mov EBX0. It's literally the same thing. But the reason why I do that is so that way when you run the code, it doesn't give you a weird unexplainable error in the output. Because if EBX is something other than 0, then sometimes it gives you an error code because it assumes that you're trying to print out with an error code.
Mm-hmm.
Yeah, but if EBX is 0, then it assumes that you're not printing out an error code.
What's a XOR? I mean, this is like XOR.
Like XOR.
This actually is
exclusive OR. So
EBX or EBX or something or what?
So it's exclusive OR. So basically, it's A or B, but not both A and B.
Mhm.
So you can think of it as like in true and false, or true like a Boolean. So
yeah.
If A and B are Boolean values, if A and B are both false, then it's false. If A is true and B is false, output is true. If A is false and B is true, output is true. But if they're both true, then the output is false again. So basically, this is a bitwise operation. It goes bit by bit.
Oh.
And if both of the bits are different, then it sets it to 1. If they're both the same, then it sets it to 0. But EBX, all the EBX is equal to EBX, so all the bits are going to be the same, so they're all going to become 0. It's literally just setting EBX to 0 in a fancy way.
And if it was not equal, it would have set them all to like 1s or something. Or what would happen if it was not 0?
If it was not equal, then the bits that aren't equal would be set to 1.
Oh, okay. Oh, only the bits. That's a bitwise or bits that are not equal.
Yeah,
are set to 1.
Bitwise XOR.
Wow. Bits that are not equal. Okay. Interesting.
And that's usually pronounced XOR, not XOR. Because it stands for exclusive OR, so XOR.
Oh. Have it... Huh. I'm trying to remember what I heard people say in like videos. And maybe they did. I don't know. What does Google say? What do other people say? How do you pronounce XOR? XOR. I'm not seeing it.
Yeah, it looked like a lot of people on
there.
there.
A lot of people prefer XOR.
Yeah.
Definitely. This is X. XOR. Yeah, looks like this is not just the preferred, but you know if there's an original, this is probably the original too. Anything else is just unstandard. Huh. That's cool.
Wait,
but that's extra.
Why is exclusive OR red? How is that not a Wikipedia? Is that not a Wikipedia page? How is it not a Wikipedia page?
What? Where?
Also, like in that one in that those there's that red text there, which means that whatever it's trying to link to doesn't exist as a Wikipedia page. I'm just thinking how exactly.
These are for
Like exclusive
Wiktionary.
lore feels like it should. If exclusive lore feels like it should be like a massive doc.
No, this
Like
isn't. This
Wikipedia
isn't
page or something.
Wikipedia. This is Wiktionary. These linked. These all link to Wiktionary. See, they
Oh,
don't
those
link.
are. This isn't This isn't Wikipedia.
This is
Oh,
Wiki. This is Wiktionary. Mm-hmm.
oh,
Yeah,
oh,
that's
it's a very
why.
different website. Oh, well.
Exactly. And the reason
It's
they
just
don't
that
have
usually
that
the red.
page,
I think that usually the red links are like links to pages that don't exist or something.
they are pages that don't exist, but they don't need the page exclusive lore because they just this is the page for exclusive lore that they use. Is what they're saying. It's
Well,
a
just
synonym.
link to the current page or something.
But why would they link to the current page? We're on the page. Why would they link to the page we're on? And it would just reload
Why
the
not?
page. Because it would just reload the page. Is what the.
Yeah, why not?
Okay. But yeah.
Why? I mean, the other thing is why are they? Well, I mean, if that's the case, then why would it be a link?
Just to show that, hey, we don't have a page for this. Because some people might want to find it on a page. Like, we don't have a page for this because it already exists as a page. Like, it's the page you're on. Mm-hmm. And also just to make it look good with these other. These ones are links, so just to make it, like, match the others. Like, this has a page, this doesn't. I don't know. Yeah. Where were we? Where was I?
It's well,
Exor.
yeah, XOR.
Exor. But it's less fun to say that because it's like you have to be like X.
What'd you say?
I said it's less fun to say that because you have to like make more sounds. You have your that consonant. It's a
I mean,
okay. I'll
yeah, I
use
mean,
the
I suppose it's harder to pronounce. I mean, it might be
yeah.
like slightly, like one
It's
syllable
less
harder to pronounce.
efficient. It's like less efficient. Yeah, it's called a
Sensation
what?
underscore black
Is it?
1984 says Kaser.
Exor. We're talking about that operation because I said Zor because it's like more fun and easy to pronounce and more efficient. Most importantly, more efficient because the X is like it's a consonant cluster. That's why consonant clusters are less fun. Cause just be like.
Sensation underscore black 1984 says K like kick, then SOR, like soar.
Yeah, it's
Problem
actually
solved.
supposed to be Xor, not Xor.
It's XOR. It's like XOR
Like
because
exclusive.
it stands for
1955 says
exclusive.
just accept it is pronounced XOR.
No, I accept it. It's just like it's less fun. That's all. It's like less efficient with the consonant cluster at the beginning, but it's fine. Xor.
Sensation underscore black 1984 says or maybe the Chinese way. Sure.
Sure. See, it's even more smooth on the tongue to say sure.
Yeah, let me do the shore
Sure.
operation. Let me do the shore operation.
Yeah, doesn't it just roll so smoothly in your mouth? Sure. Let's do the shore. Go to the shore.
Well, the problem isn't about how easy it is to say it. The problem is that when you tell somebody that you're gonna do the shore operation, they're all
I already know what it means.
like 100 times out of 100, they're gonna ask you what
Shores
the fuck is the
out.
shore
Win!
operation.
There you
Shore's
are.
algorithm.
There you are. So happy to see you. Hi, Win. Just let you know if you want to like
Yeah,
come.
or
come
they're
visit,
gonna
you're
think
welcome.
you're talking about the shore's algorithm. Yeah.
Yeah, I'm just talking about how like I think how long of this conversation did you hear, Wind? Apparently, Xor is pronounced X. Or
They've
how
been
do
here
you
for the last
pronounce
3
it?
hours.
Anyway, no, they haven't. I don't think so. How? Or they would have said hi. Wind usually says hi. Wind. How do you pronounce?
They did,
You
you
pronounce it
missed it.
Xor, right? The real way.
You literally missed it.
Oh, I think they heard us talking about it. Yeah, I just don't like the
Blind
consonant cluster. It's
137
less
says
efficient.
the only thing I heard was you talking about how to pronounce XOR.
Even the bot says XOR.
It
GPS is XOR.
the bot is it actually did. Like
Yeah, the
Twitter?
bot said
Line
XOR.
137
Damn.
says like the letter X and then or.
Yeah. Oh, he does it too. Okay, so okay, I'm gonna use XOR. I won't complain. So what? Oh yeah, message. Yes, ECX. Oh, what I was. Oh wait, you set. So now we know what it does. You set EBX to 0 by using XOR on it to see if EBX is EBX. So set it. I mean, it just is 0.
Me
What?
personally, with the examples that they give,
Wait a second.
the way I don't like the order. I don't like that they do like that they do EDX, ECX, and then EBX, and then EAX.
Oh, wait,
I
why am I
prefer if they did
connecting
it like the
yours?
other way around. Yeah, they do it like in reverse order. It's like it just like feels confusing for me to read. Then they do it in that reverse. Like when I do it, I did EAX, then EBX, and ECX, and EDX. Because I just go A, B, C, D.
Wait a second. Since you, maybe I'm misunderstanding this operation. Since you did this bitwise XOR here, you set EBX to 1, and then they got.
No, I set it to 0.
Oh, but up
to
here,
0.
up here you set it to 1 though. It was 1 here.
Oh yeah, I
here.
set it to 1. Yeah.
But then once it was here, so then it said, oh yeah.
I mean, yeah, there.
I
wrote that just because. I know that just because, but technically, like I said, the XOR EBX EBX, it's the same as MOV EBX 0, which is just sets EBX
I know.
to 0.
Well, it ends up being that same result. But why?
Yeah.
With how XOR?
Sensation _ Black 1984 says if something seems like it's in the wrong order, maybe your thoughts are in the wrong order. Just a thought.
What?
I don't read from bottom to top. That's the thing. I read from top to bottom. And I don't like conditionally read from bottom to top, depending on where I'm looking. It's usually from top to bottom. I mean, code executes from top to bottom. It doesn't execute from bottom to top. And
yeah. So
DCBA, like come on.
You're comparing. So you compare EBX to EBX, and at this time, when you do make the comparison, they're 1. They're 1, and then what is it saying again? You're saying if they're different, set them to. If they're same, set them to 0. Oh yeah, same, set them to 0. If they're different, set it to 1. Okay.
Yeah.
I just keep forgetting what I got. Yeah.
Yeah, but then are any of the bits?
That's why it sets to
0.
If
I'm comparing EBX to EBX, are any of the bits in EBX different from any of the bits in EBX?
Mm-hmm.
What was your response?
Me?
Sensation _
If I'm
Black
comparing
1984 says the text has direction data is a vector.
Yeah. If I'm comparing EBX to EBX, then are any of the bits in EBX different from any of the bits in EBX?
You're asking me?
Yeah.
Oh, I understood it. Yeah, if you're comparing them, they're not different. So they're 0.
Yeah,
if they're same, they're 0. If they line up and they're different, they're 1. I just forgot how that works. Okay.
Yeah.
Mhm. So.
Yeah.
Right, we have. Okay, I'm looking at their sample code. This is the code from Tutorial Point, but this code was written by Corrupt. I just commented it out. It's
JK.
cool. And this was, yeah, this one's from Tutorial Point also. Right, so 1 school system, right? Message lane move EDX 9. Wow, so they did that manually, like by counting out. Oh. But they have the length 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh wait, 9 stars. It's S2 times 9 dB. What's S2? So I guess this gets replaced with 9.
No, it's storing 9 of those asterisks there. It's just a string of 9 asterisks.
I see. DB, because this is the one they want. times 9, but 9 of these. That's 2 times 9. Oh, it's another way of saying that. Okay.
It's just saying do 9 of those.
Data. It's kind of weird, the whole like data section and then the text section, because then this is like you're like moving numbers around into boxes.
Yeah,
and
it's basically like here are your variables and here is your code, like of how you're supposed to put all of your variables at the top of your class.
Yeah,
or
and then
like
this is weird because then these.
It's pretty much like that.
Yeah, all the stuff down here reminds me more of like actual code, like more higher level stuff, like stuff. Yeah, it's interesting.
Oh, everything has its roots.
Everything has its roots. 9 of the stars, and then EBX14 is printing again, and the program, blah blah blah. That's cool. This was the coolest part of this was, well, the coolest things I've seen.
137 says roots of -1.
Is that what you said? Did you say roots of? I don't know.
Yeah, -1 has its roots too.
Oh, I didn't hear you said that. I didn't hear you say. I thought you said everything has its roots, not roots.
I did say everything has its roots, and then Lynn said roots of -1, and I said -1 has its roots too.
Oh. Oh wait,
Sensation
you know what? I hate you
Black
when
1984 says
I hate complex numbers. Hey, no one say I, because I don't appreciate selfishness. Not here, not in this stream. Don't be selfish. Don't be selfish. No I.
Why? So here, let's talk about this situation. You said that we're not allowed to say it, but then you said it a bunch of times in that sentence.
That's how you'll get around it.
You what?
Me?
You what?
Me
Sensation
thinks
underscore Black 1984 says Utsman.
Me thinks you are wrong. Anyway.
Me says complex numbers FTW.
Yeah.
Yeah,
So
complex
then-
numbers are fun. You should try it sometime.
Okay, I'll try sometime. Right. Oh, let me give you a too long didn't read, children who weren't here before. I read this whole page in detail, but I'll give you the condensed version of this page so that you can follow along with assembly.
Christopher 1955 says there are videos of how to read assembly on YouTube. It is not a newly discovered thing.
But when you do it for the first time, it's newly discovered for the brain that gets to learn it for the first time. Anyway, so you have all these.
Yeah, I mean, but what even is that message? It's not like we're inventing something that didn't exist before.
Oh, somebody's been around forever. We're just rediscovering the roots of the computer. Well, actually, he already knows assembly. I'm learning more about various different programming languages.
Sensation underscore Black 1984 says, or, even better, there's these things called books, right?
Books cost money.
That costs money. This was free.
It is. It's also more fun to learn from the people that already know what they're doing.
Sensation underscore Black 1984 says apparently it's easier to consume the information from a physical book. Or so I've heard.
It really depends on the person. There are people that like hate books and hate reading that would rather watch videos. There are people that...
I personally think that it is objectively always going to be easier to consume information related to coding from the web than it is from a book, simply because you have access to a much wider range of resources, and you can get answers to specific questions that aren't in the book.
I think it just depends on the person. There's good resources, good books, there's good videos, there's 1,000 different ways to accomplish the same thing. That's the beauty of the day and age
Like if
we
I
live
had to
in.
pick between a bunch of books as my resources versus the internet as my resource, I would always pick the internet because it's just objectively a better resource. And it also is constantly updating a book. If I get a book, well, if there's new information or new stuff, it's not in the book.
Because I think everything has a place.
Sensation underscore Black 1984 says, well, good luck.
Anyway, you have all these different registers. You have these 32-bit registers. Well,
Live
we can
137
agree you're
says,
eventually
"I feel
going
like
to
if you
type
learn anything programming
code
related,
into a
you're
computer.
eventually bound to type code into a computer."
Most definitely. And if you're not typing code into a computer, then yeah. It's like, you probably should. Maybe. It's a good idea. It'd be fun. You should try it. Touch a computer, not grass. What I say.
Touch computer is not grass. Yeah.
Mm-hmm. That would be great on a shirt. I come up with the best things. So, yeah. There's all these different 32-bit registers. These are like the normal ones you work with to do arithmetic. They're named EAX, EBX, ECX, EDX, but they're divided. So they're subdivided into smaller parts. So if you're using the whole EAX register, you're accidentally, if you use the smaller boxes, which they're divided into, then you could like overwrite what you're doing by accident. So it's divided into the big gray box, AX, BX, CX, DX, or like the smaller. Well, those are 16-bit, because half of 32. And then the smaller 8-bit registers, AH, AL, BH, BL, CH, CL, DH, DL. And yeah. They're also used to, like, pass in information into the functions in, like, the subroutines in assembly. So we'll use them to pass stuff into it. Yeah. Then you have these pointers that tell you how long like the stack is, and you have to, and they move around as you add memory, not memory, as you add the information that you're working with the registers, like you pop them into the RAM. It's like, I think it's supposed to be like RAM, but the pointers point to like locations in the RAM, and that's where you store them longer, so you can grab that information again to use it later in the code. Then you have all these flags that tell you, like, if something's signed or unsigned, or something overflowed. Like, what are these operations are done on? Oh wait, it could be. I guess it depends on what. If it's like a 16, like, if it's like the number's like a byte or larger, or could be the numbers can be different sizes. So anyway, you have flags that tell you more information about the data you're working with, that are like either the flag is either on or off, and it will tell you stuff, interesting things.
Flagging is stacking.
And yeah, that's about it. That's like the too long didn't read version.
Can I get a TLDR? The TLDR.
Do you grade me? Grade my mini lecture. Like that.
I don't think we've gotten to subroutines yet.
Okay. But just explaining what I just read, like, decent, like, TLDR.
You'll be able to give a better explanation when you understand it better.
For sure. Like, I'm still trying to figure out myself. System calls. Interesting.
And you didn't give an overview of the introduction. Like, come on.
Oh no, I'm not gonna do that. You know how long that took? I was on this for like 10 hours yesterday because of mod. Remember that? Remember when?
Yeah.
Beautiful memories. Thank you for teaching me all about mod. I feel I'm very happy with mod. Mod's the best. Yay, mod. Assembly system calls.
Just condense all of your notes from the introduction into a 1-hour presentation as TLDR.
Okay.
Live 137 says what's
all right.
minus 11.
I think you're supposed to do, it's like -11/3 in parentheses, and then you floor it, and then you multiply it by y or something, and then you do x minus that. A whole thing. Right, I think. Is that what you do? Is that what you do? Crap, is that what you do? I think that's what you do.
What's x and y?
I think -11's x, 3's y. I think.
Yeah.
Okay. That's the answer. When I don't want to compute that seems like annoying to compute, but then it just. Oh wait, no, that's not. I just have to floor it. Okay, yeah, I can do it.
Disconnected or something. What's the answer you got?
I didn't do it yet. I'm gonna do it right now in my head. Try to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then you I guess it gets. Where does it floor? 1, 2, 3, 4, 6, 7, 8, 9, 12. Wait a second. But then I would have to find what the decimal is to know. Wait, no, I don't. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on. Let me think. I'm thinking. 1, 2, 3, 4, 6, 7, 9. So it has to be. So it has to be. I think it's floored to 3. And then 3 times 3. 9. And then it's like negative 11 minus 9. But then that's a negative number. I'm sad now. I think I did it wrong.
What's negative 11 over 3?
Oh. Negative. Oh. It should be negative. Oh, wait. Okay, I got my signs. Okay, you're right. Okay. So then it's negative. If we go back to where I was, it's negative 11 plus. I may have spent a long time on. Maybe not 10 hours, but quite some time.
10 hours on
Negative. Negative.
Yeah,
mods.
because they're doing like the elementary official mod where you just keep subtracting until you can't do it anymore, and then whatever
Take the
you get is your
remainder.
remainder as your
And then I was
result.
like, what the
But
hell you can do
that
negative
doesn't-
mod?
That doesn't quite work as nicely, like with that intuition for handling negative numbers.
Yeah, it wasn't enough in the case of negative numbers. Okay, negative 11. Wait, what did I say? I floored it and then 9. Negative 11 plus 9. 9, 10, 11. It's mod 2. Is my answer. Mod 2 win. Mod 2. What did I say? I tried.
I think that's wrong.
I hate you. I hate this. I do. What I do? Wait, okay. Let me start. You said negative 3. Damn it. Wait, no. Negative 11 over 3. And then that's something. I don't know. I think that one. Oh wait, I floored wrong because it's negative. So you do it differently. So then it would be 4. 4 times 3. 12. So 9. God, negative 11 plus 12. Is it 1?
Yeah.
Okay, I floored the negative number wrong. Yeah.
So.
Cool. At least I got it eventually. System calls are APIs for the interface between the user space and the kernel space. APIs for the interface between the user space and the kernel space. Okay. It's kind of weird how API is used for the documentation, but it's also used for the actual stuff too. I think that I always thought that's weird. It's not just it's the documents and the stuff you use to communicate with stuff. We have already used the system calls syswrite and sysexit for exiting into the screen and exiting from the program respectively. You can make use of Linux system calls. I know this part's not super important because it's Linux, but still, I'll just read it. You can make use of Linux system calls in your assembly programs. You need to take the following steps for using Linux system calls in your program. Put the system call number in the EAX register. Store the arguments to the system call in the registers EBX, ECX, etc.
That is what we're doing.
Oh, damn. Okay, cool. So this is relevant. Put system call number in the EAX. Oh wait, as I read this, I'm gonna look at the example and put this in my head that that's what's happening. So
That's
this is
that's the A equals 4, B equals 1, C equals start of string, and B equals length of string.
That's what they're doing.
It's like that.
Mm-hmm. System call number in the EX. So this is the system call number, which is the system nut, right? System underscore right. Store the arguments of system call in the register EB. Yeah. The arguments. Yeah, are EB. These are where all the arguments are. The length.
Yeah.
2, 9. That's cool. Yeah. trying to think. 9. Okay. Called irrelevant interrupt. ADH. 80. What is H hexadecimal?
Yeah.
Okay. The result is usually returned in the EAX register. Oh. Turned in EAX. What's the thing that where you didn't do... Oh, you did say EBX. I just wanted to see if you did this to EAX, but it was EBX that you did this to. Set it to 0. There are 6 registers that store the arguments of the system call used. These are the EBX, ECX, EDX, ESI, EDI, and EBP. But I think you said you don't mess with... Did you say you don't do EDI? Or something? I don't know. I'm trying to remember which ones you said you don't mess with. Like the pointer ones.
EPI don't. Oh,
Yeah.
well, EPI you don't mess with in general.
Oh yeah.
ESI and ESP.
These are just
and
extras,
EBP.
right? Did you say ESI and EDI or extras?
ESI and EDI you can use those fine. They're
Yeah.
just like the other ones. They're just like the ones. You can use those fine and there's no problem.
Yeah, these are the ones that they recommend it using for like strings and stuff, but you just use them like whenever you can use them for whenever you want.
I just use them whenever I need them.
Nice. These registers take the consecutive arguments. Drink some water. Starting with the EVX register. Oh, so it doesn't necessarily matter. You don't have to use ECX. It just has to be consecutive. So like basically, oh wait, I assume what it's saying. It says these registers take the consecutive arguments starting with the EBX register. So like when it's giving the arguments like this one here, can you just say like EBX is 4 and EAX is 1? It doesn't. No wait, no, I mean not the sorry. I meant can you change the B to an A and the A to a B? Well, actually, I'll just try doing it. You can't.
It won't work.
Oh, so consecutive.
If you do that,
I know.
well, if you do that, it'll exit your program.
Oh, okay.
Because A will be set to 1, and I think that's the exit program call.
Okay, so when it says consecutive, it means like consecutive as an A, B, C, D. That consecutive, not consecutive as in like which comes first in the lines of the code.
Yeah.
Okay.
They just all need to be set to the right values before you call the interrupt.
Mm-hmm. But I think what you could do, though, and still make it run is like if you did this is D. Wait, I want a simpler one. Where's the this one? I think the number you put into the EX determines what kind of call happens.
Line 137 says the number you put into the EX determines what kind of call happens.
But because of consecutive thing, I think you could say you could turn this to EBX and then turn this to E. Wait, no, that's a D. A, B, D. Oh wait, so you can't even like use. Oh wait, ECX is used for message. Oh wait, oh yeah, and you have a limited. It's so weird. You have a limited number of these registries. It's so awkward. Wait, I'm just gonna start up here. So you have A, B, C, D. Oh, you used all of them. Damn it, so I can't do it. Never mind, my thing won't work then. But then, no, wait. Oh, move ECX D. Yeah, so, wow. Okay.
I get tired, by the way. I'm going to sleep soon.
Okay. Whenever you need to, just go to sleep. You can go to sleep whenever you need. Yeah. I don't know. I guess I was just wondering if the argument was like one takes EAX, one takes E. Like if there were only two arguments, there's like a lot more than I thought there would be. But if there were only two and it was like EAX, EBX, couldn't you just then like replace EBX with like ECX and then EBX with EDX? Because the only thing that matters is the consecutive order, not necessarily their names. Like, does this have to be consecutive? I thought. Does that make sense?
You just need them all. So for the call, you just need them all to be set to the right values when you run the line int ADH.
Yeah, but like,
Like A, B, C, and D just need to be set to the right values.
Mm-hmm. But like EA could become EB as long as everything stays consecutive, as in like ABCD order, ABCD.
Yeah, as long as they still have the right, as long as those registers are still set to the right values. It doesn't matter what order you do them in, or even where in your program you set the value to that. You set them in the right values. Just as long as they're at the right values when you call the interrupt, that's all that really matters.
Mm-hmm.
So like I could set ECX to something way up at the top, and then if I don't change it anywhere in between, but by the end I change like A, B, and D, and set those to the right things, then it should still just work.
Yeah. Well, maybe I'll just type out what I mean, because like, wait, what I actually mean, I don't mean like ordering it, like copying and pasting it, moving it up and down. I actually mean like the actual letter itself. Like for example, if there was like. This isn't actually in the code. But...
In that example, if you change the B to A and you change the A to B...
Well, not that example. I don't think that's good.
You would have that. That would not work.
Yeah, not that example. Because I realized it doesn't work in that example because there's like too many A, B, C, Ds and stuff. But if there was only two, if there was just two only, and it was like EAX, EBX, and that's all there was, maybe that will never happen. But if that's all there was, couldn't you just say, CX, DX, and have it be the same, or no? It just has to always be A. Like, A will always be A. Because it's the same order. CD, A, B.
Okay,
that's why.
So I'm assuming that this is just like in general, like using these registers. You mean just in general using them?
No, for using the registers. And passing
an argument. I thought we were still talking about like the interrupter or something. I thought we were still talking about like the println command. No, For in general, just using the registers, it doesn't matter which letters. Yeah, just use them.
Or keep them. Okay, good.
Yeah, it could be A, it could be EAX, EBX, or it could be ECX, EDX. Yeah.
Well, I do mean like passing. I do mean this, but like imagining there's so many things. But imagining there's only two things going in. Here, there's more. That's why I didn't like these examples. But if there was only two,
it has to be set up that way. You can't set it up properly with less than that.
Yeah, but theoretically, if there was one with less, because I only know is the print. If there was one that only took two,
then you would use the registers that you need to use.
Yeah, so that means it has to be A. A can only be A. It will never be. It could never be B in any circumstances. Is what I mean.
Well, not these circumstances.
Well, I'm not asking about these ones.
Sometimes it's interchangeable, but not this time.
What'd you say?
Sometimes it's interchangeable, but not this time.
Sometimes. I think, okay, so it's related to consecutive order.
137 says the int0x80 thing is what the interrupt is returning to.
Yeah, referring to.
The interrupt refer to. Yeah. I was just wondering with how to pass in the arguments, but I think it makes sense. I think it works. And limit it. Depending on how many arguments there are, because there's a limited amount of registers. If there are more than 6...
Yeah, you can't interchange them for this thing, because for all intents and purposes, the only thing that line sees is numbers in A, B, C, and D. It doesn't know what they mean or which numbers were moved where. It just knows that they're numbers.
Numbers. Wait, what was it? If there are more than 6 arguments, then the memory location of the first argument is stored in the EBX register. More than 6 arguments. Wait, how many? We have like more than 6 arguments. But there's like only... Well, I guess there's some extra registers, because there's only like 4 main registers anyway. The memory location of the first argument is stored in the EBX register. Huh. Oh, so in this case, like, it would have to be, if there are more than 6 arguments, and this one has to be an EBX. The following code snippet shows the use of the system call system exit function. System exit. Move EX1. That's the system call number. System exit. Oh, wait, I should have just used this one. Wait, no. I'm gonna say, maybe I should have used this one as an example. Like, this has one. Yeah, this is like, this takes like, well, this isn't really like a method, right? It's like it's an interrupt thing. Wait, maybe that's, never mind.
Yeah, kind of.
Yeah, this is kind of different. The following code snippet shows the use of the system call. Oh wait, but they're all system calls. Well, these are system calls. So these are system calls like methods? Can I think of them like that or not?
Yeah,
You think?
I'd say so.
Because they take arguments to do stuff.
They're like functions. They're basically functions.
Yeah. Okay, well, I guess I will use this as an example.
But of course, like, they're not like methods, like kind of thing, like methods in C#.
Oh,
but
like,
they're
yeah.
pretty much like that. Like they're not like as they like returns this type or is public or static or whatever. it's not. You don't have that kind of stuff. It's just you just run it.
Does stuff. Cool. But yeah, maybe so this one takes one thing that goes into it or whatever. So this has to be EA, it can't be EB or C or whatever. Always EA.
Yeah.
Okay.
Because how is it supposed to know after that code runs? How is it supposed to know? All it sees is numbers in A, B, C, and D. It doesn't know the context of those numbers or what they mean. It just sees the numbers.
Yeah. I don't know. I thought since only order mattered.
It'd be like if I gave you this function and I just gave you 3 random numbers and you're supposed to tell me which number goes first. And like which number is supposed to be the first thing, and it's like they're 3 random numbers. How am I supposed to know?
I thought as long as they were ordered in a certain way.
Yeah, it'd be like I assume that it's in the order that you gave them to me in.
Yeah.
That's what I assume, and that's what it's assuming here. It's assuming that it's in the order that you gave them in.
Oh wait, I see. So it'll always check
the A, B, C, D order.
It checks the first one, second one, and if in the first one it needs an argument. So it's like, where's my thing? Like I'm doing it in order. Like it needs this, and that's why it's A.
Yeah, it needs A, B, C, and I mean it doesn't. Now. I mean, of course, those lines can be moved around.
Oh yeah,
that's fine.
But it will check the A, B,
But all
C.
matters is what the register's values are in A, B, C, and D when you run the int ADH line or int 0x80.
Yeah. Okay. Now I get it. So they can. Yeah. Makes sense now. The following code snippet shows the use of the system calls this right. ECEA. Anyway. Yeah, so message length goes into D. It's ABCD, so that's 4 arguments or parameters or whatever. EC takes the message that you want to write. EB. Yeah, and this is like where it does this stuff. System call, file descriptor. I wonder what stdout means, but it does say file descriptor. All the sys calls are listed in user include ASM unistage. Okay, together with their numbers, the value to put in EAX before you call interrupt 80. Oh yeah, that has to go in EAX. Oh, system exit, system fork. Name EX, EBX, ECX, EDX. Oh, I see. EDI. EBX, ECX, EDX. I wonder, was ESX on the last page? I don't remember if they talked about ESX. But I remember EDI, I think. I don't remember what they're used for.
What's ESX?
Yeah, doesn't that seems new or something? I don't know. It's just like ESX is just here. This fork.
And I don't think I've heard of that one before.
Me neither. Oh, there were all those missing registries. So that's probably one of the ones that was like dotted out that they didn't talk about. Sysfork, struct, pate, regs. I don't know what this is. This interrupt. Structure part.
Struct pointer, maybe?
Oh, pointer. Sysread, unsigned int. Character. Oh, these are going to be used in the tutorial, so just showing some examples. It doesn't tell you what they do yet. Unsigned int, char. Size t. Const char.
I wonder if that's a typo. I wonder if it's supposed to be ESI.
Oh, yeah, ESX.
Type ESX into JDoodle and see if it turns like the register color, like
Oh,
that
yeah.
blue color or something. See if it recognizes it.
Oh wait, this is what we want. Oh, it's
Right,
probably...
yeah. It's a typo.
That's
It's a
great.
typo.
You were like ESX. Like I've never heard of that.
I was like, I've never heard of that. What is that?
Because the thing is, like, a lot of these things, even if you've never used them, you've heard of them. You're like, yeah, I've seen that before, or I know that exists. Then you're just like, what? I knew it. I knew this was something weird. Because I was like, it's like when you're playing that game, the observation duty. Like something's not right. Something got changed.
Yeah, when I saw the ES and then followed by the EDI, I was like, that feels like that's supposed to be ES. Okay, well, whatever.
Right.
That's ESI.
It is. Sys open const character int. Interesting. Sys close.
Line 137 says.
What Machigai Sagashi? I think that's like found the mistake. Finding the mistake or something. Sys close. Unsigned int. Example. Hooray. If I finish this, once I finish this example code, you should go to bed. So you get plenty of rest. And then you feel good tomorrow.
Line 137 says it's like the spot the difference game.
Yeah! That's what I was saying,
Yeah,
because
crazy
I was saying
tomorrow.
observation duty is actually a spot the difference game, and we were like, it's a game he has on Steam, so he showed me it once. Yeah. It was like spot the difference. Did you? Oh wait, no. You wouldn't have been able to spot the difference, right? Because you didn't hear me read about the whole page, like reading all the registers. But I feel like you would have spotted the difference if you heard me read all the registers earlier.
Well, did it list out all of them? It didn't talk. There's at least one that it didn't talk about. So.
Yeah, that's true. But
Like
if it was
that
listed,
one
but if it was like
that
here,
you
they make it sound like it's important. So they should have mentioned it. It's weird that they would mention one of the ones that were like blacked out or whatever, if they were just gonna bring it up later. Right. So. Yeah. Now I see at this point. You know what? I'll just delete. I'm gonna delete their stuff because I already looked at this. I can just look at it later. Like, it's literally on the website. I'll just delete all this. I'll just keep your stuff, because, you wrote that. You took the time to write all that. But you wrote this, like, fast. Maybe all you had to do was this push thing. Okay. Oh, wow, there's a lot of parts. Okay. Copy. Wish they had a copy button. Please enter a number. 1, 2, 3, 4. You have entered 1, 2, 3, 4. Wow. Does it actually want you to... It will actually ask you to type this, I wonder? Or just... Oh, I see. So the order of these different sections doesn't matter. Put this in data. Oh, wow. You really can type in it.
You have to type in the standard inputs, I think.
Oh, wait. Oh.
You have to in the
Oh, yeah. Not wait. I just like typed in the
document.
output. That's awkward.
Yeah, you have to
Thank
type
you.
in the input and then run it. Yeah.
Oh, you're right. Oh, wait. I don't think I submitted it. How do I submit? I pushed enter, but it made a new line.
You have to. You just.
Oh,
you
I just have to
type it
push
in
the
there and run it.
star.
Yeah.
Wait, nothing happened. Oh my god. Oh, running. Wait. It's not doing ding. Am I doing it wrong? You have entered. I just copy and pasted it. What they had. Is awkward.
Let me look at this.
Sure.
3-2 store at num 5. TDH. This is lend display message.
Tell me if you want me to move the screen.
So that one doesn't print that. This message? What is this message?
This message? You have entered.
Oh. Well, it's not reading. Maybe check the interactive box, maybe?
Oh! Oh. Okay. Maybe it'll like...
Or... No, that didn't?
No.
Oh, maybe not that then.
It's not this? It's really not typing in here? Oh yeah, it doesn't. That doesn't do anything. You can just delete all this.
Maybe, yeah, uncheck that. I don't... Yeah, what is this?
Interesting.
Like, it should just be typing in the standard inputs box.
Yeah, and then it should...
Let me see.
Hey, there you are.
I'm not looking at the right thing. Can you...
Can I?
Not looking at the right thing here.
What? Oh.
I wonder if the share thing is messed up.
Oh, is it? I'll give you another link.
Click somewhere on the page.
Okay.
Okay, no, that's working. So the code that I'm seeing on my end is not the code that's on your end.
Oh, do you have to like reload it or something?
I'm gonna reload.
Okay. I was just reshare.
Just join session. But like, do the fucking thing. It's not doing it. I don't see the right code. Can you like Control A everything, Control C, then like paste it back in or something?
Sure. Okay, I just deleted everything.
Why don't I see this on my end? Can you close the? Hold on. What if I do this?
But I don't even see. Oh wait.
End that. If I end
Skip.
that and then open it up again.
Okay.
Fresh. Yes, join session. Okay, yeah, undo. I think it's fine now.
Okay.
Okay.
Nice.
Why? How the fuck does this work? Why? Yeah. Why isn't this working?
It might be something related to JS
Maybe.
Doodle.
Wait. What if I need? What if this needs to be 1? No. What did I do? Let me take a look at my other code. Maybe I figured it out before.
Oh.
I probably figured it out before. Where is read line in my code?
Yes.
That's not what I'm looking for.
You know what? What if this has to be section?
Oh, I know. No. I know the problem. This number. They have 2 in the example.
Okay.
This needs to be 0, not 2.
Really? They made a mistake in their example?
No, they didn't
Oh.
make a mistake in their example. It's just different from their. It's just different from their environment compared to our environment. In our
What we're
our
using.
code, it needs to be 0. In their code, it needs to be 2.
Oh, okay. Because it can be different depending on what system you're on.
Yeah.
For that. Oh, wow.
But now it should work.
Okay. You're right. You went 1, 2, 3, 4. Nice. Which part did you change? Which one became 0 and 2?
Yeah. That line right there, line 24.
Oh,
Line 24.
Okay.
I changed that to. I changed
Nice.
that from. It was 2. I changed it to 0.
Nice. DX.
I had to go and look at my old code in order to figure out because I did a read line thing in there, so I had to look at that to figure it out.
Got you. User message. Delete. That's cool. Read and store user input. EAX3, EBX0. Yeah, I wish they commented all these lines for what all the arguments or whatever parameters are for this system call. 3.0.
You wish they what?
I wish they had a comment on every single line saying what each of these like parameters or whatever are for the call. Numeric 1 for sign for that information. How many characters can this handle?
Up to 5, it looks like.
Oh, that's why it said 5 bytes.
Just looking at the code, I think it's 5.
Yeah. I'll put 6 and see what it does. What? Yeah, you're right. I just dropped it off. One for sign of information. Huh. 1 for sign. Wait, if I said 1 for sign, what if I put negative numbers in? Like a bunch of negative numbers. Will it still be 5 characters? Or does this count as a character?
You can literally just type letters. You can even type letters.
Yeah, that's true. Huh. Oh yeah, because that's a character. Like this is it's just a.
It's
Yeah,
not
I get
even
it,
checking for numbers. Like it says, please enter a number, but really the code isn't checking for numbers.
Oh yeah, it's not. Yeah, that's why it says please. It's begging you. It's like please put in a number, not you must put in a number.
Please put in a number.
Please. Which I did not do. Oh, this 5 is this? How many it supports? Like I could put like 10, and there'd be more numbers. 6.
You have to change that number in the code as well.
Oh, I would have to change with it.
Online. What line is this? Let me scroll up. Wait, I'll just look at it on my end.
Oh, this one, maybe.
You changed that to 6. So if you change this thing to 6, I could also do this.
Oh wait, you making changes isn't changing mine. Oh wait, no, never mind. You're doing it on the bottom. Oh dang, what are you doing? Equals number.
Do that.
Ah, instead of that's cool. Equals num. But how will it? Huh.
I made the new thing len input. So then you can just change this number in one spot and you get more numbers.
Where is?
Assuming I did this right.
Oh,
yeah.
Okay. Where's len input being set to 6? Where is?
At the very bottom. Very bottom.
This one?
New one that I added.
What's num? Well, where's num being set to 6 or whatever?
Right above. Yeah.
This one? Oh wait, I mean this one. Like a click.
No, num is being defined right above the very bottommost line.
Oh, this is really. Oh, here, this one.
Yeah, that's where
defined.
num is defined. That's where it's defined.
Oh, okay. That's cool. It's kind of weird how some stuff is defined in section, the data, and some is defined in the BSS part. Like this one being, please enter a number and blah blah. You have entered, and then.
Yeah, well, I mean the stuff in .data doesn't change. The stuff in .bss does change.
Oh, okay. That's the only difference, really. Is like you can change stuff down here. Cool. That's really cool. I like the modifications you made. You like made it better. Yay.
Yeah, so now you can just change that number and that lets you add more things.
Cool. 8, 9. Nice. You did that really fast. 9, 10. So there's an extra one. And the 8 one shouldn't be included. Yay. Nice. Thank you. But yeah, you should get to bed. I think I will end up I'm gonna make a JDoodle account later when I'm done streaming, and I'll save this.
You can save this code somewhere.
I will. Or actually, in case this like page crashes, I'm gonna like copy it into like a text file or something. But also, like I'll make an account.
Yeah, I mean just control A, control C, and go to the clipboard, and then you can Windows V open up clipboard.
Windows V. I didn't know you could do that. Windows V opens up your clipboard. Yeah. So many interesting. Wow. Was it the? Was it alt? These are like so useful, like useful shortcuts for things. Like, what was the other thing? It was like alt.
Yeah, the clipboard is especially extremely useful.
Yeah. So I don't have to do things like the slow heathen way.
Yeah, so then you can have like multiple things copied at once.
Oh.
If you haven't done Windows V before, you should do it now so you can turn it on.
Okay. I just hit Windows V, nothing happened. Oh wait, no, never mind. I just did it wrong. Oh, it's not even turned on. Turn on clipboard history, it says. Oh, nice.
Yeah, and then when you copy something else, something new gets added to that list.
Yeah, I won't like override it and be like, well, I lost my thing I copied. Oh no.
Yeah, it only saves up to like maybe like 10 things or something,
Fine.
but
That's
like
awesome.
that's too long.
So Control
That's
C.
more than one. That's 10 times more than one, right?
It is. Wait, my clipboard's still empty though. Maybe I just didn't copy it right.
Did you do Control C?
I did. Okay, I Control C like many, many times, so maybe it'll be there multiple times. It's empty. Your clipboard is empty. Interesting.
Really? Huh.
Let's see. But if I copy and paste, like for example, clear this. See, it's on my clipboard because I just copied it back.
Mm-hmm. Well, I can't see what Windows is showing on your clipboard because I can't see your clipboard.
Well, nothing, because it literally says your clipboard is empty. Like that's all it says when I open it. It says your clipboard is empty. Let's make some history together by copying multiple items to it. Weird.
Maybe there's something weird with this website.
Maybe. Well, I'm on Windows 11, so maybe it's like broken. I'd rather have the clipboard not work than have my search bar not work. So, there's that.
Yeah, I mean, maybe you'll figure it out. You'll figure it out eventually.
Yeah, not a big deal. I don't even use it anyway because I didn't even know it existed. So I'm not really sad about it.
Yeah, once you figure out how to use it right, it'll be very convenient. I mean, it not working right. So actually, it not working right now might be because you already have that. Like, try selecting something different.
Okay.
Try like selecting something different and then copying it. See if that shows up in the clipboard.
Nope, clipboard is empty.
Weird.
But maybe they changed it so the command is different to copy to the clipboard on Windows 11 or something. It's not Control. I don't know. I'm C, but like they did another command for it.
No, it shouldn't. That did get copied, right?
It copied, yeah. Let me see. So it copied.
Okay.
Yep.
And it's not in the Windows V clipboard.
Windows V.
That's weird.
Your clipboard is empty. Let's make some history together.
Yeah. That shouldn't be doing that. That shouldn't be doing that.
What does Google say? Why does my Windows clipboard? Okay. I did just activate it.
Mm.
Well, this is just typical.
Clipboard history not working with it. What does that one say? Clipboard history not working. Yeah.
Wait, the LifeWire?
That one, like that first solution is like a shitty solution. That doesn't answer your question.
It doesn't.
Honestly.
That's true. Oh wait, this one.
The first one. Why is clipboard history not working?
It is turned on.
We already have that. Scroll down. You literally just did that pretty much.
It's true.
Scroll down more. Windows key plus V, clipboard not working. What is that?
Trouble with clipboard history. It's maybe this one. What do you want me to click on? This one?
Oh, I think what this might be telling you to do is the kill
Restart it by killing it.
And then restart explore.exe. Maybe that fixes it. That's a whole thing.
Oh, you mean just this small text? That's what you think you're gonna do?
Well, that and also compared to like the one below, which is very similar, it looks like they're gonna have you like restart explorer.exe, and maybe that fixes the clipboard or something.
Oh.
Which, if that works, I guess it kind of makes sense.
Well, I could just restart it. I mean, whatever. I mean, start whichever one they want. Restart whichever one they want.
Yeah. But basically, yeah, basically what
What
it's
do you
saying is
restart?
open up Task Manager and then select and then find explorer.exe and end task, and then like use like the run menu to run explorer.exe to start it up again, and that should fix the problem. When you kill explorer.exe, it'll get rid of your taskbar. But in Task Manager,
Oh.
you can run the you can use the you can open up the run menu, and then in that you type explorer.exe, then your taskbar will come back. That's pretty much like it restarts all those UIs.
Oh, okay. Well, restarting the actual computer would do the same thing, right? But without taking my taskbar
Yeah,
away.
restarting the computer would do the
Oh,
same
let's
thing,
do
but
some
you
other
lose
thing.
all your tabs.
You're right, but it'll it's gonna restart in the next few days because it always does, just randomly. So I'll just wait for when it does that. Mhm.
I'm gonna go to sleep.
You're gonna go to sleep. Good night.
Night.
Thanks for helping me out. Thanks for hanging out earlier too. It was fun.
You're welcome.
All right. Good night.
Night. Bye.
Bye. Okay. I will just copy paste this in somewhere else. Let's see. Okay. Wait. Save it. Introduction to taxes? What? In 5th grade? Oh. It's probably like for Texas or something. What? What is TX Tex? Oh, Tex. Texas. Oh. That's income. What else does thing say? Payroll. Huh. Oops. Periodic table. Okay. Wait, text isn't an option. This is like a single. But this was supposed to be a minus sign. I think what hair taxes. I think there's like a word missing here. Let's see what the explanation is. Okay. That's here to me think does nothing. Subtract. Oh, it is subtraction. I thought they meant deductions, like when you get a tax break. What?
Line
Invest them
137
into
says, I think the correct
That's
answer
not
is
an
to
option.
invest them into the
Stupid
stock
question.
market.
I got it wrong. Store them in his lunch bag. In the stock. That is. You're right. The only correct answer is not an option, though. Sadly. Lunch bag. Sorry, lunch bag is not the best way because it can get messy and coins might get lost or accidentally thrown away with the lunch trash. Okay. What do they want? Count and note them? But he could still lose them just because you have them on paper doesn't mean. Just because you have them in paper doesn't mean you. Like, he could just drop the coins on the ground, write them in a notebook. Like, what is that gonna do? Keep track of his coins. This is dumb. This is not a fair. That wasn't a fair question. That was not fair. I hope all these are not unfair. Virtual science box. Of course, this is like the same kind of question. Uh-huh. This one. Wait. Record them on a. This one then, actually. I wonder what it will say about this. It'll probably say, like, oh, apps aren't safe to use because, I don't know, stranger danger. Are you serious? This two-part system means Paul is less likely to check his points. And it creates one more task for Miss Schiffman. Who cares? It's her job as a teacher to do work. Why can't the kid just look at the shared spreadsheet? Seriously, this one is A? This is dumb. A shared app will make it easy. Easy too for Paul. This is grammatically incorrect. To keep track of his bucks on his own while allowing Miss Schiffman to assign them instantly during class. This is ridiculous. Make it easy? What? You're not supposed to be using your phone in school anyway, I would assume. So why would you use an app? And how can you trust the kid not to, like, lie about how many science bucks he has? He's literally a 5th grader. Oh, I guess she's supposed to assign them. But that's extra work for Miss Schiffman. It literally said that in the third option. I'm tired of these classroom coins. Serious. Better be this. This is ridiculous. Items in the classroom can easily get lost or stored in backpacks. Oh my god. But that's more work for the teacher. What? You could lose them in a bag, too. Individually accumulate. How is this part of any curriculum? It's just it's so random. It's just like a random one. Ugh. Oh, this one's, thank God, the fair question finally. I memorized the answer to this. Sanity. think I'm supposed to do math. Babysit. Just have more money, exactly. That's what I do.
Line 137 says if you don't have enough money, just have more money.
That's the solution, right? That all countries like to take. It's like, we're running out of money. More money. Have more. This is interesting. This is the Texas curriculum, apparently. Which is, so it's very different from the standard 5th grade curriculum. And apparently it's also unfair, so very interesting. Oh, I just realized I had to do it. I missed a unit test up here. Income tax. Obviously. I think once I finish this unit test, I think I'll try a Python thingy. Because I like cursed things. This is math. This is the math curriculum of Texas.
Line 137 says, is this considered part of math?
Yeah, this is the grade 5 math curriculum for Texas, apparently. And all these boxes that are like light purple, and then there were some up here. There actually were some up here too, and all the boxes that are white are different from the Common Core, and they're not fair. So yeah, very unfair. How you should store your coins? Like, are you serious? I feel like the reason some of these things, well, no, but some of the like the unfair questions are because, like, instead of teaching actual math, they're like, let's just make up questions because it's too much work to teach math. They will get the phone for free. I like this option. I wish we lived in a world like this. This one again. Luckily, I remember the answer to this unfair question. Disadvantage. They require a username and password, which you could forget. Uh-huh. You know, I found out too that like Social Security and stuff like that was inspired by what was it? inspired by socialism or was it communism? I'm not sure. Okay. Exorcism.
Line 137 says, wouldn't mortgage depend on whether you have a fixed interest or variable interest loan?
You're not supposed to ask those types of questions when you always assume everything's just the same. But yeah. I think so. I think their meaning of like fixed and variable is like if things change a lot, if they probably change a lot, then fixed. If they change somewhat but not really that much, then they're putting it into I mean the opposite. Switch the two. You know. First one was variable, second one fixed. It was a weird. The whole thing was weird. That was very weird. I feel very weirded out. I was not expecting. I was expecting math. I wasn't expecting that. By the way, if you want to VC, I'm down too. By the way, just in case. Morning, Sweep. Hey, got the two Python guys.
N_sweep says good morning.
You just showed up right when I was switching. Oh, it says C#. I meant Python. You just showed up when I was switching to Python. Because up till now, I wasn't doing Python.
N_sweep says nice. Great timing, LUL.
I know, the it's a sign from the universe that...
Line 137 says no step on Snick.
No step on Snick. Exactly. I'm so lucky. Okay. Oh, now that you're here, I can continue from yesterday. So, guess what, Win? I made this with a lot of help. Okay, wait, where is it? I made this with a good amount of help from Sweep, who corrected all my many mistakes. Or helped me figure out why things not work. And I said that I would rewrite this whole thing using a different way. So I used the, concatenation, but now I'm going to try using join. And, by the way, you said I can use join, right? But insert and append aren't really, you wouldn't use insert and append in this, method, right? Mm-hmm.
Line 137 says, oh nice.
Yeah, lists. So we don't.
Line 137 says insert and
because you did bring them up, but you weren't like implying I should try to use them in some capacity. But to make the join approach work. Oh, okay. Well, I'll try to rewrite this again with join and maybe try to use insert and append. I want to try to rewrite things with as many. Like if I'm aware there's another way to do something, I want to try to do all the different ways. The deal with join
N_sweep says the deal with join is you have to collect up a list of things to be joined first.
I do. So you may want insert. Oh.
Line 137 says, yeah, that's a good point, Carrot.
Oh, wait, with join, I'm joining things, and I'm using, like, a separator thing in the middle.
Line 137 says the input to the join method is a list, or more generally, iterable.
Oh, I learned yesterday I learned from Sweep that, well, maybe you were there. I don't remember, actually, because it was late. But I learned that that strings are treated like lists. Well, what is it? No. Yeah, sometimes strings... No, sometimes, yeah. Strings, like, act like lists, and they're weird. And it makes me sad. And you can say something
N_sweep says, yeah, that's right.
Yeah, you can say something in string, and then it will be treated like a list. Like it'll iterate through all the characters in that string as if they were like part of an array or a dictionary, or what do you call it? Or list? You call it?
Blind 137 says I guess they're both iterable.
Cursed. This cursed. This language is cursed. Okay. So, isn't everything all? Do you mean when you said? Now I'm wondering, when you said you need to make the join approach. Wait, you said you have to collect up a list of things to be joined first. I already have a list of things. That's my input, I think, right? It's a list of words.
Blind 137 says lists are mutable, whereas strings aren't.
I see. But then, remember when you said like a list is like a Python's array? But arrays aren't supposed to be able to change size, at least in C#. Or I think that's like a feature of what arrays are. So then they're not really arrays, I suppose. Maybe that's why you call them lists. They're like arrays, but mutable. Oh yeah, I need to open up another exorcism tab so I can see the instructions.
Darkus says I mean teating string as an array of characters is pretty common in a lot of programming languages.
Oh, well, I mean, I was talking about that list or arrays. Oh, you mean you're talking about like treating a string and then being able to work with it like an array is pretty common. Ah. Okay, I think they have an example of dot join. Oh yeah, yeah. You need these. I just need. I think I know what I should do. Well, I don't know. Dynamic array. Oh,
137 says dynamic array. I mean, oops.
I see. I guess I need to see how append and what's that other one again? Append and insert are used.
Blind 137 says Python list is actually an array and not a linked list.
Oh, okay, but still a array. Okay, so this just adds one to this array list thing. I'm not sure why would I use append? In that one. I think maybe I'd use insert. I don't know why I would use append. Because I'm not adding anything onto the list. Because they're giving me all the words I need.
N_sweep says you may only need
insert.
Insert.
They're just related. I see. Let's see what insert does. I think the only thing I would use is like something to take out, like the opposite of insert, like remove. Because I just need to get rid of the first item.
Says append is like saying dot insert -1 item.
Oh wow, and append is like saying dot insert -1 item. Oh, what is that? Append. Wait, insert. Wait, I need to see what the output is. Apple, banana, cherry.
N_sweep says puts the thing at the end of the list.
Oh, at the end. Apple. Orange. Oh. So here it puts it at 1, I guess, like where it starts, or like so it can go 0, 1, 2, 3, 4. And that one, -1.
N_sweep says here you're specifying you want orange at the first position.
Ah, -1. Okay. I don't like. I know, Wind. I know you don't. I know.
N_sweep says try chanting the 1.
Try. Okay. Wow, this is slow. I see. Hmm. But I don't think I would. I don't think,
N_sweep says try using append instead.
yeah. Oh, I think you're saying, like, maybe try to take a pen, like, append the
N_sweep says only takes
prefix.
1 item, no integer.
But then if I use, like, I was thinking, maybe there's a way to do it. Actually, there probably is a way to do it. I'm just like, I have to think about it. It's gonna take time because they're feeding me a
Line
list of
137
words.
says one thing important to note is that the insert and append methods modify the list in place.
Yeah. Because I don't think I need to change the list. The only thing I need to do with the actual list itself, they're giving me a list of words. I need to remove the first item from that list. And then that's the prefix, and that's the prefix is what I'm going to append to the front of each word in the list. That's what this thing wants me to do. So I think I just need to remove that first one from the list instead of like appending. Because the append, I can't do anything to strings with it because it's apparently it's like, right? Oh, can I? Actually, no. It was join that you can't use with lists, so I should be able to do something with it.
N_sweep says the output requires the prefix at the beginning too though.
Oh yeah, I forgot about that, yeah. Oh, it does? But maybe I actually I can use like append, right? Or would you say, can I use append to actually modify the individual words in the string, in the strings in the list? Like, could I use append to actually put the prefix on each word in the list? Or just, no, because it's not
137 says can I see an example of what the function is supposed to do?
Yes, you can. So this is, I solved it differently over here, and this is, the output should be, wait, running tests. Right.
N_sweep says append isn't for adding characters to strings,
Okay.
it's for adding new items to a list.
Lists only. Thank you. Where's the... Wait. I went to the wrong one. It was task 2. Sorry. Let's see. Okay, here's an example. So the input data is this. Oh, this whole thing is the input data. And they want the prefix auto, like autodidactic, autograph, automate. Oh yeah, autochrome.
Line 137 says I see, I think I understand.
Ah, yeah. And then the result, oh here. Input data, expect it. And then it will look like autodidactic, autograph, but with the little double colon in between each one. Yeah. I want to try to, but I didn't use dot join in what I did, so I want to try to rewrite it and use dot join. I think, wait, I'm gonna keep these together. Dot join chickens. Okay.
Wind 137 says
Hen, egg, rooster. It needs to look, or maybe it already looks the way it should, because I just need, oh, but I do need to put the auto in there, in the didactic part. Oh, but, I still think I have to make a for loop, though. Didn't you say there was a way I could do it? You said there was a way I could do it without a for loop, so I want to think about how I could do it without that. Or maybe I'm wrong. Because it doesn't, I don't know. Maybe I'm wrong. Oh, but I still need the loop for the prefixes.
Says you'll probably still need the loop
oh,
to add
okay,
the
to go through.
I was probably wrong when I said that yesterday.
You do wind? Going through each one without a for loop. Is it any kind of loop? Is that like a trick? It's like a loop of some kind? They're good.
N_sweep says at wind 137 without a comprehension.
Whoa. I don't even know what a comprehension is, but I don't comprehend.
N_sweep says cool.
Don't comprehend the comprehension. Is it like super advanced Python? Or is it something I would actually be able to use? Not really?
Wind 137 says not really.
Just by using join. But then... But then you... Okay. Okay, just join. Maybe that's what you were thinking. I think that's what you were thinking yesterday, weren't you? And sleep, or you're not sure.
N_sweep says I'm not seeing it.
Maybe I should start. trying it. Vocab words. What if I already start returning? I need to get the prefix though, so I know. Wait, vocab?
N_sweep says sorry to repeat a message but TDS skipped it. Try to talk about what your list of items has to look like for join to produce the output you want.
Yeah. I think I need, I just need N in front of each, I mean, the prefix needs to be in front of each word. But, so I'm gonna make a variable to put the prefix in.
137 says maybe a spoiler, but my way without the loop leaves some ugly bits at the end that you have to chop off.
It does? Oh, I think I know what you want. I think I know. Wait, let me guess. Prefix. I think I know. And then I can chop them off with like, oh wait, I can't do that with a pen. I can't do that with insert. I can just, I don't know, be sad. Wait, it leaves ugly bits? Wait, no, wait, then I don't know what you want. Because I was going to do something that I thought... I think I'm wrong. I think this output's not going to get what I want. But I'm going to try anyway. So prefix equals...
Wind 137 says maybe just try it with the for loop first.
Well, this won't take long. This is like short. I was just going to do 2 lines. But it's probably going to be wrong. Now I'm sad. Wait, I can't use this in a oh, because it's a string. Oh, wait, no. Okay, never mind. I wanted to use prefix in here and have it not be...
N_sweep
Actually?
says at salttoserenity line 28 off
Never
by
mind.
1. Laughing face.
Oh, yeah. Okay, I keep forgetting you have to do that. What was I even gonna do? Oh. I don't think I can do what I want it to do anymore. Never mind, it doesn't work. It wouldn't work because I would need to have this. I want it to have like prefix like in here, and then I want it to use, but I don't think that works like syntactically. And then I wanted to use dot join with vocab word. You know?
N_sweep says also good call on the indentation, but your
Oh, yeah.
indexing is off by 1.
Thank you. Not again. I said to sweep yesterday. I was like, if I got $1 for every off by 1, I wouldn't have to ever work. That's it. Like I'd make more money than any programmer.
Blind137 says that's basically the idea of what I had in mind.
Me? What I had in mind? Really? Yeah. That's what I was thinking. But how would this wouldn't leave ugly bits at the end? I don't see how that would happen.
N_sweep says, oh, this is clever.
Into the separator. Yeah. I just don't know how to put it in the separator. Obviously it's not like this, but I don't know how to do it. Because I can't do... Can I do this? Plus? Prefix dot join? No, wait. Would it accept this? Is this valid? No, it's probably not.
Blind137 says, wait, is the output supposed to end with?
Nothing. No, it's not supposed to end with that. Oh wait, I need to get rid of this other stuff, but no, it's fine.
Blind137 says, oh, okay, then there wouldn't
Vocab
be
word is
any
not
ugly bits
defined.
then.
Oh, no ugly bits. Nice. What happened? Name vocab word not defined. Vocab words. This keeps happening. Also, I made a mistake yesterday where I put the, instead of, I didn't have this indented. I mean, I had this indented by accident. No, wait, no.
Blind137 says line 29 is
Yeah,
almost
I
right,
did.
but the join takes precedence over the...
Anyway, I tried returning in a for loop and then it broke. You're not allowed to return in a for loop, are you? Because it doesn't make any sense. Because it broke it. Oh, almost right, but the join.
Blind137 says, so it would have to be prefix dot join vocab_words.
The join takes precedence over the... Oh, plus. Join, I'm thinking that join takes precedence. Oh. Oh. Oh!
Blind137 says,
You can
kinda
do that?
like
That's how you would do
appendus
it.
Y-way.
That's the syntax for it. That's so cool. To make... like this?
Blind137 says join is more important over addition.
Join is... Oh, so it will do this. It will just... I see. That's what precedence means. That's so cool. I was going to use those instead. I don't think it really matters, but... I guess I could keep this. It doesn't really matter. It's going to return anyway. Wait. Sad face. What the... What is it?
N_sweep says you want those spaces in your separator.
Oh yeah, I do. That's true. What is all the plus 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 plus? This is, where did this come from? Oh, return. Oh yeah, because it's not spaced out down here. Ah, thank you. Thank you, guys. Cool. And it's shorter. It's like a lot shorter than this one.
Blind137 says nice.
I'm gonna make a note of what's going on. It's not, I feel bad saying mine because it's not really mine. Above is the second solution. Or the first. Here. I should credit you guys. Above second solution. Courtesy.
N_sweep says my brain absolutely cannot stop hearing the bot refer to line 137 instead of saying wind 137 LUL.
Wind. I like how the bot calls you wind. Line 137. Oh, you keep hearing line 137. I'm gonna call you line 137 now. Line 137. Okay, what's the next task? But yeah, wait, Python is meant to break if you try to return inside of a for loop, right? What's the next thing? Oh. Remove a suffix from a word.
N_sweep says it's not that you're inside a for loop but that you're not inside a function.
But isn't the for loop inside a function? But I guess it doesn't count. Well, I should change my category. Ness is a common suffix that means state of being. In this activity, your sister needs to find the original root word by removing the ness suffix. Oh.
N_sweep says return always works from inside a function.
Well,
it halts the function immediately and returns.
Yeah. So look, this is what I did yesterday, and then it broke. So wait, let me comment this out. I'll show you. I made a mistake yesterday that I caught after like 3 minutes of looking. I'm like, wait, what did I do? This worked before. I did this. Actually, this wasn't here at the time. Wait, why am I deleting it? Here. This broke it. When I did this was an accident. I returned this and then it broke. So I just thought I couldn't return in a for loop. Maybe I'm wrong. Oh.
N_sweep says I see.
That's what it is? Sorry. Invalid to return. Oh, it's an assignment.
N_sweep says you're doing A equals, so it's invalid to return.
Thank you. That's what happened. Okay, so assignment. Let's see.
N_sweep says so if you did word_list equals stuff and then return word_list it would work.
I see. Oh yeah, it's but it would run. Thank you. In this activity, your sister needs to find the original root word removed from that suffix. But of course there are pesky spelling rules. If the root word originally ended in a consonant... Oh, there's no spelling rules. Originally ended in a consonant followed by a Y. Then the Y was changed to I. Removing... Oh, like a happy essay. Removing ness needs to restore the Y in those root words. Happy, happiness. Implement the remove suffix ness word function that takes in a word and returns the root word without the ness suffix. I have enough methods to do this.
Wind137 says, wait, is that right?
Talking to end sweep? Oh, dry. Is this spelled?
Wind137 says, isn't it spelled dryness and
Yeah.
not dryness?
Oh, you're right. They didn't think about the edge cases of dryness. That's what you mean. I'm glad you're here to point out all the flaws in this assignment. Yeah. Dryness. I want to say, and I want to add this. For example, heaviness becomes heavy and sadness becomes sad. And dry...
N _sweep says English T90 respects T90 respects.
And dry becomes dryness. To add to the instructions. See? Now it's part of the instructions, so it's correct. Amazing. I know. And
Wind137 says amazing.
the best part is this code gets submitted to this community. Like, once you submit your solution, it becomes public along with everyone else's solutions. So people will get to see how to spell properly English words. I feel like I've contributed. Well, you contributed. It was really your idea. Move the suffix. Oh, they're giving me a single word. So if they're giving me a single word, then one word. Wait, no. Oh yeah, I don't know. One word. I can treat that word like a list, right? Like I can treat it like a list of characters. Isn't that like allowed in Python?
N_sweep says yes, you can also say something like inness in Word.
Oh. Oh yeah. In this. But then I would still have to remove something. Like I have to remove the Y from the words. If there's a Y. So I'm probably gonna have to make an if statement too. Why not this one?
N_sweep says check out the str.replace method.
Oh. Okay. Let me see. I want to see what words they're going to pass in for the test. Oh, it's a list again. I thought they were going to give me one word. Heavy remove.
Wind137 says there's
oh
even
wait,
a
no,
method
I'm supposed to
called
return.
str ends with.
I'm supposed to put the Y back in. Heaviness. Oh. I just need to remove the E-ness. But wait, sad. Oh, I need... Oh. There's going to be if statements in there, isn't there? Going backwards, yeah.
Wind137 says
it is
oh,
going
it's
backwards.
going backwards.
I wasn't expecting that. Wait, that's task 3. Wait, I am on task 3 though. So yeah, it goes like in this direction. And then turn heavy, sad, soft, crabby. So I need to check for E-ness, and put a Y, or I need to check for just ness without the E. And then just delete it. Mine, I know.
137 says so business becomes busy. Mind blown.
Busyness, busy. Yes, exactly. Oh yeah, because it's called remove suffix, so we are taking it away. There's even a string that ends with string.replace. Let me see them. String I'll start with this one. Ends with. Oh.
Me says coding Python for 6 years.
So that returns true or false. Oh wait, I see how I could use this one. That's cool. What about... what's the other one? Dot replace. Oh. Oh, this is perfect. These two are perfect. You guys gave me the perfect things. I like... oh, you like... this is good code, right? Wind... because look, because the replacing the bananas with the apples is perfect. Just... it's like you wrote it yourself. Okay, so just... but I am deleting stuff. I mean, I could delete it by replacing it with an empty string.
Line 137 says no like banana but like apple.
Apple. Yes. Okay, I think I know what I should do. But then each word... I have to go through each
Line
word.
137 says except the glue company Apple.
Yeah. Except, yeah. Oh yeah, the glue company. Says the person who what's that?
N
What's the
underscore
word?
sweep says glue company LUL.
Says the guy who supports them monetarily and voluntarily. Sorry, I drank some water. I kind of wonder if I can get away with this without a for loop. Because last time, there was a way to do this. Well, you know, we did it without a for loop. And that was cool. But that was with... but that was just because we're joining... But that was joining a list. That was different, I think. I think we need a for loop here. Okay, so... indent, because I learned you have to do that in Python. I did it! I invent it! My goal... they didn't introduce for loops
Line
yet.
137 says have they introduced for loops yet?
They didn't! So technically I'm not supposed to. They didn't. I've just been using them. Because Sweep taught me. Well,
N
Sweep
underscore
said.
sweep says from the way the stock string is written I believe you only have to do one word inside this function.
Oh, dang it. Okay, then I'll try to not use a for loop. Since they weren't introduced yet. Ugh, sigh.
N underscore sweep says I think their test loops through a list on its own, but you don't have to handle
Oh, that's
a
what it
list.
does? I thought it was passing me a list. It'll just put in one word at a time. That's what their test is doing? Oh, I didn't realize that. Because input... oh. Okay. 'Cause at the beginning I was under the impression that it was just one word. Then that's fair. More fair. It says, yeah, it says words. I didn't say words. Right? So, okay. If, wait, I'm using string dot replace, oh, wait, string dot ends with, and replace one. Ends with... What's that? I'll do Enos first. Oops.
Garcus says each function has a param to indicate what the expected input and output types of that function are.
Oh, wait. Not string, sorry. Word. Because this is a method from this class. Yeah, each one has a parameter. I think you... I see. Probably this. But yeah, colon thing. Turn word to replace. How was this used? I think the first one is Enos. But if I'm wrong with what the parameters are, but I think that's what it said when I checked. Because I did check, but I'm just trying to... Hopefully I remembered it right. There's only 2 options. Wait, it ends with, is they're giving me, oh yeah. Yeah. It's happy. The happiness. I don't want to oh, I need to do more. I need to do more. Because I remove this and it becomes hap. I need the Y. That's what I'm missing. Where did I press it?
N_sweep says the Y should go in the second arg of replace.
I can put it in without doing the... Oh, I was gonna join them by putting that into a variable. Oh yeah, that's a simpler way. I was actually just gonna like do a whole nother line and like put this in a variable and then add and then do plus Y, but that's like an whole extra step when I could just do this. Well, yeah. Replacing this. But this one, I don't need to put anything. Except the colon. Hey. Thank you guys. And you're right, they were feeding one word in at a time. Oh, thank you. So...
N_sweep says T90 go T90 high.
I was wrong. I thought it was a list they were giving me. Extract and transform a word. Suffixes are often used to change the part of speech a word is assigned to. A common practice in English is verbing or verbifying, where an adjective becomes a verb by adding an N suffix. Return word.
Garcus says return word :4 if word -5 equals I else word :5y.
What? Is that that's an option? Oh, that's an option? Wait, will that do both? Will that do both cases?
N_sweep says readability is king.
Like, I'm wondering. Or... Oh, but what if they... Wait, Wait, would that piece of code actually do the whole thing? What you wrote, T-Carcass? I kinda wanna test it. Will it? Okay, I'm gonna try it. I'm gonna see if it does something. Because this is easy to comment out. What? No way. Oh wait, I guess I need to look up the split notation thing. This is... Oh, what is this? What does this do? Yeah, start, stop, skip, right? Oh, step. Stop, -4. Like 1, 2, 3, 4. Wait, 1, 2, 3.
N_sweep says it's accomplishing the dot replace.
What? Dot replace by slicing off the end of the string. Oh. You'll slice this off. Okay. Word. Oh. If word. -5. Oh, not equal to I, because you need the I and the E-ness. I never thought of this cool. Like, where's one with ness? Heaviness. So I guess if you slice off 1, 2, 3, 4, 5, if that's not equal to I, which is, in this case. Wait. Oh,
Odepi Bode says at N_sweep F.
that was
Sad
random.
face.
F. Was not expecting that.
Salttoserenity says back.
Back. I didn't give up. I'm still looking at this statement. Word -4. Or
Line
whatever.
137 says
If
Okari.
Else. Oh, they're writing the thing you do here instead of on the bottom of the if statement. Like, do this if blah 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 instead of putting it at the bottom. It's like all condensed into one line. If word. The word my says is 1, 2. 3, 4, 5. Not equal to I. Return word minus 1, 2, 3, 4. Wait, but then you would need... But no. It's not doing what I think, because then... I thought it would do this. Well, I'm wrong. Because this works, but I thought that this one would then do the word minus 4. And then it would be heavy. Wait, it's doing the Y one. So it's jumping where I think it's not supposed to go. I guess wait. I'm probably misunderstanding the not equal to. Yeah, I'm reversing. I'm just trying to... Why is this happening?
N_sweep says you've got your if logic backwards.
Not equal to, yeah. Did I say equal to? Oh wait, not equal to. Booleans are hard. True and false is hard. If it's not equal to... Oh, so it's not... Wait. But it's not equal to... Wait. I... So that's true. So then this is the one you're supposed to do, I thought, when it's true.
N_sweep says but it returns the thing before the if when if is true.
I thought it's true. This is... That's why I thought this was true. Because it's not I. 1, 2, 3, 4, 5. Are you supposed to count from 0? Like 0, 1, 2... Wait, what? No, 1, 2, 3, 4, 5. Not equal to I. Oh, no. Sorry. 1, 2, 3, 4. This I. Wait, is it I? Not equal to I. Oh, it's else, because it is equal to I.
Says no. That one would be false because it has the I.
It has the I. It's just grabbing the character at negative O. 5. I. So jumps to the else word. 5, turn it to... Oh, wow.
N_sweep says so you get the else instead of the first thing.
Start. Stop. Oh, plus Y. Thank you. That's cool. And then otherwise, you just cut off the nest, which is 4 characters. Oh, because you're telling the string to stop earlier than where it would normally stop.
Perfect.
That's cool. Here, I'll write this. This one's cool. T-Curtis. Oh, and you're saying I probably should use doc strings. See.
N_sweep says this works great, but your first solution is much more readable for other dev/future you.
Yeah. I see. It's cool that this one exists. More readable. Better for future devs, including me. It's cool.
Garcus says depends on the language knowledge.
Cool.
He refer reading those kind of onoliners over if blocks.
But I did learn something from this one that you did, T-Carcass. That's really cool. Like, you can put the thing that you do in front of the if statement instead of, like, after it, you know. Like, you can do something like this. Like, that's really cool. Let's see. Extract and transform a word. Oh, wait. Oh, I was reading this. Verbing or verbifying, where an adjective becomes a verb by adding an N suffix. In this task, your sister is going to practice verbing words by extracting an adjective from a sentence and turning it into a verb. Fortunately, no, I didn't say anything about their doc strings.
Need a space after.
Oh. Well, I'd rather... Okay, even if it's good style, I'd rather look at it condensed so I don't have to scroll as much because I don't like doing work. Because mainly I'm just going to go back and read my own, like, notes just so I can remember the syntax only. In this task, your sister is going to practice verbing words by extracting an adjective. Oh yeah, I said that. Fortunately, all the words that need to be transformed here are regular. They don't need spelling changes to add the suffix. Implement the adjective verb sentence index function that takes two parameters: a sentence using the vocabulary word and the index of the word. Okay. Brighten. 2, 1, 2. 0, 1, 2, dark. Oh. So I have to turn the string into a list. But I can do that with the... There was a split thing that they talked about, I think. And the index of the word once that sentence is split apart. The function should return the extracted adjective as a verb. Now, so take it and then add n. Wait a second. If... Oh yeah, there's a case that there's a period. So if there's a period, we'll have to remove that.
Line 137 says Kijken.
What's... Oh, Kaiken! Biking! I remembered. I don't know. Wait, no. Kaiken is like sea. Isn't it like to see? Biking is fietsen. That's Dutch. We were studying Dutch. We should do that again sometime, Win. Study more Dutch together, because that was kind of fun. And I'm also forgetting all my Dutch now. Not that I ever really learned much. Or remembered that much anyway, but it's fading. Do I?
Of me says still need.
I think I just returned the adjective, but I can check to see what output they want, so. Wait, do they have an example? No, they don't. It literally says brighten. They don't want the period. Like, this is the output they want. Brighten. No period.
N_sweep says at Sparkus, yeah, if I weren't working on a team I would probably do something similar.
I might try something like this just because this... Only because this is easier to write for me. This is like more interesting. Maybe, I wonder if I can do something like this in the next one. Okay, maybe I should like think about the steps so I don't mess this up. But it seems simple enough. Like I gotta, well, one thing at a time. Break it into words. So where's the thing that they did? What was it called? That broke it.
Line 137 says the solution with replace also doesn't quite work if there are multiple ness in the word.
Oh. Oh yeah. Luckily there wasn't multiple nesses.
Wind137 says I don't know if such a word exists in English though.
Ness. Be Ness. Nessie. Yeah. I don't think so. Ness. Wait, maybe it was like a previous lesson where they talked about how to break a string. Well, they definitely did. There was... Oh, split. There it is. And then separator, which will be a space. Sentence. Okay, right now. Wait, was it like this? Capital? No. Well, I need to put this somewhere.
Wind137 says methods
Wait.
are generally not capital.
Word list. We know. Yeah. Or call it words in sentence. Methods not capital. Thank you, I see. Words in sentence a split. Then I have this too, so I need that one.
N_sweep says ruthlessness is the only one I can find.
Oh, there is like a word that ruthless and s-ness. Well, yeah, but without the n though. But that was close. That was a close.
N_sweep says no.
Close one. Send. Doing word. And then at this point, I think I can do, if I wanted to, even though it's like maybe not good style, I think I could do something like this. Is it bad if I copy? No, wait, maybe it is. I'll just keep referring back up to it. Like, if something has a period, return. I want to do the period. Wait a second. I need to delete. Oh, no, I just need to add n. I just need to add n to every adjective. I think that's what I was supposed to do. Bright N, dark N. Yeah. Yeah, that's why I didn't want to do it.
N_sweep says, in my opinion, the only reason copying and pasting is bad right now is you're still building your intuition and muscle memory.
I agree. I thought about it. I was like, there's nothing wrong with like saving myself some time, but I'm still trying to remember like what the names of the methods and stuff are. And so it's better if I try not to look, if I can, and type it out. For sure. Return word. I don't want join. I want not replace. Wait, maybe replace. What does replace do? It does it replaces something with something else. Oh, I mean, I can just this. Um. Wait, I want to do the case where there's a period first. So, um.
Line 137 says you could use replace to get rid of the period.
Oh, did I already use that one? I kind of forgot if I did. Oh yeah, replace. I was literally saying string.replace. What am I saying? Yeah, you're right. That's what I was about to do. Um. Thank you, Win. The replace. If. Wait a second. How would it? Would this make? How would I set this up though? If Oh yeah, because I don't. Oh wait, -1. You can actually search from the other end of the string. So.
Line 137 says if there's no period, replace will just end up doing nothing.
Word. Wait, really? If there's no period. Yeah, you're right.
Line
Then I don't want to do
137
anything.
says so you don't need to worry about the case where there's no period.
Oh, it's not. If there's no period, replace will just end up doing nothing. Oh, cool. Wait, really? Oh wow. It just. Wow. It doesn't like freak out and like, oh, there's no period here. Throws an error. Wow, okay. It's cool. I wonder if these two lines can be combined though. I think so. Like this. Dot replace. Oh my god. It's just a bananas.
Line 137 says it's just like if I asked you to get rid of all the bananas in my house.
No, that's I would throw an error at you, line 137, because I would be like, why did you make me come all the way over across to another country to clean your bananas? I came as a friend to help you, and you trolled me, and there's no bananas. I would be very upset.
N
And throw an
underscore
error.
sweep says at line 137 is it a texture thing or a flavor thing?
I never asked line 137 that question. I don't know. I always assumed it was flavor. Is it a texture thing or a flavor thing? Because, yeah, bananas do have kind of a mushy texture. Flavor. But the flavor's so good.
Line 137 says
It's
flavor.
so yummy. Do you like banana sweep? I love bananas. They're one of my favorite fruits ever. Don't hate me. Don't hate me, line 137.
N underscore sweep says I put bananas in smoothies but I hate eating whole
Ah,
bananas.
okay. I mean, they do. I'll be honest though. Bananas have kind of like an aftertaste. They're one of those like fruits that it's like they have kind of like a. They have a very unique taste, so I can kind of imagine
Line
why.
137 says I don't like banana flavored things.
Or actual bananas. Banana flavored things don't even taste like real bananas. You guys hate
N
them
underscore
both?
sweep says fake banana flavor is the worst.
No, fake banana flavor is good too. They're both good, but they don't taste like each other. They taste different. I think. I hate. You know what I hate? Grape flavored stuff. Artificial grape. Does anyone even like artificial grape? Because anyone who does should seek help. No, you guys,
N
you're
underscore
lying.
sweep says artificial grape, artificial banana.
It's not. No. Not all day long. Well, I'll give you. You can have all the artificial grapes.
N
I'll take all your
underscore sweep
artificial
says
bananas.
all day long.
Oh my god. Oh my god. Artificial grapes at the absolute worst possible. So it ends up being a good thing, because then we just can exchange.
N_sweep says, yeah, we can trade LUL.
Just like if you ever happened upon a lot of bananas, wine, I'll take them from you. I would be happy to. Teamwork.
N_sweep says teamwork.
Oh, I can just with this. But then word there's not a period. Wait, no, then I'm gonna overwrite word. I don't want to do that. Word with period. But then I need to know which one to return, so I still need an if statement. Because I can't just, like, randomly return one. Right? I mean, I know I could do this. I'm just trying to figure out what's, like, an efficient way to do it.
Line 137 says, I asked you to get rid of all the bananas, not replace the bananas with N.
I thought that's what were instructions. All the bananas.
N_sweep
okay,
says
fine.
the return was good.
Fine, I'll just... Okay. I won't replace all the bananas with N. Remember, I am publicly submitting this. Bananas.
N_sweep says, oh wait, maybe I misunderstood the Rex.
Oh, wow. Really? Oh, wait. The, what are they doing again? Oh, they're giving a sentence, and then you have a word. This is like the index of the word. And then you just put N at the end of the word, that's it. Unless there's a period, then you have to delete the period, and then put N at the end of the word. Banana. Bananas.
Line 137 says, but there might also not be a period.
Yeah, there might not be a period. Yeah, there sometimes isn't a period, that's what I mean. So I was like, that's what I was making an if statement.
Line 137 says you want to put N at the end regardless of whether or not there is a period.
Yes. I do. I wouldn't, you're right, account. Oh, that's why.
Line 137 says if you replaced with N you wouldn't account for the case where there's no period.
Oh, this, by not doing that, I'm accounting for the case without making my life more complicated than it needs to be. Okay. So then banana. Wait. Return. Banana. Plus N. I don't think I'm missing anything. Hey, thank you. Thank you. Banana. Heck yeah.
Line 137 says PogChamp.
Ignore all this. Continue. Nice. Oh wait.
Garcus says nice, same as my solution. Only using more lines.
Oh, more lines. see. Wow, loops are so far away. I feel like they should have introduced those like earlier. I still feel kind of sad that the tree is so small. Wow, the little sister returns. This one. String class offers many useful methods for working with and composing strings. Oh, it's willing. Wait, how many? Oh, this is the entire doc. I wonder how many there are, how many string methods Python has.
N_sweep says at wind 137 I use Pyrite LSP and the built-in type hinting in 3.12.
Oh, Win, did you know? NSweep told me that they work with Python professionally with like AI, like they do data or something. I thought it was really cool. Yeah.
Wind 137 says oh cool.
And then guess what, Win? I told them about I told them
Wind 137 says we're still on Python 3.9 at work LUL.
Remember when you sent me the article about like Apple saying do not hallucinate? I told NSweep about it in their prompts.
N_sweep says at wind 137 I am a contractor so I get to use what I like for now LUL.
It's awesome. I want to be hired by Apple as a prompt engineer. That would be amazing. And I want to do not hallucinate. It's great. Just give the correct answer. Never make a mistake.
Sweep says just give the correct answer, please.
I love how that's like comparable to when people are just like, you're just like, oh, I'm having a hard time. They're just like, oh, just don't. Just do better. Do better. Great, thanks. String methods.
N_sweep says have you tried just being happy?
I know. Or what did you say? You said earlier, Wind. You said the solution to not having money is have more money. That's it. Simple. Don't have money? Have money. You did. It's literally the same. It's the same thing.
137 says yes.
It's the same thing. Searching, cleaning, splitting, transforming, translating, many other techniques. Huh. Cleaning? Is that why is that why you said like sanitize the string? Remember when you said that to me? You're like, I think we should sanitize the string. Strings are immutable sequences of Unicode code points. Individual characters are code points. Strings of length 1 can be referenced by a 0 based index number from the left or -1 based index number from the right. Strings, I really like this -1 thing. It's really handy. I do wish like that was like in C# because I think that's really convenient that you can do that and don't have to do extra math. That's the only nice thing I have to say about Python. Right. Strings can be iterated through using for item in string or for index item in enumerate syntax.
Wind 137 says -1 is a shorthand of len, string, -1.
-1. Oh, yeah. But, like, that's weird. Name string. Yeah. That's cool. It's string. String computer read it through. Okay, read this for index item and enumerate string. Wait, why would you even want to use this like really long syntax, longer one, if this one exists? They can be concatenated using the plus operator or via string.join. Iterable.
N_sweep says at line 137, what do you do for work?
I'm pretty sure they taste test bananas. That's why they hate them so much. Additional variable. Oh.
Line 137
okay.
says also machine learning-ish stuff actually.
That's why I knew you guys would be best buddies. And you both use Python.
N_sweep says at line 137 cool.
As your main. So am I not being spoiled right now? That's why I have to get good at Python as quickly as possible so that I don't bore you to death. Like I should try. And then
N_sweep says tell me more. Laughing face, laughing face.
Yes. And then I also there was a piece of Python code that I thought was really interesting where you make a bunch of snowflakes in the terminal and it was really cute. And then Win said is like that if I get better at Python, then one day I might be ready for him to explain that program to me so I can copy it. Yes. Positive reinforcement. Yes. I want the snowflakes.
N_sweep says ha 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 positive reinforcement LUL.
Tell me when that day comes, Win. Please tell me when the day comes where I'm ready for the snowflake program. Anyway, point iterable and rate. And implement all common sequence operations. Sequence operations? Oh, that's what these... The single quotes, double
N_sweep
quotes.
says is the snowflake program Conway's game of life perchance?
It's not. It's... Well, I can actually kind of show you. I showed it. It's pretty cool. Yeah, it's just it's just a program that
Line
not
137 says at N_sweep
just,
actually no.
Yeah.
It's just a program that randomly generates snowflakes.
It creates snowflakes, rows of snowflakes at the top of your terminal, and then pushes each row down. And they're randomly spaced, and you can control the density and how fast they fall, how fast the rows are pushed down, so it makes it look like the snowflakes are falling down the terminal. It's pretty cute. That's it. Cool, I know! I thought it was awesome.
N_sweep says cool.
But because you can use any copy pastable character, you don't have to use snowflakes. You can make it rain bananas if you want to. Like why stop with snowflakes? If I do that program, well, again, the code is already there, but maybe I should try if I'm ready for that.
137 says no bananas.
Oh, bananas for sure. If I were to try to do that piece of code, I would try to do it myself without peeking at it, because it's all provided. And then instead of snowflakes, I guess I can just ask the chat what characters they want me to make fall down. Yes. I think it has to be Unicode though. Or he used Unicode. He just grabbed a bunch of random Unicode snowflakes, because there's actually like a lot to pick from. Surprisingly. I don't know why you need so many snowflakes. But then there just might be a lot of characters that look like snowflakes. I think that's part of the reason. Like, I'm pretty sure the star symbol
N
was
underscore
considered a
sweep says, oh
snowflake.
no kidding. I had no idea.
Wait, so this, it linked here, this common sequence operations, is it referring to this single quotes, double quotes, triple quotes? Because this doesn't look like an operation. To me. But it linked here. Strings are immutable, meaning the value of a string object in memory cannot change. Functions or methods that operate on a string, like the ones we are learning about here, will return a new instance of that string object instead of modifying the original string. Following is a small selection of Python string methods. For a complete list, see the string class in the Python docs. Nice. String.title parses string and capitalizes the first character of each word found. I feel like string.capitalize would be better. In Python, this is very dependent on the language codec used and how the particular language represents words and characters. Oh. Yeah. Language codec. I thought encoders and decoders. Huh. Code text to bytes. Text to text and bytes to bytes. Upper.
N underscore sweep says they didn't use capitalize because there's another method called dot upper that capitalizes the whole string.
Descriptive. I see.
N underscore sweep says so title is intended to be more descriptive.
Each word. Oh yeah, because each word. It's not just capitalizing one word either. It's like the whole thing, like a title. That's true. In Python, this is very dependent. Oh wait, I read that. There may also be locale rules in place for a language or character set. Okay. Man in hat. It says Thai. Man in hat Russian. Man in hat Korean. Man in hat English. That title. Oh, so this one has capitals. What? Oh wait, I thought this changed. I thought the Korean changed. I'm like, Korean has capitalization? But no, it didn't. String that ends with
Line
suffix.
137 says yeah, title just does nothing for languages that don't have capital letters.
Yeah, that's good. That's a good feature. Just like how nice it was that if there's no bananas in your house, like it doesn't break just because there's no bananas. It just is like, okay, that's fine. Then we won't, delete your... Yeah. Oh yeah, but then we won't delete your, I guess, bananas. I'm like getting confused with the bananas versus like the period. I'm like, wait. Well, yeah.
N underscore sweep says at wind 137 what kind of stuff do you work on in the space? I'm in healthcare. I was doing prediction of adverse outcomes for providers, hospitals, etc. with SCBoost.
So cool.
Wind 137 says we're using graph neural networks to run simulations of atoms and molecules.
Dang, you You guys are flexing on me, and then I'm over here with my resume, like, oh, I'm good at off by
Sweep
one
says at
errors.
line 137, oh that's rad. Physics is fascinating to me.
Whenever I have any question that's physics related, Wind is always there to answer my questions. That's how I know what meters per second actually means. No, wait, meters per second. That's called. Wait, I'll remember its name. It has a special name.
N_Sweep says at salttoserenity, I'm a college dropout and I was a guitar salesman just a few years ago. You can do it?
Well then I'll have to live up to you. But, what was this word? What was the word for the meters per second? Meters per second. Oh, thank you, Win. Oh, that's what I was wondering too. If you play guitar,
says, yeah, you can do it.
It was called. No, I don't remember. But it was cool. I think it begins with a T. Am I right, Win? The word begins with a T.
Sweep
it's
says
like
bass is my choice.
What word?
Line 137 says nice.
Remember? There's a special word for meters per second. Like it has a special name to describe that. Yes. I thought that's so.
Line 137 says M.
And I thought the word begins with a T. Oh wait, no, J. That's J. Oh, it was jerk. Damn it. I wouldn't have gotten it. I kind of did forget it. Oh, bass. Bass is underrated.
Line 137
that
says,
is the actual name.
That's not an insult. That's the actual name.
I know, it sounds like... it is. It's called jerk. Meters per second. It's crazy. They called it jerk.
N_Sweep says, oh. Jerk. Sounds like an insult, LMAOO.
Yeah, I like how you... That was actually smart of you to explain, like, you're like, wait a second, just so that no one's confused here. Like... String that ends with suffix returns true if the string ends with suffix. False otherwise. Oh, this is the one you introduced me to, when string that ends with... Oh, I didn't mean to open that. Oh wait, this is sad. My heart breaks. Ends with a broken heart. True. This is like coding. You know, this reminds me of the... What was it called? Like coding poetry. Remember when you showed me Black Pearl? I still haven't forgotten that. Every now and then I read it because it's cool. I still like Black Pearl. Do you know what Black Pearl is, Answeep? Have you heard of Black Pearl? Because if you haven't, I kind of want to show it off because it's really cool. Here, I'll show you what Black Pearl is.
N_Sweep says I don't.
Win showed me this like a long time ago, like way back when we first met. Like it was very long ago. Well, it feels long. Here, I'll show you. My code is Google. It was a code poem written using the Perl programming language, and it's so cool. And it runs. It doesn't do anything. Like it doesn't. I don't think it gives an output, but it parses, and it runs, and it doesn't throw an error. So that's cool. With keywords. It'd be cool if more people wrote like cool poems with code. Isn't it cool? It's really interesting.
N
It's like,
underscore sweep
whoa.
says, oh, interesting.
It ends with sleep, sleep, die yourself. Die at last. It's so dark. I don't know. I like this poem. I think it's hilarious. As they say. Heavy. They are. And it was
N
written
underscore sweep says, damn, yeah, those last 4 lines are heavy.
1990. This was posted. It's an old poem. But imagine like sneaking up behind a coworker and seeing their IDE, and you see like this in the editor. Like, this is what they're typing. You just be like,
N underscore sweep says, hey,
nah.
it's not that old, lul.
But it just, with how technology has changed, it feels so long ago since I last saw a VHS.
Line 137 says 1990 was 10 years ago, right?
Was yes, for sure. Yes. Cheerfulness ends with that's true. Punctuation is part of the string, so needs to be included in any ends with match. Okay. Dance ends with false. Quick fox is a dog, false. String.strip characters. I don't remember if we used this one or not previously. Returns a copy of the string with leading and trailing characters removed. Oh. Okay. The code points specified in characters are not a prefix or suffix. All combinations of the code points will be removed, starting from both ends. Oh, yeah. Wait, no, we didn't. Starting from both ends of the string. If nothing is specified for characters, all combination of white space code points will be removed. Oh. Leading and trailing. This will remove HTTP because it can be formed from STPH. Oh, wait. STPH. HT. Oh, wow. Oh, so it doesn't even matter the order. That's cool. HT. Wait, but they're missing another T. Shouldn't there be another T? Doesn't that matter? Because this is STPH, but where's the extra T?
N underscore sweep says,
Oh.
I actually did not know this.
Oh, you only need one T anyway, because it's going to remove all the T's and all the slashes. I see. It just, like, took me time to think about it. Removal of all white space from both ends of the string. Yep, justification equals.
N underscore sweep says, I always thought the strip string had to be specific like HTTPS://.
I see. Yay! We got to learn something new. Because I was like, oh, this stream's probably so boring because I'm doing, like, super basic stuff. And then I'm getting it wrong. That's the worst part. I'm doing it wrong. More than half the time. Justification equals. Justification not strip. H. Yeah.
N_sweep says, I guess this behavior makes sense
That's
because it
true, not
removes
just
all
one
instances of
space.
space instead of just one on each end.
Mm-hmm. Prefix and suffix in one step. Unaddressed, strip on. Oh yeah, UN and ED. That's cool. Unaddressed, strip DN UE. But this is like also seems kind of dangerous because you could accidentally grab characters. You could strip characters you don't want to strip. Since it's like, you know, it grabs every single one instance. If you're not careful. Oh, quote. String.replace substring replacement substring. Return. Oh yeah, that's the replace. Returns a copy of the string with all occurrence of substring. Replace with replacement substring. Quote used below is from The Hunting of the Snark by Lewis Carroll. Okay, I'm not going to read the Hunting of the Snark.
N_sweep says, personally, it's rare that I use strip to remove anything but with
Ah.
space.
Got you. Snark. That's the place for a. Ah. Bookkeeper.replace. KK with K. K. Nice. Yay. Instructions. In this exercise, you are helping your younger sister edit her paper for school. Teacher is looking for correct punctuation, grammar, and excellent word choice. You have 4 tasks to clean up and modify strings. By the way, Nsweep, what do you think about LeetCode? What about you, Win? I never asked you this before. What do you think about LeetCode? Oh wait, actually I think I did at one point. Maybe. But I don't remember what you said. Wait, you help me understand your paper. Correct punctuation, grammar, excellent word choice. Word has to yeah. Capitalize title of the paper. Any good paper needs a properly formatted title. Implement the function capitalize title, which takes a title string as a parameter and capitalizes the first letter of each word. Wow, all you have to do is use the exact method that it told you to. That's actually called title. A string in title case. I mean, this one's so easy that I don't even think it should be an exercise. Watch me get it wrong, though. No, wait, I think it was... What was it? It was... Oh yeah, string.title. Oh, that's it. Check if each sentence ends with a period. want to make sure that the punctuation of the paper is perfect. Implement the function check sentence ending. Take sentence as a parameter. This function should return a bool. What was that one called? Ends with title. Ends with. That's the one. I think that's what it's called. No attribute. I think this wasn't its name? Or maybe it was. Oh, wait! I get it. This way. Or maybe it is the wrong title. Too. Oh, it's just called ends with. Oh yeah, I guess you don't name methods like this.
N_sweep says ends with.
Yeah. I thought you would name them the same that you name the variables, but I guess not. I kind of don't like how like second words and methods aren't capitalized, because it would look nicer if it was like this. Hey. Clean up spacing. Verify that there isn't any white space with the... Oh wait. To make the paper look professional, unnecessary spacing needs to be removed. Implement the function clean up spacing that takes sentence as a parameter. The function should remove extra white space at both the beginning and the end of the sentence, returning a new updated sentence string. Oh, that's all that does. So this is like similar to the... This is like strip. But you can't specify what you want to strip. But it just automatically does the spaces for the strip. I guess. Clean up spacing. Oh wait, no, I thought this... I'm dumb. This is what I need to do. You have to use strip to do this. I thought this was like... I'm dumb. I don't know why. I thought... I wasn't paying attention. I was like zoning out. I thought this was like an actual Python library method. My bad. I've noticed too, I think the Python track on this site is like significantly easier. The problems they're giving you, they give you, are significantly easier than the ones they give you in the C# one. Not that the C# ones are hard, it's just they're harder.
Me says Python is easy.
They're doing in strip. Replace word choice sentence, old word, new word. Why is this? Hold on. To make the paper even better, you can replace some of the adjectives with their synonyms. Write the function replace word choice that takes sentence, old word, and new word as parameters. This function should replace all instances of the old word with the new word and return a new string with the updated sentence.
Me says, how many weeks would Blackjack project take you?
Like, what do you mean? Place. What's replacement word?
Me says it would take me weeks to code.
Old word, new word. Substring. You know what? Substring. Wait, no. What am I saying? I mean replace. I think that's what's called. Yeah. Nice. Where did I stop?
And I think it's just about to be a little more interesting. Let me click play now, and hopefully this isn't too loud. DAVID, enter.
Hello, David.
Okay. Thank you. Thank you. That's a low bar. Let me go ahead and set the voice too. And you might now remember how we began class where we had a robotic computerized voice. Oh, we didn't use Scratch at the time, but we could change this in Scratch alone to be a little different. So DAVID.
Hello, David.
Okay, a little creepy, but we can play all day long with that. But the point is that these functions are just now doing something a little different, but it's just these inputs and outputs. Well, let's make the cat more like a cat. Let me go ahead and throw away all of this asking questions stuff. Let me go up to sound, and let me go ahead and drag the play sound meow until done. And here too, it comes with meow. You can add your own sounds, sounds as well, but I'm just gonna use the default meow. And here too, hopefully this won't be too loud. Let's make the cat meow by clicking play. Okay, it's a little piercing, but it's cute. And if I want the cat to meow twice, I could just play the game twice. All right, but it'd be nice to just get it to meow automatically 2 or 3 or more times. So you know what I could do? I could just drag a second one of these. I could actually, you know what? I could even just right-click or control-click and duplicate them. But I'll just keep dragging and dropping. There's different ways to solve problems. And now let me click play. Okay, cat does not sound particularly happy, so we could go.
N_sweep
Oh, that
says
was
cranking
unintentional.
up the speed to 2x for a few seconds so that 1.5 sounds more normal. Pro
That
strat.
wasn't actually my strategy for that. I just wanted to yeah. I was like, well, that's a little too fast. Maybe even I could probably do 1.75 honestly.
N_sweep says I do it intentionally all the time.
Do you
LUL.
really? I've never thought about doing that. Oh, that's interesting. But now it does sound kind of a lot more normal if I just sped it up. Someone told me when I was watching this at like fast speed, and then I put it back to normal speed because I needed to hear some of the things he was saying. Like they were like, now it sounds like he's talking in slow motion, even though it was just normal speed.
Under, how about control? We can wait 1 second. Now
It
there's no
does
room.
sound really normal though now after doing that. It's crazy.
But it will sort of expand to give room for me. So let me try this. And now it's going to wait 1 second in between meows. Okay, let me stipulate that is correct. If my goal is to get the cat to meow 3 times, it meowed 3 times. But per our discussion earlier of algorithms and the design thereof, this is not the best design. Okay, thank you for playing along at home. Yeah. In what sense is this arguably not well designed? Yeah. I repeated myself, which actually in programming tends not to be a good thing. Now, it was easy. I almost resorted to copy-paste, which saves me time up front. But just imagine a contrived scenario now. What if I wanted to wait like 2 seconds in between? All right, it's not that big a deal. I change it here, and I change it here. But what if the program is meant to meow 10 times? Then I have to change it here, and here, and here, and here, and here. And eventually, I'm going to screw up. Like, humans are fallible. I'm going to overlook one of them. One time it's going to be 1 second, another's going to be 2. And just stupid things will happen. You're setting yourself up for failure if you design things poorly.
It is pretty funny seeing people walk at 1.5 times speed. Oops.
And so I would propose that we use another type of building block to solve this instead. Yeah. Yeah, so we could use a loop and just write minimal code, but to accomplish even more functionality. So let me throw away most of these blocks.
It just get weird. It's very entertaining.
N_sweep says yeah, gestures get weird.
Yeah.
Let's go and grab this repeat block, which we haven't used yet, but it's right there. And as the name suggests, this will allow me to repeat something some number of times. Let me put these 2 puzzle pieces inside. It'll grow to fill. Let me reconnect it to the green flag. I'll change the default 10 to a 3. And now it's just sort of better, because if now you want it to meow more times, you change it 1 place. If you want it to slow down, you change it in 1 place. There's no room for error, and that's generally a good thing. But, you know, this is silly. Like, Scratch comes with a cat. Why didn't MIT give us a puzzle piece called meow? Like, why am I implementing the idea of meowing myself? Like, that took me, what, 1, 2, 3, 4 puzzle pieces. Why isn't there just 1 puzzle piece that meows for me? This, too, we can do in code, be it in Scratch or C or other languages, too. I'm going to go down to these pink my blocks here, where I can create my own puzzle piece. And I'm going to call this literally meow. And I'm going to go ahead and just click OK. And notice that it's given me this new type of start connector. It's a start puzzle piece that nothing goes above it, but you can put anything you want below it. And I'm going to go ahead and cheat here. I'm just going to grab my existing code, so to speak. This is code I'm writing, even though it's puzzle pieces. And now, let me just claim, and I'll move this aside, here is now an implementation of my own function, my own block called meow, whose purpose in life is to meow until done, and then wait 1 second. But what's powerful...
Honestly, Scratch is pretty cute. I wish that existed when I was a kid. But I think I would have enjoyed playing around with it. Good.
Now is notice at top left, now that I've made the block, I can use it any number of times. So I can grab this meow block, drag it over here, and you know what? Now that meow exists as an idea, I can abstract that away. And I'm just going to arbitrarily drag it way to the bottom. I'm not deleting it. I'm just putting it out of sight, out of mind, so that we can focus now on this idea. And I claim that this implementation of meowing is sort of better because it's more compact, it does what it says, and I don't care about the implementation details of meow.
N_sweep says yeah, me too.
Aw, it's so cool.
My wife was an elementary tech teacher for like 10 years and
That's
used
actually
Scratch
awesome.
with the older kids.
Oh, self-degrade. Aren't you? Oh, so it's not just me. Like, don't you just sometimes feel like jealous of all the young kids these days? Like all of the resources you get, like the iPads. Like their kids are like born with iPads in their hands. Like imagine having that head start with technology. But yeah, it is nice. I'm finally glad.
Underscore sweep says it's crazy to think about.
I know. I'm finally glad to have a viewer who doesn't make me feel like I'm super old and I should be on my deathbed and taking. Yeah, it's nice. I can be like, oh, remember dial-up? Oh, yeah, all the good times.
Underscore sweep says LUL.
Polaroids and cassette tapes. It was fun. Hey.
Underscore sweep says I'm in my mid-30s and I changed careers at 32.
Huh. That really is inspiring to me, though.
Underscore sweep says
really
out of me
is.
learning how to type correctly, home row, etc.
Yeah. It's yeah.
Of me says never had that class.
Unless it's like, oh, they're talking about when did you? Oh, because you said keyboarding class until 7th grade. That's cool.
Underscore sweep says the kids get it now in early elementary school.
Yeah. I still also remember the time when all the like laptops were really ugly. They're like big and ugly. Ugly. Let's go.
Of me says I was thrown into Pascal at uni.
So this idea of sort of better because it's more compact, it does what it says, and I don't care about the implementation details of meow. So this idea of abstraction, something we're going to use frequently. To abstract something away is to simplify. Don't think about the underlying implementation details, just care about what it does or what it's called. Someone has to care about the implementation details like me 30 seconds ago, but here on out, I don't need to care. And so in fact, you and I are using the abstraction that is Scratch because I don't know how to put a speech bubble on the screen. I don't know how to create that sound meow. MIT did that, and they abstracted those pieces of functionality away already for us by just giving us these puzzle pieces we see here. So the code will work the exact same, but it's sort of better designed now, because now I've abstracted away the idea of meowing, but I bet I can improve this further. Can I get rid of the repeat block altogether? And let me just tell the meow block how many times to meow. Well, let me go down to the bottom and look at the implementation details. I'm going to right-click or control-click on this, and I'm going to edit it. So I'm going to make a change. And I didn't do this before, but I'm going to call it meow as before. I'm going to add an input, and just so I know what it says what it does, I'm going to add the word times here. So, and I'm going to change this.
Actually, I didn't know about this feature. I think this like right-clicking on Scratch thing. Huh.
I'm going to right-click or control-click on this, and I'm going to edit it. So I'm going to make a change. And I didn't do this before, but I'm going to call it meow as before. I'm going to add an input, and just so I know what it says what it does, I'm going to add the word times here. So, and I'm going to change this placeholder to N for number is the go-to placeholder anytime we want to talk about a number in CS. So now notice the puzzle piece looks a little different. It takes an argument or a parameter called N, which represents the number of times you want the thing to meow. Now that doesn't do that yet, so let me go back to my other code. Let me just decouple these temporarily. I'm going to move my loop into my implementation of meowing, but I don't want a hard code that is literally write the number 3 anymore. I'm going to grab this circle, this oval, and put it there. So now I've generalized the function. So now it will meow any number of times, 0 on up, by executing that loop. And now, more powerfully, out of sight, out of mind, notice that my code just became so darn simple. Like my function is called meow, it meows some number of times, all I have to do is type a number there, and it just works. And I don't care anymore about those lower level, so to speak, implementation details. So here, no surprise, if I type in the number 3, zoom out and hit play, it still works just fine. So any questions on what we've just done here? It's still just meowing, but that's besides the point. It's this creation of our own functions, this modularity, this abstraction, that's going to be the idea that keeps coming back to us. No? All right, so let's make this a little more cat-like. Let me throw away all of this code, and let me go ahead, let me throw away this code first, and then the rest of this code, and let me go ahead and give myself...
I know! I like seeing him walk...
Sweep says my man has to walk so far to
yes,
point at the projection LUL.
I do like seeing him walk back and forth. This guy has like a lot of like passion though. He's really like energetic, enthusiastic. He just sounds like he's so excited. Might be because he knows he's being recorded for these lectures, but he's a pretty good presenter. I wish all my teachers were this like energetic, like walking around and like pointing and like look at this and look at this.
Another green flag block, and let me go ahead and let's create a cat that allows us to pet it by moving my cursor over the cat, and maybe it likes that, so it'll meow when I do that. So let me go under control, and let me grab this if conditional, which we talked about as a building block earlier. Let me go to sensing, and we haven't used this before, but here is a weird sort of diagonal shape that says touching mouse pointer question mark, so that's a Boolean expression. So I'm going to drag that, and it's definitely the wrong size, but it is the right shape, so it will grow to fill. And the question I want to ask is, if the cat is touching the mouse pointer, then go ahead and meow happily. So let me grab the meow sound, put it in there, and so I think when I click the green flag to start the program, and now I let the cursor, the mouse pointer, touch the cat, we should hear, doesn't seem to be working. There's a bug or a mistake in this program too.
Wait a second, let me look at it. Can I figure this out before he reveals why the cat doesn't meow? Until dawn. I don't know. I honestly can't think of anything other than like maybe it's like running so fast.
Me says no touch, no play sound.
But he touched it, I think. Oh, wait, but he didn't say the cat, or I don't know. He didn't specify what's touching.
N _sweep says there's no loop keeping the program alive.
Oh, yeah. But wouldn't it have played the sound at least once until it ended? Oh, when he started the program, he wasn't touching the cat, so it just ended. If touching it and it wasn't touching, it's over. When it, yeah,
Me says if has no
you're
house.
good. Thank you. Oh, damn it, I didn't figure it out. Okay. It's so funny. This is so simple with just basic blocks, and then I was just like, but yet, yeah. That's a good point. I have no regrets watching the Scratch lecture, even though it seems basic. Like, it's still good, you know, has good ideas and content.
Doesn't seem to be working.
Because obviously I need to brush up on a lot of rudimentary programming concepts, so it's fine. Oh, his name's David?
Garcus
You know
says
this
I
guy.
think David has been voted the student favorite lecturer
I
a few
know,
times
he's
at
so
Harvard.
he's really cool.
Easy to see why. His energetic
No.
passion and not overcomplicating the very
Yeah.
basic intro class.
It doesn't feel like he overcomplicates it. He explains things well and succinctly. He also doesn't like over-explain. It's like it's pretty perfect.
Of me says he makes
Balance.
mistakes.
He's great.
There's a bug or a mistake in this program too. What did I do wrong? Yeah. I don't need to specify this right explicitly because a detail I didn't discuss earlier, in the bottom right of the
Me
screen,
says he
notice
calls
that
print a statement.
Isn't a statement like any line where something happens, like this happens, this happens, this happens, whether it's declaring a variable or using a method? Program that intrinsically easy. Do it a lot for it to come automatic.
Of me says print was a statement in Python too.
Or maybe it just could be different in different languages. And since he's using Scratch, you know.
Of me says print is a function.
But, it's to get a salary.
N _sweep says I still call print a statement by mistake a lot. I still get a salary.
Cat is already selected, so this code relates to that cat. So your instinct is good if we had 2 or more sprites, but I just have 1, so I'm covered there. Other thoughts? Yeah.
Oh,
Your
someone
instinct
got
is good if we had
someone
2 or
got the
more
answer wrong. What did they say?
sprites, but I just have 1, so I'm covered there. Other thoughts? Yeah.
Okay.
Your instinct is good if we had green. Notice that the cat is already
Me
selected,
says
so this
should
code
David
relates
make the
to the
same
detail I didn't
mistake
discuss earlier.
without correcting himself?
I mean, in an intro class where he's just talking about basic concepts and using Scratch, I don't think it's a big deal. I'm slow down temporarily for a second and make him sound really slow.
In the
'Cause
bottom
it's
right
normal
of the
speed now.
screen, notice that the cat is already had 2 or more sprites, but I just relates
Oh.
to that cat. So notice that the cat is already selected. So this code relates to that cat. So your instinct is good if we had 2 or more sprites.
Wait, what did they actually say to him?
What did I do wrong? Yeah. I don't need to specify the sprite explicitly because a detail I didn't discuss
Oh, that's what I
earlier
said,
in
dude. The student who answered first, I was like, maybe he didn't say, like, the cat. Or wait, did I say that? I don't know. Well, no, I didn't. I did think that in my head. I didn't actually say that. That's one of the things I thought of, though. The other thing was, like, maybe... what was the other thing I thought of? My answer was that... like, it's moving too fast or something so that the meow can never finish because it keeps doing it. Like, it never allows itself to, like, you know, because there's no, like, wait. Meow and wait or something. That's what I was thinking.
the bottom right of the screen, notice that the cat is already selected. So this code relates to that cat. So your instinct is good if we had 2 or more sprites, but I just have 1. So I'm covered there. Other thoughts? Yeah. It only checks once. So I click the green flag. The computer did what I told it to do. The mouse pointer was not touching the cat at that moment because it was touching the green flag. So of course it didn't meow. So what maybe is the fix here? What puzzle piece can we add? Okay, interesting solution. So let me go ahead and under control, let me grab a wait 1 second. I'm going to change the 1 to 5, and now I'm going to click the green flag. So here we go. 1, 2, 3, 4, 5. Damn it. Oh, that was yours, not mine. It didn't work. Sorry? Oh, maybe forever. So your approach would work, but it's very much a hack, if you will. Like, I would have to time it perfectly so that the mouse pointer is touching it, or conversely, I have to drag it there and just leave it there for 5 seconds, and that's a little weird.
Wait, it didn't do anything? What did he do?
Oh, that was yours, not mine. 2, 3, 4, 5.
Oh, he's purposely, like, not putting it over the cat before the timer's up.
Damn it. Oh, that was yours, not mine. It didn't work.
So that it won't work. Yeah, because he wants to make a point.
N_sweep says he waited too long on purpose to make a
You
point.
think this is smart?
Sorry? Oh, maybe forever. So your approach would work, but
Forever.
it's very much a hack, if you will. Like, I would have to time it perfectly so that the mouse pointer is touching it, or conversely, I have to drag it there and just leave it there for 5 seconds. And that's a little weird, because, like, you don't just touch a cat.
Oh, that's the point he's making. Like, it's... Oh. Wait, I feel like it's worth it to make sure I hear the full point.
Ever. So your approach would work, but it's very much a hack, if you will. Like, I would have to time it perfectly so that the mouse pointer is touching it, or conversely, I have to drag it
Wait,
there.
did one of the students say, like, something forever? Like, wait forever? Or... What did they say, actually? 'Cause it
Approach
was fast.
would work. Sorry? Oh, maybe forever. So your approach would work, but it's very much a hack, if you will. Like, I would have to time it perfectly so that the mouse pointer is touching it, or conversely, I have to drag it there and just leave it there for 5 seconds. And that's a little weird, because, like, you don't just...
Wait, what's the point he's making afterwards? Like, your approach would work with forever. Like, what was the student actually answering? Like, do what forever? Because if they meant, like, forever, like that 5 seconds forever, then it would never do anything. Ever.
touch a cat and then like 5
But
seconds.
maybe I should just hear what was his question.
Okay, that was yours, not mine. It didn't work. Sorry?
Oh, he just said it
Hack,
didn't work.
if you will. Like I would have to time it perfectly so that the mouse pointer is touching it, or conversely, I have to drag it there and just leave it there for 5 seconds, and that's a little weird because like you don't just touch a cat and then like 5 seconds later it meows at you. Like presumably we want it to be more interactive, so I like this idea of a loop, right? Why don't we just tell the cat to forever listen for the cursor as?
Oh, that's what he meant. It's just when the person said forever, and then he like went off. I think he like went off on a tangent. For a second.
By using not repeat, but forever. Let me move this in here. So now the cat's going to be told when the green flag is clicked, just forever, if touching, if touching, if touching. Oh, meow, when actually touched. So now if I zoom out and hit play, nothing's.
Yeah,
And
that's I was
underscore
confused
sweep says, "Oh,
too.
forever is a
And then I
block."
see like, oh, it's a block. That's the loop. It's just said forever. While true.
N underscore sweep says it's Scratch's name for a while true loop.
While forever. It's amazing.
Happening. I don't have to wait any number of seconds, but when I do touch the cat. Fan section here, thank you. So now it's actually working.
I think my favorite part in this lecture, by the way, I don't think you were there when this happened, but is he just did like something really basic. No, you should have seen earlier. He had the cat, like it was like click the flag.
Says applause LUL.
Yeah, click the flag, and then it's like there was a block that says like cat says hello, and then everyone like burst into applause, and he's like, oh, well, thanks, but it wasn't really like that intensive. He's like, I barely did anything.
Quite.
It really was funny, but it made me feel like, wow.
N underscore sweep says ha 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 ha, that's hilarious.
Like, imagine if every time I put a semicolon or made a parenthesis, people were, you know, burst into applause. It'd be like, yes, thank you, thank you.
Well, so there we have sort of a logical bug, but it does make sense if you think about what it was you told the computer to actually do. Well, let's make things even more interesting by using one of these extensions. In this bottom left corner, this is how I got to text-to-speech earlier. Let me go to video sensing over here too, and I can actually, there we go, literally the video has come on. Let me go ahead and do this, get rid of this code, and let me step out of the frame. When video motion is greater than, well, this is CS50, so let's just type in 50, which is just a measure of motion. Let me go and play sound meow. Okay, and let me stop and restart. All right, so there's the cat. Okay, it worked. The cat's a little insensitive. There.
Really good summer bears.
N underscore sweep says, that being said, it's really good to celebrate beginners making small improvements. I get amped about fixing bugs with my students.
Do you teach on the side too? Like as, in addition to contract work?
There we go. Actually, you know what? Maybe it's just. Let me put. Let's see.
N underscore sweep says,
God.
yeah,
Oh,
I
it's
teach
okay.
privately.
Oh, that's so cool.
There we go. All right. Let me put. Let's see. 20. Oh my God. Oh, it's okay. There we go.
Do you ever
All
get
right.
students who are like really advanced? You said privately, so maybe it's like, just like lots of different kinds of people looking for help. Do you ever get anyone who's like, yeah, very advanced, but they're just like looking for like specific help with very specific things, like with their projects? Oh, okay.
N underscore sweep says, sometimes accomplished programmers who want to learn data science tools and stuff.
Get drunk. Oh, T. Carcass, you look at students' code too. You also teach or help students? Like, whoa, it's awesome. Oh, and Linux. Oh, I don't even know what Vim is. I feel like I've heard it.
N_sweep says at Tkarkas I don't work for a university or anything, so I don't have lots to look over LUL.
Hmm. That's pretty cool. I bet, since you help teach people, I bet you know some of like the best resources for different things. If you have anything really good that you'd recommend, I'd love to hear what you have, or like just like a favorite website or a favorite book. I'm always trying to collect more things. And same for you, T Carcass. Automate the boring stuff. Okay.
N_sweep says my favorite book for learners is Automate the Boring Stuff.
Cool. I do have that book from a Humble Bundle, so I just never like actually used it. Like opened it up and tried reading it. That's probably something I should do.
There we go. So now it's a little more sensitive to the petting by using the camera. Now this is kind of a weird example, and if I just start moving around crazily, like it's just going to meow incessantly, which is what was happening. Okay, when in doubt, this is when you reload the page.
N_sweep
All right,
says
so
it will teach you a lot of what you're already learning on exorcism.
Oh, okay. Cool. By the way, do you have any thoughts on Sweep? Oh, I don't know if you answered this and I missed it because TTS didn't read it, but do you have any thoughts on like what about like leet code? You know, people talk about that all the time. I ended up going on exorcism because I heard leet code can be kind of hard.
Garcus
Ooh,
says
quest
I do
lectures.
quest lectures and optional classes on advanced concepts.
Oh, that's what you do with teaching. Oh, cool. I don't know what quest is. Is that a language?
So now we're back to where we wanted to be. But where can we now use these kinds of building blocks? Like we were doing such tiny little programs, but even that, like we could turn into a whole game, I bet. Could we get like one volunteer to come on up? One volunteer? Everyone's like looking down. How about, okay, on the end here, come on down. Yeah. All right, round of applause for our one brave volunteer here. All right. These Super Mario cookies are on the line for you, depending on how this goes. So I'm going to have you come over here and in advance on Scratch's web.
If you want to get a job at whatever Fong is called now, or if you need
Oh, yeah.
to study algos, leet code is good.
Ah. But for all around learning. I see. I think the hardest, maybe one of like the hardest parts is like just knowing. I think it's like easier maybe with something like if you want to make games like Unity and stuff, but if you're just learning like a language outside of that, like the thing I had a hard time with kind of is just knowing like what projects to do, especially when you're a beginner and you don't know very much, like what's appropriate and not too large in scale or scope or whatever, so that you like get frustrated and can't finish it.
N_sweep
Oh, but
says
later you're
thinking
never
of
able to stop
projects at
thinking.
first is hard. Later you will never be able to stop thinking of projects.
Yeah, and then that's where the real joy comes in, the real fun and the beauty of programs, when you can actually like make the things, anything that you think of. That's the dream. It's cool.
Site. We have some cookies are on the line. Brave volunteer here.
I also heard too from a friend who learned programming that
Garcus says current one is on graphs.
hours.
Last task was about disjoint paths and
That's funny.
minconst/maxflow. All the solutions should run in a few seconds on my machine, but some of the submissions take hours to run due to how inefficient they are.
Yeah, one of my friends says that like they learn mainly by like reading other people's code and like messing with it. Like, that was a huge part of their learning, is seeing how other people do it rather than starting just from trying to make something, so that they could learn the syntax and learn how each part of the code works.
N_sweep says at Tkarkas LUL brutal.
Are you really forced to run the code if it takes hours? Isn't there like a time limit? Like, if it processes for longer than such and such minutes, you fail.
N_sweep says reading others' code is a very good skill.
Work on team.
N_sweep says especially for if / when you work on a team in the future.
I really like, it's funny because, like, in school, when I was, like, in school, I never liked group projects, but I like the idea of working in a team for coding, even though I don't really like most group things. Just the idea of, like, being able to learn from other people and see how other people solve problems. Like, that's why I'm here on Twitch. Like, I want feedback. I want to see how other people do things.
Me
and it's
says
fun.
A team of slackers.
Oh, I guess that's actually, yeah. You're right. It's partially because everyone, like, so many people just don't want to be a part of it.
All right. The Super Mario cookies are on the line for you, depending on how this goes. So I'm going to have you come over here, and in advance, on Scratch's website, we have some pre-made games, one of them written by one of your predecessors, a former student, that they implemented this sort of whack-a-mole game. So what you're about to see is the camera turn on you, and you're going to see 4 moles, above, below, left, and right, and using only your head, up, down, left, right, the goal is to whack...
Dude, she volunteered for this, and now she has to do this. She probably didn't even realize what she was volunteering for. This is why you don't volunteer. And now she's on the internet, record it in the lecture. I'm sorry, but you and her face
Marcus says for the longer ones, I pass them to my other machine and leave it running on the background. While run times that long is a fail, I still want to see what the output is going to be.
Sometimes that long is a fail. Oh, that's nice of you to, like, see it through to the end. But what if someone's code is, like, correct? Like, it's proper and they solve the problem, but the problem won't be solved until the heat death of the universe. Do they still pass? But yeah, this girl's face, she's like, why did I don't know, I just feel like she's like, why did I volunteer for this? Because that's how I would feel.
A mole to get a point every time your head touches one of these sprites. So you're about to see things get very interesting very quickly, but using these building blocks, just those simple blocks, but have 4 sprites, not 4 cats, but 4 moles in this case, we can actually turn these into actual games. So here we go. Beginner. Okay.
What did that say? Get some head exercise?
N_sweep says my guess is it would be wrong because the algo is implemented wrong LUL.
Oh, okay. Punch me by moving your head.
So here we go. Beginner. Okay. You just need to center your head first. Nice. 10 seconds. Nice. 2 seconds. All right, a round of applause. Thank you. You want to introduce yourself?
Hi, everybody. My name is Vanilla. I'm first year, and I'm going to be majoring in computer science and economics.
Nice to meet you. Here we go. Thank you. So we won't look at the code for that actual game. It was written by one of your predecessors, and you can see it online if curious, but you can think about now with our functions, conditionals, Boolean expressions, loops, how you can kind of compose that kind of program. So odds are there was a loop that was just constantly listening for that kind of connectivity, or it was one of those extensions that was waiting for motion to go touch one of those sprites. Notice that there's these numbers.
It was playing rave music, and she was bobbing around.
N_sweep says the RAVE music was great.
Not only did they make her go through what they made her go through, but they played rave music while she was doing it. That's great. Oh my god.
numbers up here, and we haven't talked about this yet, but just like in math, where you can have variables, x and y and z, in programming, you can create variables using other puzzle pieces in Scratch that just keep track of how many seconds are left. That keep track of
I think maybe one of the funnier parts is too is like he could have just done this himself, but he made his student do it, and he didn't tell them what they were gonna do before they raised their hand to participate. If he was like, "Oh, does anyone want to play this whack-a-mole game?" Who raise and have them raise their hand, maybe no one would have volunteered. So it's funny.
how many times her head hit one of the moles, and so you can implement the mechanics of games using very simple building blocks. But how do you go about building something that's more interesting and interactive like that? Let me go ahead and bring up, for instance, one of the very first things I wrote years ago when I was in graduate school, and Scratch had just come out. I was taking a class at MIT's Media Lab, and they invited us to beta test, that is, try out the software before grabbing the
Oh wait,
head hit.
I'm gonna go back a little and slow it down because he is telling like a story about, you know, himself. So I want to hear what he says.
One of the moles, and so you can implement the mechanics of games using very simple build. Let me go ahead and bring up, for instance, one of the very first things I wrote years ago when I was in graduate school, and Scratch had just come out. I was taking a class at MIT's Media Lab, and they invited us to beta test, that is, try out the software before it then became part of the world. And the game I made was this one here. Let me find the right version of Oscar Time. So Oscar Time is a game that took me tens of hours probably in the end. It was a little bit addictive, but let me go ahead and full screen it, and I won't play the whole game, but it looked a little something like this. Where trash.
Oh my god, copyright. Is there subtitles? How could he do this? Alright.
N_sweep says, oh man, good catch, ha ha ha.
I know. Well, he's catching the trash, and I'm just like, oh yeah, yeah. Gotta, yeah, yeah. Shoo, piece of trash.
Garcus says part of writing an algo is getting it to run in reasonable time. Correct output for something like the most optimal train pathing in a rail network is not very useful if it takes 2 hours to find it, while dispatcher needs it to be close to real time.
Yeah, I see. Maybe I was like not paying enough attention, but why was he like describing each item of trash as if we can't see? Or was he saying that the sneaker's not trash? I'm actually not sure. Okay, wait, is it over? The copyright? Maybe not. It's still playing.
Here, even though our examples thus far are just...
Well, not really. Wait, is this normal speed? It's a lot harder to... I missed the audio. It's a lot harder to pay attention when I have to actually read it. Ah, got you. Thank you. Thank you for visiting.
N_sweep says, nice chatting as usual.
Always nice
Gonna
to see
get
you.
some work done before my
Hey,
meetings
and thank
start.
you. Thanks so much for helping me out with Python. I was working on those things earlier. I appreciate it. Get a lot of work done. Good luck with your meetings. I heard in tech there's like constant meetings. Well, sometimes.
N_sweep says, happy to help.
Like there's all this stuff they do, like agile and stuff that ends up like people have like meetings all the time. I don't think I'd enjoy that, but yeah. My God. I don't know. This just sounds.
N_sweep says, when I was full-time, meetings were ridiculous.
Gilbert, that's cool. So every time they do that, you're like get more money. They force you to come to a meeting. But yeah. I don't think I would like constant back-to-back meetings and with people all the time. It would be really annoying. I also heard about like how programmers sometimes don't get along with UX designers, and it can be annoying to
N_sweep
communicate.
says good morning. Get some sleep, LUL.
Ah, thank you. Good morning to you. Have a great day. Like, your day just got started, so, make it a good one. And don't forget to, do plenty of hugs, to your wife and everything, too. Alright. See you next time.
N_sweep says you too. See you next time.
See you. Toggling between them. Oh, they're just gonna raise the volume. Why does it keep having them raise the volume? There we go.
Let me go ahead and consider how I went about implementing that from the get-go. So I will...
Oh no, another one. Oh, let me look at what he did. Huh. If I full screen the video, I wonder if it full screens too in OBS. Wait, I think full screen and then look. Oh yeah, it does. Cool. Oh. Is it still playing? Music?
Number one.
Oh no.
This idea. I changed Oscar's costume, his appearance, to be just number one, which was one of the images I imported into the program. And then I forever did this. If Oscar is touching the mouse pointer, then change Oscar's costume to number two, otherwise change it back to one. So it's super simple animation. I'm just toggling between lid up, lid down, but it kind of feels interactive. And if I wanted to really make this pretty, I could have like 30 different costumes where the lid is ever so slightly higher. Then it would look even more like a movie or fluid motion. But this was enough to get the job done. Which is to say, I didn't try to implement all of Oscar time together. I just took a second baby step toward my goal. And then my next version of Oscar time might have looked a little something like this, where now the trash, there's more going on here. Let's look at two of these blocks of code. The first thing I did was I enabled drag mode to draggable, and I had to Google to figure this out because otherwise it didn't let me drag the trash while playing the game. But once I figured that out, I tell the trash to go to a random x coordinate between 0 and 240 from left to right, and then the y location 180, because I always want the trash falling from the sky. And then what do? I told the trash to forever change its y coordinate, its vertical coordinate, by -1, -1, -1, so like 1 pixel at a time, which creates the illusion of it falling from the sky. But I needed to do one other thing, and let me scroll up. Each of your sprites can have multiple programs, multiple scripts, so to speak, that are not attached to one another. They will happen in parallel for you. The second one is saying this: forever, if the trash is touching Oscar, what should it do? Go to a completely different x and y location at the very top. Why? Well, as soon as I drag the trash over the Oscar, I want it to disappear as though it's going into the can.
An Oscar is a trash can?
As soon as I drag
Oh, wait, maybe it's the character.
the trash over the Oscar, I want it to disappear as though it's going into the can, and I then want it to reappear at the top, so more trash falls. So I just thought about, like, what would it mean for the trash to go into the trash can? Well, who cares? What really matters to the human user is that it just disappears and teleports elsewhere. And so that's the idea I implemented here. So if you can reduce sort of intuitive ideas to just basic building blocks like this, you can start to make things much more interactive. And lastly, if I look at this version here, you'll see that we've combined these. And so indeed, if I actually go ahead and play this now, not only is it falling, I can let it fall right on top of Oscar and watch it disappear. But notice, Oscar doesn't pop out yet because that was the fourth version, and then the fifth version, and then I added the annoying music and so forth, but sort of compose this program step by step by step so as to accomplish my larger goal. And this is going to be true of all of the code you write, be it in Scratch or C or Python or the like, trying to come up with, or rather trying to reduce your ideas, your grand vision, to just baby steps, building blocks, so that you start with version 1 and maybe you submit version 10 or 20. But you don't try to implement version 10 or 20 at the get-go. You take those incremental steps. All right, how about one other? Well, let me propose this. Let me go ahead and open 3 games that represent one that your predecessors also implemented, which looks a little something like this in version 0. Suppose I wanted to implement a game that simply has these kinds of mechanics. I'm touching my arrow keys on my keyboard, up, down, left, and right, and I'm moving the Harvard logo. Let me zoom in a bit. So if I hit the up arrow, the Harvard shield goes up. If I hit the down arrow, the shield goes down. If I go all the way to the left, it goes left until it hits the wall, and same thing on the right. So this is like the beginnings of a game or a beginning of a maze, something like that. Well, how might I implement this? Well, let me look inside this one, and there's a lot going on, but again, I sort of took simple steps. Notice that I've got 3 sprites: a left wall, which is just a straight line, the right wall, which is a straight line, and just intuitively, why did I implement those as sprites? Why do they need to exist as entities themselves? Yeah, in front. Yeah, I wanted to interact with the shield, so I need to be able to ask that Boolean expression, like not touching mouse pointer, but touching shield, for instance, a different type of yes-no question. And so what is the code for the shield actually doing? Well, there's a lot of duplication, and let me focus on the abstraction first. Notice that I've got this when green flag clicked, I want the shield to go dead center, 0, 0.
I think about this.
I've got this So when green flag clicked, I want the shield to go dead center, 0, 0, and then forever listen for the human's keyboard and feel for the wall. So I decided to implement my own pink puzzle pieces that implemented 2 separate ideas. One, just listen for the keyboard, up, down, left, right, and then do something. And then feel for walls is this idea of whenever I go up, down, left, or right, if I touch a wall, I need to stop doing whatever the keystrokes are telling me to do. So now if we dive into those implementation details, listen and feel are abstractions, custom puzzle pieces. Let's look at the implementation details. Well, here's the keyboard. If the key arrow up is pressed, change Y by 1. If key down arrow is pressed, change Y by -1. And you can probably see where this is going. Right arrow is X by 1. Left arrow is X by -1. And that's sort of all that's involved with up, down, left, right. But wait a minute. Why is there no loop in this listen for keyboard puzzle piece? I needed a loop last time, so it constantly works. Exactly. I put the loop in my main part of my program up top, so something is telling me to keep listening again and again. So it's got to be somewhere, but it doesn't have to be in the actual implementation. And lastly, how about this feel for walls? Well, if touching left wall, which is just another sprite, change X by 1. So that is to say, if I'm touching the left wall, I want to kind of bounce it back the other direction. And same thing on the right wall. If I'm touching the right wall, I want to bounce it back to the left, which effectively means that even if the human's hitting the key, it's like fighting with this code, but it's never going to go through the wall based on that math. It's going to stop it right there. All right, let's add something else to the mix. Suppose I want the game to change to be a little something like this, where Yale is some kind of block in between me and like the exit. So some dramatic, race here. Okay, I just got by. But the Yale logo doesn't seem to be doing all that much except bouncing. So I'm guessing there's a loop, maybe a conditional, like checking for those walls too. So let's go ahead and zoom out, see inside. Let's not worry about Harvard because it's pretty much the same. Let's look at the Yale puzzle pieces. And sure enough, go to the middle, 0, 0, point in direction 90, so point horizontally on the grid. And then if touching left wall or touching right wall, I'm kind of cheating this time, but cleverly, just spin around and do 180, so you effectively bounce off the wall. This just tightened up my code. I don't need to do the -1 or the +1. I just say bounce in this form of code. Otherwise...
Oh, that's interesting. Oh wait, that makes sense. It's just 180 degrees is turning direction, changing direction. Right? Is it? Wouldn't it be upside down though?
I don't need left wall, direction. It just got by.
Oh no, it doesn't.
But the Yale logo doesn't seem to be doing all walls the same. Let's look at the Yale puzzle.
I'm kind of not sure why the Y doesn't like end up looking like it's upside down. Turn. Sure.
Pieces, and sure enough, go to the middle, 0, 0, point in direction 90, so point horizontally on the grid, and then if touching left wall or touching right wall, I'm kind of cheating this time, but cleverly, just spin around and do 180, so you effectively bounce off the wall. This just tightened up my code. I don't need to do the -1 or the +1. I just say bounce in this form of code. Otherwise, just constantly move one step. Now, if this is a game where Yale is supposed to be better and faster, well, let's change the 1 to 5. Move 5 pixels at a time. And let's move it 10 back and forth. Let's maybe 100. Uh-oh. So what just happened? That is a bug, which we can avoid.
I'm still thinking about why the Y doesn't flip. I guess it's because it's like only is about the motion, not about the rotation of the sprite. Oh, so 180 degrees would be just the, I guess, the opposite direction. I guess 360 degrees would be like the same direction something is going.
Be 100. Uh-oh. So what just happened? That is a bug, which we can avoid by just not doing that. But why did it break out of the wall? Yeah. Exactly. Because I'm doing 100 steps at a time, I'm never actually touching the other sprite because I'm sort of stepping way over it. So there's never a moment where they're actually touching. So previously, I was just getting lucky by doing fewer steps because it's gradually going over the wall, which gives me just enough time to detect as much. So I would have to kind of tinker and handle this a little bit differently. So it's a bug if it's too fast, but at least if I keep it slow and reasonable, the math actually does work out, so long as it starts again in the middle. Well, let's do one final flourish here, whereby let's bring MIT into the mix, right? They're super smart, so maybe they can kind of track us and follow wherever I'm going. So how might this work? All right, so nothing happens yet because we haven't finished composing the game. And notice here, okay, now MIT is struggling. Like, it's kind of twitching there because it's going just above, then below, then above and below. So we could fix that too if we want, but that's just a function of my math, 1 pixel at a time. Let me open up this one, see inside, and click on MIT. And, you know, it doesn't take much to implement MIT, it seems. So go to random position, forever, point towards the Harvard logo outline, aka the shield, and then move 1 step. So if I wanted to make MIT even smarter, even faster, what do I change here? Yeah, change 1 step to like 2 steps to double their speed, or 5 steps, 10 steps, or 100 steps, and the game's going to be over like that. But that's all it takes to now make these 5 steps. So if I wanted to make MIT even smarter, even faster, what do I change here? Yeah, change 1 step to like 2 steps to double their speed, or 5 steps, 10 steps, or 100 steps, and the game's going to be over like that. But that's all it takes to now make these kinds of elements. So if you are a game player on your phone or consoles or computer or whatever, if you think about almost any game, you can probably now start to think about how they implemented those mechanics, because it's just being reduced to functions, conditionals, loops, variables, and the like in this case. So let's go ahead here and have maybe one final volunteer. We've got one more bag of Oreos here. Okay, that was super fast. Do you want to come on up? All right, brave volunteer, come on up. All right, let me find the full-fledged version of this that one of your predecessors made. And let me get the right one. Okay, here we go. We'll see some instructions on the screen in just a moment. And when we hit play, you'll see that the mechanics are all combined now into one full-fledged game. But first, an introduction. It's on.
Hi everyone, I'm Sam. I live in Apricot. I'm a freshman and I'm from Nepal.
All right, welcome to the stage. All right, so here we go. Yep, go ahead and click the green flag.
You can't touch this.
Oh my god.
So you see the grid is just bigger this
Dude,
time.
I can't. My mouse.
You can't
Okay,
touch
here.
this.
I'm sad now. I was like, no way they're gonna put in copyright music. Why? Why? Why did my pause not work? It's actually a really cute little game.
These light bulbs, and I'm wondering if you divide 64 by 8, that's 8 bytes of light bulbs, and we now have some Unicode in our vocabulary, so might very well be the case that we've been spelling something out on the stage here for you all of this time. But before we adjourn for cake to be served in the transcript, allow me to introduce some of CS50's human friends.
What does transept mean? Oh. Okay.
The Harvard Crocodillos and the Radcliffe Pitches to give us introduce some of CS50's human friends, the Harvard Crocodillos and the Radcliffe Pitches to give us this exciting ending. This is CS50.
Oh my god, please don't sing. Yep. He's gonna copyright. He's gonna sing. No.
Good afternoon, CS50. We are the Harvard Crocodillos, Harvard's oldest a cappella group, founded way back in 1946 at the historic Casey Pudding Club. We'd love to make a big thank you to CS50 staff and to David Malin for having us perform here at Sanders Theater. And if you enjoy this performance, please come audition for us this weekend at Farkas Hall.
Hello, everyone. We are some of the Radcliffe Pitches, and we are also hosting auditions this weekend. You can find more information at
Oh wait, she's gonna talk first.
See you next time.
What do these look like? I think this is just the same stuff that was in the lecture. Cool. Nice. I'll be right back. Okay, I think I should watch a little bit of this because I am starting to get tired. Precision.
So this is CS50, and this is week 1, 0 index, so to speak. And it's not every day that you can say that you've learned a new language, but today is that day. Today we explore a more traditional and older language called C. And rest assured that even if what you're about to see, no pun intended, looks very cryptic, very unusual, particularly if you're among those less comfortable, cling to the ideas from last week, week 0, wherein we talked about some of those fundamentals of functions and loops and conditionals, all of which are coming back today. Indeed, whereas last week, and with Problem Set 0, we focused on learning how to program with Scratch, which again, you might have played with as a younger student days back. Today, we focus on C instead. But along the way, we're going to focus, as always, frankly, on learning how to solve problems. But among the goals for today, and really on an entire class like this, is just to give you, week after week, all the more tools for your toolkit, so to speak, via which to do exactly that. So for instance, today, we'll learn how to solve problems all the more so with functions, as per last week. We'll do the same with variables. We'll do the same with conditionals, with loops, and with more. But we'll also learn, at the end of today's class, really how not to solve problems. It turns out as powerful as Macs, PCs, cell phones are nowadays, there's actually certain things that they can't do very well, and the information they can't represent very well, and that actually leads to a lot of real world problems, both past and surely future. So more on what we're not going to be able to do with programming before long. But beyond that, let's come back to this picture here. So this was the very first program that I wrote, that you wrote, presumably in some form, and all it does is say hello world. But as promised, today, this puzzle piece, or these puzzle pieces together, are going to very quickly start to look more like this. And I've deliberately color-coded it in a way so that the text on the screen now kind of resembles the puzzle piece. So if I go back, notice that we had this when green flag clicked puzzle piece, mostly in yellow with the green flag, that sort of kicks off the whole process once you actually click the button at top right of Scratch's user interface. And then there's the purple block, which actually is the verb, the action, the function that does something. So if I bring us back over to what we're about to see today, there's going to be some boilerplate, so to speak, some orange text here on the screen that for now you just kind of type and take for granted, like you need to write your code like that. But more interesting is going to be the purple. And we're going to see today that the function previously called say in Scratch is now called printf in this language called C. But in white here, you'll see similar text to our white oval last week, whereby that's where user input, like your input as the programmer, can actually go. So there's a lot of distraction, and honestly, it's these kinds of things that tend to distract and get frustrating early on when learning to code for the first time. But the ideas, most importantly, are going to be the same. So how are we going to go about using this? Well, it turns out, like last week, you're going to start writing something called source code. So code as we know it, quote unquote, is more technically called source code. That's what you and I as humans actually write. And indeed, it might look a little something like we just saw. But unfortunately, computers only speak this binary, zeros and ones, more properly known as machine code. In other words, those same patterns of zeros and ones, last week, someone guessed print out hello world on the screen, because one of those patterns is an H, another pattern is an E, an L, an L, and an O, and so forth. And then other patterns of those zeros and ones are commands or instructions to the computer that literally say, show HELLO, comma, world on the screen. But machine code would not be nearly as much fun to write if it were indeed in zeros and ones entirely for us. Ideally, you and I are going to write source code, which conceptually is sort of up here, high level, but we're going to need a program to convert it to the lower level machine code so that we don't spend our lives actually having to read and write zeros and ones, which back in the day, kind of in yesteryear, you kind of sort of did with things called punch cards and holes on physical sheets of paper. We're beyond that, because after years and years of innovation, folks have given us higher level languages instead. So here's what we're going to need to do today. If at the end of the day, you and I are writing source code, but we want machine code as output, we need something in the middle that's going to convert that source code to machine code. You and I are not going to have to learn or talk about really anymore zeros and ones. And the type of program we're going to start using today and introduce you to is called a compiler. So a compiler is a program that translates one language to another. And it can be any two languages, but today and often we'll talk about it in the context of source code to machine code. So this is Apple or Google or Microsoft or folks from other companies or even volunteers who have written software that do this conversion. You and I are essentially going to download a free compiler and use it to actually get our computer to understand the source code that you and I write in these higher level languages. So where are we going to do that? Well, we could actually give you instructions and you could download the appropriate free open source software onto your own Mac or PC. The reality is that creates so many technical support headaches because we all have slightly different computers. We all have slightly different versions of Windows or Mac OS or Linux or other operating systems. And that too tends to be a distraction at the beginning of any course like this or learning programming. So we're going to use the cloud instead. We're going to use a URL of the form https://cs50.dev. And what this will do for you is put inside of your browser window absolutely everything you need for the course, but it's going to use software called Visual Studio Code, otherwise known as VS Code, that's actually free itself. It's very popular in industry. It's what real programmers use every day, but it's a cloud-based version thereof. And so everything will just work for you out of the box, but toward the end of CS50, the goal is going to be to get you off of CS50's infrastructure, to get you to download this freely available software onto your own Mac or PC if you so choose, so that those training wheels, so to speak, can come off. And then even if you never take another class again, you don't need any classes infrastructure moving forward. You'll have everything you want and need on your own Mac or PC. But for now, it'll save us a bit of time. So in just a bit, I'm going to go to that URL myself on my computer, and I and you will see a user interface that looks a little something like this. The colors might be different based on your settings, fonts might be different and so forth, but in general, it consists of a few different regions. So over here at the top is where we are going to start writing code today. So it's a tabbed interface, like any number of programs nowadays, and this is that same C code we saw a moment ago. So this is where, in a moment, I'm going to start to type it. Over here at the bottom is what we're going to call a terminal window, or a console. And the terminal window is where we're going to type commands for compiling our code, for running our code. And we'll see today a contrast between a graphical user interface, or GUI, which has menus and icons and things you click and are very familiar with, versus a command line interface, or CLI. And so we're using both of these together, and command line interface just means down here, you only use your keyboard. You can click, click, click if you want with your mouse. It's not going to generally do much because a command line interface takes commands at the keyboard. So in a weird sense, it's going to feel like taking a step backwards from the Macs, the PCs, the iPhones, and Android phones we all have, which are very graphical. But it turns out once you become a computer person or a programmer, you can be a lot more productive, a lot more efficient, I dare say, by learning to harness a command line interface and using both types of interfaces for what each is good at. So more on that in just a bit. Over here at left, you're going to see soon a folder interface like Mac OS or Windows, where any of the files or folders we create in CS50 are going to end up as well. So it gives you sort of the best of both worlds. You can point and click on the left, or you can type commands at the bottom, as we'll soon see. And then along here is the so-called activity bar, where there's just VS Code specific features, but also CS50 specific features. And if you're in your own version of CS50.dev, you click through in the ... menu or zoom out so you can see everything. You'll see CS50's own rubber duck, virtually speaking, that will be there throughout the course to answer any and all of your questions as well. So more on that soon too. So here's the code that I propose that we write first, just like we wrote our very first Scratch program to say hello world. So let's go ahead and do exactly this. I'm going to switch over to this screen here where I've already logged into cs50.dev on my computer. And just to keep the focus on the code, I've hidden the activity bar. I've hidden the file explorer, so to speak. So you're seeing here the area where all of my tabs are about to go, and the terminal window where all of my commands are going to go. But I've just simplified the UI to keep our focus on the interesting parts for now. So how do I go about actually writing and compiling? And so how go? But I've just area where all of my I've hidden the file explorer, so to speak. So you're seeing here the area where all of my tabs are about to go, and the terminal window where all of my commands are going to go. But I've just simplified the UI to keep our focus on the interesting parts for now. So how do I go about actually writing and compiling and running some code? Well, the teaser is going to be these 3 steps. One of these is a command called aptly code, and code is just going to let me to open or create a new file, like a file called hello.c. Make is going to be, for now, my compiler that allows me to make the program, that is, convert source code into machine code, so from C to zeros and ones. And then weirdly, but we'll soon see why, ./hello is going to be the command to run my actual code. So the textual equivalent of like double-clicking on a Mac or a PC icon or tapping an icon on your phone. So that's it. These 3 commands are going to allow me to write, to compile, and to run code ultimately. So let's go ahead and do that. I'm back in my VS Code interface. I'm going to go ahead and run code hello.c, and notice a couple of details here. So one, there's this weird $sign, which has nothing to do with currency, but it's just a common convention in the programming world to represent your prompt. So if I ever say go to your prompt, we really mean go to your terminal window, go to the $sign, and the $sign is where you type the command. Sometimes it's a different symbol, but a $sign is conventional. Now that I've typed code space hello.c, I'm going to go ahead and hit enter, and maybe not surprisingly, this gives me a brand new tab, a new file, if you will, called hello.c, and just like Word documents have their own file extension, like docx, and Excel files have .xlsx, and PDFs have .pdf, and GIFs have .gif, and so forth, so do C files have a file extension by convention that is .c. Now, a couple of minor points. Notice that by convention, I'm almost always going to name my files in lowercase. By convention, I'm never going to use spaces in my file names, and my file extension 2 is going to be lowercase. Long story short, accidentally hitting the spacebar or using file names with spaces just tends to make life harder when you're in a command line environment. So just beware, silly, stupid things like that. So all lowercase, no spaces for now. So my cursor is literally blinking because the program wants me to write some code. I'm going to do this for memory. It'll take you presumably some time to acquire the same instincts, but I'm going to go ahead and type this first line here, pronounced include standard io.h. More on that soon. Int main void, with some parentheses thrown in. Notice what's about to happen here is a little interesting. In the code I want to type, I want what we'll call curly braces, the sort of squiggles that you don't use often in English at least, but are there on your keyboard somewhere. But notice what VS Code does, and a lot of programming environments, is it finishes part of my thought. So I'm only going to type a left curly brace, but notice I actually get 2 of them. And if I hit enter, notice that not only does it scooch one down a bit, it also indents my cursor, because just like with pseudocode last week, whenever you're doing something logically that should only happen if the thing above it happens, similarly is indentation going to be a thing when we actually write code. So VS Code and programs like it just try to save us keystrokes so I don't when we actually happen if the thing above it happens. Similarly is indentation going to be a thing when we actually write code. So VS Code and programs like it just try to save us keystrokes so I don't have to waste time like hitting the spacebar or hitting tab or sort of wasting my human time like that. All right. So with that said, I'm going to go ahead and type the last of these lines, print f, where the f is going to mean formatted, and then a parenthesis, and notice it gave me 2. So and if I hit enter, notice that not only whenever you push one down a bit, it also indents my cursor, because just like with pseudocode last week, whenever you're doing something logically that should only happen if the thing above it happens, similarly is indentation going to be a thing when we actually write code. So that's it. And then a parenthesis, and notice it print f, where the f is going to mean formatted, and then a parenthesis, and notice it gave me 2. It gave me the second one for free. Sometimes it will get confused, and you can certainly override this, delete it, and start over. And now, unlike Scratch, in C, it turns out I'm going to need to use double quotes anytime I'm using an English word or phrase, or any human language for that matter. Hello, comma, world, and then at the very end of my line, much like English uses periods, I'm going to use a semicolon in C. So that's a lot of talking, but it's not much coding. It's technically 6 lines of code, but honestly, the only interesting one intellectually, as we'll soon see, is really line 5. Like, that is the equivalent of that say block. Now, here's where I'll cross my fingers. Line 5 of code. So that's a lot of talking, but it's not much coding. It's technically 6 lines of code, but honestly, the only interesting one intellectually, as we'll soon see, is really line 5. Like, that is the equivalent of that say block. Now, here's where I'll cross my fingers, hoping that I didn't make any typographical errors. It's going to automatically save for me, and I'm going to go back to my terminal window, where now
I'm going to bed now. Stayed up too late. But if anyone's there, see you later.